students, good afternoon. Right, good afternoon, everyone. Let us have the revision of yesterday's topic, that is potentiometer. Right. So in that, few people asked the doubts. I clarified, but still, I hope one or two students not satisfied. Right, that's why I'm giving the explanation again. Kindly concentrate here. First of all, I told you one simple point here. Yesterday, one student asked that you guys see, I think. I'm revising my kindly concentrate here. Between these 2 points, which one known EMF I have connected? Okay. Between these 2 points, I have connected unknown EMF. Okay. Right. If only known EMF is directly available, let me take 10 volt. The moment X is being connected, if means X is connected in the circuit, if galvanometer shows 0, if galvanometer shows 0, then what does it mean? The unknown EMF X is equal to 10 volt. This is a basic point I gave you. Okay. So why I gave you this point, kindly concentrate. In this entire instrument, there is no instrument in which the pointer is moving and showing the 2, showing the 3, that type of thing is not there. Today class is given only 4 hours. So is the class, 1 second. Let me check. No, yeah, actually class is up 2 to 8:30 only. 2 to 8:30, yeah, 2 to 8:30. It is showing, see, 2 to 8:30 only. Right, see. No, yeah, 2 to 8:30. Okay, right. See, in this entire instrument, why I have taken this introduction, the point here is, in this entire potentiometer concept, there is no device such that the pointer is moving and showing the corresponding 2, 3, 4, etc. That type of facility is not there in this. That's why the concentration is which one here? Unknown is compared with respect to known value. That is null deflection concept I told you. Okay, right. After that, suppose I have connected Y. For example, I have connected Y. If Y is connected, if the galvanometer is not showing 0, if the galvanometer is not showing 0, then what is the value of X in this circuit? We cannot guess it. Why? If Y is not Y is connected, if the galvanometer is not showing 0, means Y may be greater than 10 or less than 10. Anything is possible. If Y is also equal to 10, it will be showing 0. That's why if under this condition, if Y is given under this condition, the galvanometer is not showing 0. If the galvanometer is not showing 0, how do you find out the X? That is what the main procedure. That's why I have gone to the topic, which one? Basic slide wire DC potentiometer I have taken. Concentrate here. Basic slide wire DC potentiometer. In this, what I have taken, this is the battery supply, some known voltage, some rheostat, okay, right. And this rheostat is for variable purpose in the designing stage. So leave it here. Sir, between A and B, concentrate. I told in the yesterday's class, I explained the doubt session also, but still student may be having small confusion here. Between A and B, right, I am connecting the slide wire where 0, here 1 volt, here 2 volt already determined. How calibration is done? What is that? I is equal to 10 milliampere, R is equal to 200 ohm, length equal to 200 centimeter, like that we have taken. Okay. After calibrating, how much current is flowing through this? 10 milliampere is flowing. 10 milliampere. Kindly concentrate. Here, I am connecting unknown EMF. I am connecting unknown EMF. Okay. Now, which is known EMF here? This is known EMF only. Why? With the help of this entire circuit, we have calibrated this scale so that the corresponding which one here? Yes, EMF across the slide wire is known to us. And here galvanometer is there. Okay. After that, here what you have to do in this entire thing, what is it here? If the galvanometer is not showing zero, if the galvanometer is not showing zero, we don't have any other facility to make zero, because in this variable facility is not there. That's why you created that. Keep it here. Suppose galvanometer is showing zero, which is a known EMF across this. 2 volt is known. So unknown EMF is equal to 2 volt. Suppose it is not showing here. Suppose 1.5 is there. No, it is already known to us because calibration is done already. Suppose I am connecting here. I am connecting here. If the galvanometer shows zero, across is how much voltage is there? That's why unknown is equal to known only. But this is not that known. This is only taken as a battery supply for calibrating the corresponding slide wire. For calibrating the corresponding slide wire. Clear? So that is the reason why we need to concentrate on the actual topic. What is that? First, in this is a basic circuit. Known EMF is there. Unknown EMF is taken. Galvanometer should show zero. If it shows zero, yes, unknown is equal to known. If it is not showing zero, how to determine? That's why we have taken the variable facility. Connect here, like this. Keep on varying all these points. We can get the determination of total value. Clear? At least now it is clear, I think. Yesterday one student asked that, but I understood that it was not clear, I think. Right? So this is the total topic. After that, sir, as the size is large, what you have done? Slide wire of same size but 10 ohm, and here you can keep. See, I have taken like this, but simply you can say like this also as you wish. 10 ohm, 20, 30, 40, 50, anything. But normally says that the dial resistance box type will be taken like this. Right? In this, what is that? Always 10 milliampere is always to be maintained. Resistance is 10. So across this, how much voltage will be there here? 0.1 volt. I am connecting 100 volt. You can measure up to 1.1 volt. Suppose I'm connecting 200 volt. You'll be measuring up to 2 point. That's why range extension purpose we are using this. But full scale value is always same. Full scale value is always same. So this is the total topic we have taken the yesterday's class. Got it, guys? Right? Okay, now. Next, yesterday's homework question. Did I give energy meter question as a homework? Anyone? Just remind me. Energy meter, did I give the question as a homework? Anyone? Okay. Which question? Can you read that? Can you give that word first? Which one? Yeah, 0.9. 130. Yeah. Got it. Got it. Yeah, this one I gave you, right? This is 138 seconds. Right. Ashish, today, sir, what is it? Okay, today. Today 2 to 8:30. Sunday always 2 to 8:30. 6 hours. Okay, right. In this 230 volt, V is 230 volt, I is 10 ampere, and meter constant is 1800 revolutions per kWh. The meter is tested at half load, rated volt. Same thing we have taken already. What is that? half load and rated voltage testing, right? And unity power factor. Right. How many revolutions? 80 revolutions in how much time? 138 seconds. Determine the error. Same discussion as it is. Same question only I can say, but only numerical values are different. Model, everything is same. Right? Concentrate here. Sir, first let me take energy true. What is energy true? V into I into cos phi. Right? So therefore here V into I into cos phi into time. What is V? 230 into current is 10, power factor is 1, time is how much here? 130. Be clear, guys, be clear. People are getting confused here. Sir, if I substitute 138 second, what will be there? This, already told you this. This is in watt second. Okay, I want to convert this into kilowatt second. Few people message me like, sir, 1 by 60, why, etc. I'm giving that. Here, kilowatt. Watts to kilowatt means what is it? 230 into 10 into 1 by 1000 into 138. Okay, now I want to convert this into kilowatt hour. I want to convert this into kilowatt hour. How much? 230 into 10 into 1 by 1000 into 138 seconds to be converted into hours. How much will be there? 3600. So finally, you are getting the energy value. Clear? But sir, what is asking? Energy at half load. I'm coming to it. I'm coming to it. Energy at half load. So automatically, what you have to take here? 5, 5, 5. Clear? Right? Energy at half load. So I'm writing here energy true at half load. Kindly give me the value for this. Yeah, I know. Actually, Vinitha and all kinds of concept. Procedure I gave you. Procedure means I have concentrated on this one because people are getting confused. Like, sir, what is watt hour kilo? That's what I've taken. Now half load. Yes, anyway I've taken. Don't need to worry. I will give you everything. First, I give the normal procedure. That's it. People are giving different answers. Which should I take? Point zero 0.04408 kilowatt hour. Many people give this. Yeah, correct. Okay, right. Okay. Sir, after that, energy measured at half load. Energy measured at half load. What is that energy measured? See, excuse me, 80 revolutions are there. This meter constant is given. So therefore, 1800 revolutions. 1800 revolutions gives 1 kilowatt hour. 80 revolutions gives dash. So therefore, 80 by 1800 into 1 kilowatt hour. What will be there? 0.04444, right? Kilowatt hours. Is it? Yeah. Now finally, same thing. Percentage error at half load. Percentage error at half load equal to energy measured at half load minus energy true at half load by energy true at half load into 100. Can you substitute and tell me? See, I'm facing the problem here only. After giving these two values also, people are giving final answer wrong answer. Why these many different answers? Few people are giving 0.826. Few people are giving 0.819, 0.725. Right, you will be getting 0.816 percent or 0.817. It seems no problem. Is it 0.8 or 0.081? Saicharan, kindly check it here. So answer is, what are the value you are getting? That only the answer. No need to worry. Got it? Right. Sri Gyanarathi. Right. So in the question they said meter tested half load. Did you attend my class yesterday here? See how divided load. Actually, it should be 10 actually, but half load no. So that I'm writing specially like 10 by 2. Load means already I have taken a 5, so 10 by 2. But this is already at half load, so no need to take a half load. Only the full load current is given. Same thing. Yesterday, same model. I solved one more question. Right? Ganarthi, clear it is? Right? That's why I have taken 5 now. You may be getting confused. 10 by 2. Why? 10 is the current, full load current. I made it half, so automatically half load only. Right? That's in yesterday's class also. I have taken 10 by 2 model, but I have written 5 directly. That's it. Right. This is energy meter question. And potentiometer question also I gave you one homework, right? Same question. A basic slide wire potentiometer has a working battery of 3 volts with its negligible internal resistance. Kindly concentrate. Try to draw the diagram always in the potentiometer. Then the things will be very, very simple. 3 volts battery voltage is given. Right. Basic slide wire question. Correct. Right. Basic slide wire question. Okay. Right. Concentrate here. Sir, 3 volts battery is there. Its internal resistance is not there. After that, some rheostat will be there anyway. This is RH. This is battery voltage, simply 3 volts. Okay, now the resistance of the slide wire is 400 ohm. Kindly take the as it is given data. What is this? This is A, this is B. The slide wire resistance is 400 ohm. Check it here. He has taken 200 centimeter. 200 centimeter from here to here. Okay, after that, 200 centimeter scale is placed along the slide wire. Means length scale is there 1, 0, here 100, here 150, 199, 200, like that. Centimeter scale is there. So all these are in centimeters. Okay, after that, the slide wire has 1 mm scale divisions. Okay, what is it? In this each and every, what is it? 1, 2, 3, 4, 5, like that. Some 10, 10, 10, of course, 1 centimeter is 10 mm divisions will be there. After that, this is the data given to confuse you, and it is possible to read up to 1/5 of a division. Means not only 1 mm, in 1 mm, consider here, the slide wire has 1 mm scale division. In 1 mm scale division, we can read up to 1/5 part. That is only idea purpose they have given. Okay, but in this question not required. The instrument is standardized with calibration process with which one? Standard cell 1.018 volt. And here galvanometer is there, and it is being calibrated by keeping the slide wire at which value? 101.8 cm. That's why I told you practical point is like this only. So therefore this is kept at this point. What is that? 101.8 centimeter. 101.8 centimeter mark on the scale. Calculate the working current under this condition. Calculate the working current and resistance of rheostat. Same question we have done in the yesterday's class. 9 ohms we got one answer. Same model. 9 ohms we got it. Same model. But only the lengthy data here to here actually not required. This entire data is not required. From here to here. Actually speaking, from here to here we can say. Not required. But he has given that length scale is given. Each centimeter has 10 mm divisions, and in 1 mm 1/5 part will be measured. Like the other data to confuse it is given. Okay, now first point here, what is that? It is already standardized by keeping it. This means the galvanometer is showing 0, isn't it? Therefore 1.018 is appeared across this. 1.018 volt is appeared across this. Clear? Right? So therefore, what we can write now? Therefore, voltage across AC, I'm writing this point as C. Voltage across AC is equal to voltage of standard cell is equal to 1.018 volt. Okay, after that, sir, what is the resistance AC? Concentrate here. Sir, total length is how much? 200. Total resistance is how much? 400. So therefore, so 200 centimeter is giving 400 ohm. So what is the AC length? AC length is 101.8 centimeter. Therefore, 101.8 centimeter dash. 200 centimeter, 400 ohm. 101.8 centimeter dash. Or simply, what we are getting? RAC is equal to, simple here, double length to resistance 2:1 ratio. But I explain 1:1 ratio for clarity purpose. Here, how much will be there? 203.6 ohm. 203.6 ohm. Okay, after that. So therefore, I is equal to, what is it? VAC by RAC. Sir, why? Here, current to through this. Concentrate here. Working current IW. Everyone concentrate. People are getting confused with this also. Sir, IW is coming at this point. It is divided. Is it divided here? No, it will not be divided. Why? Already through this path, current is 0. Why? This is under standardization condition or balanced condition. Therefore, through this only IW is flowing. So therefore, IW equal to VAC by RAC. VAC by RAC. What is VAC? What is VAC here? 1.018 volt by RAC. What is it? 203.6 ohm. 203.6 ohm. If you simplify this, you will be getting 5 milliampere. You're getting 5 milliampere. Okay, now verify. So 5 milli, only one option is there. So blindly, you can say that first option is correct. In this way, you can save the time. But for clarity purpose, I'm giving the corresponding discussion. No need to worry. What is it? Series rheostat, he is asking, sir, in this entire mesh, what is that? Voltage equal to current into resistance plus resistance. So automatically, what is that? V is equal to I into RH plus R slide wire. What is V? 3. What is I? 5 into 10 power minus 3. Okay. RH. What is RH? Unknown. R slide wire. How much? 400 ohms. From this simply RH is equal to, what is it? This is, what is it? 3000 by 5, 600 minus 400 means 200 ohms. Same logic. What we have taken yesterday, 9 ohms question was there. No, same answer here also. Right, correct. Yeah, I mean, we will give that option A. Likita, is it current or resistance? Right, so option A is this 5 milli, 200 ohm. This only I gave the homework question. That's why actually it is revision part only, because already same model we have done. Right, now let us take few more questions. So far we have taken on the slide wire, right? Now let us take the question on Crompton's type. Right. I will do it, no need to worry, I will do this. Right. Concentrate. A Crompton's potentiometer is provided with a dial resistor of having 15 steps of 10 ohm. So what is it? R box or R dial 15 into 10. What is the value? 150 ohm. First write the data like this. Slide wire resistance. All I told you know. Slide wire resistance generally taken as 10 ohm, and he proposed that only. Slide wire is divided into 100 divisions. So totally, how many divisions are there? 100 divisions are there. But be clear, sir, 1/5 of a division, 1/5 of a division can be read with certainly, with certainty means we can say 1/5 of the division can be measured properly. So 1/5 of the division can be measured properly, That's not the point. After that, working current also, kindly check it here, 10 milliampere. Working current also 10 milliampere. The range and resolution, he is asking range and resolution. Here small, there is a chance for having small confusion here. Range means, all I told you, range means, concentrate. This total value is the range, or only the slide where is the range means total value. Why? Range extension, this only means range means total value. Therefore, concentrate here. First one, range is equal to, very, very simple. What is the meaning of range? Concentrate here, everyone. Sir, this is dial resistance box. This is slide wire. Here 10 ohms is there. Here 150 ohm is there. 10 milliamperes is flowing. From here to here, what is the total value? So simply, from here to here is range. Is or no? What is a 10 milliampere into 150 plus 10? So therefore, 10 milliampere into 150 plus 10, 160. 160 and 10, 1600 milli means 1.6 volt. This is the range. All I told you yesterday. What is that? By taking the extra dial resistance box, range can be extended. Range can be extended. Yes, got it. Now resolution, small confusion. Already I clarified this, but I'm revising. So what is the resolution formula? What is the resolution formula? What is the resolution formula? Full scale value. Full scale value by number of divisions. So what is a full scale value? So is it full scale value? No, yeah, it is not full scale. Why? Dial resistance box also being taken. That's why I told you yesterday. Full scale. Where is the scale available? Slide wire available, or this resistance box also? Only slide wire it is there. That's why current through that is 10 milli. Slide wire resistance is 10 ohm. So therefore, point when I told you, no, yes, 10 milliampere, 10 ohm. Sir, how many number of divisions are there? 100. But kindly consider this type of question, same model we have done in the first chapter. That is, error analysis chapter. What is that? Here, 100 divisions, okay. But how much value he is able to measure Perfectly means 1/5 of the division means suppose 1, 2, like this. Divisions are there in this 1, 2, 3, 4, 5. 1/5 of the division they are able to measure. So automatically, what is it here? 500 divisions are there. So totally 0.1 volt by 500. What will be there now? 0.1 by 500. So what will be there here? Simply here 0.2 milli. 0.2 millivolt. So option first. Yes, very good. Yes, same thing. Same like 20 division, 10 division, some we did in errors. Right, very good, very good. This is what we require to recollect the things. Right? Okay. One more question with same model. So the question is looking very lengthy. Question is looking very lengthy, but very, very simple. Kindly, I'm giving 2 minutes of time. Give me the answer. Yes. Dinesh, correct. Vashishta, correct. Right. Few people give the correct answer. No, very simple. Yeah. Question looks very lengthy, but very, very simple answer. Concentrate. A DC potentiometer shown here. To confuse you, this much of lengthy diagram is given. Actually, instead of this, he can give like this also. But he has given clearly so much of lengthy thing. Right. It is made by connecting 15 10 ohm resistors. So what is the first point? Actually, no need to write all this, but for explanation purpose, I'm taking. What is the R box or R dial? 15 into 10. How much value? 150 ohm. 15 into 10, 150 ohm. Okay, after that. And a 10 ohm slide wire length. All I told you know, slide wire length. R slide wire 10 ohms. R slide wire 10 ohms. Length of 1000 mm. What is it here? This slide wire length is L slide wire is 1000 mm. Concentrate. It is 100 centimeter. Like 1000 mm is given. Okay. Next, the potentiometer is standardized with a current of 10 milliampere. All I told you know. Every time generally we maintain 10 milliampere. Okay. After that, balance for unknown voltage is obtained when the dial in position 10 numbers of the fixed 10 ohm resistance, fixed 10 ohm resistors included, and slide wire on the 234th mm position. This is what very, very important. Where the balancing is happening here, 11 number of 10 ohm he has given clearly across this 11 number of resistors are being taken. What is it now? 10 into 11. What is it? 110 ohm. 10 into 11, 110 ohm plus slide is how much? 234 mm. Sir, 1000 mm. How much resistance? 10 ohm. So therefore, 234 mm. How much? I'm coming again, sir. Assume that this is standardized. Suppose this is standard cell. Okay, with this standard cell, it is being connected here. It is being connected here. Means this is the circuit. This is the circuit. Therefore, the point here is, sir, between this and this, between these 2 points, how much resistance is there? Here, totally 11 into 10, 110, 11 into 10, 110 plus 234 mm related resistance. We have to take it. 10 milli is already given. 10 millicurrent is already given. So therefore, what is it now? I'm taking this point A, this point C, for example. So therefore, what is it? RAC is equal to 110 plus 110 plus. Sir, what we can write now with respect to this? 1000 mm gives 10 ohm. 234 mm gives dash mm. 1000 mm 10. So 234 mm gives dash mm. What will be there here? 2.34. 2.34 ohm. Clear? Okay. Therefore, what we can get? 110 ohm plus 2.34 ohm. So totally 112.34 ohm. 112.34 ohm. Clear? Okay. After that, what he is asking? The unknown voltage up to so and so. He is asking some corresponding unknown voltage. How do you get it? Very simply, VAC is equal to I into RAC. Okay. What is I? 10 milliampere into 112.34 ohm. What will be there now? 1.1234 volt. That's why I told you, step by step, if you follow, answer will be very, very simple. Many people give the correct answer. Correct. 1.1234. Bhavana, kindly check it. Few people gave the different answer, but I solved it right. Sir, current is 100 milli. Where is 100 milli? Check it here. This is 10 milli. Here the decimal point is 10 milli. 10 milli. This is IP. Nothing but slide wire current. Nothing but our potentiometer current. Right. Very good. Very good. Right. Right. Who is this? What is the purpose of RC and RF? To confuse you. What is the purpose? Means only to kill your time. The two, those values are not given, no need to worry, because he is not asking the total thing, etc. He is asking only voltage across this. No need to worry. RC and RF. And that's why in the given question, definitely unnecessary data chance is there. So that's why don't waste time. Don't waste time. So this is the total discussion regarding potentiometer, slide wire potentiometer, and correspondingly Crompton's potentiometer. Clear? I told you in a very small topic, we have taken the total discussion and various numerical questions. Right. If they don't give diagram, how to take 0 FSV in slide wire? In the earlier questions, the diagram is not given. In this question, diagram is not given. How we have taken same procedure. In this question also, diagram is not given. We have drawn the diagram. So kindly try to. That's why I told you before taking these type of questions, without giving the diagram, how can we solve? I told you that. Definitely, very good. Aishwarya Venkatesh, IP should be always constant. IP means our IW, our I. All I told you, that current should be always same, always same. Whatever you keep here, always by varying those, it will be maintained. But as he has given this as a fixed one, no use of this. Otherwise, suppose if you're adding some resistance, current will be changing. then by using these two calibration, that is again same procedure. That's why in this they have varied this and they maintain the 10 milliampere. Therefore, there is no use of these two resistors in the numerical question. IP is always constant. Right. AC potentiometer is not there, no need to worry. Right. AC potentiometer is not there. Right. Now, all I told you, whatever the tapping you take, what is it? What is the assumption here? I will be always maintained as constant. How? Calibration. How? By varying the rheostat. Same thing you have taken. Yes, IP always given, IP always given, or IP always, he may be asking the question by giving the corresponding data. Right? Right? No. Right. Here, already told you this in the starting days. I told you this in the starting days. In the error analysis, I told you, concentrate here. 0 to 200 volt is there. 100 divisions are there. What we say, resolution is in terms of volt per division. I told you this. Okay. In this case, what is that? Centimeters will be given. And here, 0 to some value, volt. What is the resolution? Volt per centimeter. These two are universal. But I told you one more point also. Concentrate here. Here, this is 0 centimeter, 1, 2, 3, 4, 5 centimeter, for example. What is that value? Suppose 0 to 10 volt, for example. What is the resolution? 10 volt by 5 centimeter. 10 volt by 5 centimeter. Okay. But in this question, what is that? In the 10 in each 1 centimeter, 10 mm divisions are there. What you have to take now? Here, instead of this 5, you have to take total divisions are 50 mm. Volt per mm will be there. Otherwise, in this question, he has given that in each division, 1/5 of the part is measured. In this 1/5 of the part means it is mm. In 1 mm, 1/5 is he is measuring, or 1/10 he is measuring, or 1/20th, any number. Means here what you have to do now in this, it is not mm, it is not mm. In 1 mm, fifth part into 5. That's why volt only we write. So volt per mm we cannot write. Is it the 250 mm is there? No. 50 mm only, but in 1/5, in 1 mm, fifth part is measured. That's why denominator is not mm. That's why simply volt. Same concept I told in the error analysis resolution topic. Same model. 1/10 of the division we have taken. That's why if you take the centimeter, keep the centimeter. If you take the mm, keep the mm. But 1/5 of mm, 1/5 of division, or 1/10 of division, denominator we cannot write. Why? Division we cannot write because 1/5 of the division it is. Mm we cannot write. Cm also we cannot write. So therefore, division also we cannot write. That's why simply numerator use. That's it. Right? So this is the total discussion regarding entire potentiometer. Right? I hope you have gone through the entire notes. Right? That's why I'm requesting everyone after the class, before coming to the next day, class, kindly come prepared, because if you attend the class, you will get some subject. After that, if you practice the same notes, you will get more betterment. After that, if you practice more questions, that is a final betterment. Kindly, without preparation, kindly, with preparation only, try to come to the class. Okay. After the conclusion, materials used in this entire instrument potentiometer, various materials are used here. So what are those materials? Just for idea purpose, I'm giving materials. Different materials we are using. That way I told you somewhat costly equipment also I told you in the yesterday's class. Costly equipment I told you, right? So that is what I'm taking now. What are the materials we use? These are the materials used in the DC potentiometer. See, what is that? Resistors. whatever the series rheostat or whatever the resistance dial box, all those are made up of, manganese material. What is the purpose of manganese? Constant temperature coefficient. This is one material. And all the slide wires, either in the slide wire potentiometer or in the Crompton's potentiometer, the slide wire is made up of platinum and silver, and slide wire contacts will be there. Slide wire contacts are made up of gold, silver, and copper combination. That is reason why it is generally costly device compared to PMMC. Now you can decide if you want to have perfectly best resolution, you prefer this potentiometer, but you need to compromise in the cost or size, etc. But if you are very much keen about, only size must be small, go for the PM. PM is also good. PMMC is not bad. PMMC is good. But compared to PMMC, this instrument is having little bit more advantage. That's the point. These are the materials. Kindly remember these materials. If you write any state level examination or any PSU separately is there. And if you write ESC people also, right? In all those, these are very, very important. In the GATE, directly these type of questions are very rare, but concept point of view you need to. Resistors used in potentiometer are made up of manganese. That may be rheostat, that may be dial resistance box. Whatever the slide where we are using, platinum and silver alloy combination. Slide wire contacts are made up of gold, silver, and copper. Gold, silver, and copper. Clear? So this is a total discussion regarding potentiometer. Right? Now, let me take one more simple topic. After that, we are going to start the very lengthy topic. That is bridges. Will be taken later after this topic. I'm taking instrument transformers. Instrument transformer. So what is this instrument transformer? What is this instrument transformer? Kindly concentrate here. First of all, everyone, this is equally important for both the branches. What is that? Instrumentation and electrical people. But in the instrumentation paper also, in the instrumentation gate paper also, from this topic, questions are there. That too, so many times questions were there. Don't think like it is a transformer. So not our topic. This is electrical topic. Not like that. Yeah. In the measurement point of view, these two are equally good. And one more point I told you, I'm repeating. AC potentiometers is not there in the syllabus of GATE or ESC or any examination nowadays. It is not there. No need to worry. There was old in the topic. The concept is not old in the syllabus. That's why I'm talking about only DC potentiometer. Right. See, people are asking, sir, in the classroom everything is clear, but in order to get the best preparation, how many hours or how much time? So that's why I'm giving only one suggestion here, because every year I'll say this only. But again, finally, after getting the gate rank, people call me and say that, sir, I missed the time. I wasted the time like that. That's why every time I'm saying that. Every time, whether your college is there or college is not there, fourth year completed or third year, fourth year, second year, whatever may be your year of studying, we no need to worry about that. First thing, class every day, 4 hours class is there every day except Sunday. Every day 4 hours day is there. Yes or no? Other than this 4 hours, you need to spend compulsory. Means I'm asking you to spend only 8 hours as this initial day of time, initial days. Yet 4 hours class you are attending, 2 hours complete class notes revision, and next 2 hours complete all the question whatever you are having. Means the moment the topic is done today, by tomorrow before coming to the class, topic is done by you also. Over. There is no problem of syllabus is pending, subject is pending, etc. Right? Every time people are asking like this only, sir, how to prepare? People are asking that. Even after saying that, people don't follow. I hope. See, I started June 1st, right? June 1st, one batch, new batch started. Okay, leave it. What about the other people? What about the other people? I'm asking other people before my subject, one or two subjects might have completed. Completed means not from the faculty. Completed means from you. By you, I'm asking. That's why subjects completed or syllabus completed. Always the students are worrying about the subject completion by the faculty. No, yeah, completion by you is the matter. Completion by you is the matter. But generally, people are attending the classes. Okay, syllabus completed, keeping aside. No question of revision at all. If you are doing like that, definitely disqualified. Definitely. I have seen so many people because they were the toppers in the college and they told that, so I'm the topper, I'm attending the class regularly, I understood clearly, everything is done, but no preparation. After the gate, if I ask them what was the rank, mean disqualified. Sir, why? Means, sir, I did not prepare, only I attended the classes. Only for attending the classes, right? It is not at all accepted. That's why you need to attend the class after that at least 4 hours. At least 4 hours. And every Sunday, you will not have any college work and all, only this class, right? Every Sunday, 6 hours class is there, for example. For example, what is that? 6 hours. On Sunday, you need to do extra work, 4 hours as usual. Like that, if you do it, that too, one day break will be there completely. One day break will be there. No, on that day, total 10 hours for gate preparation only. If you do like this, see, 5 fours are 6 fours are 24 plus 10, only 34 hours, excluding the class hours. Excluding class hours, 34 hours time is there for you. Is it not sufficient to complete one subject? Definitely you can complete. And okay, for June 1st batch students, my subject is the first subject. Okay, my subject is completed by me means it should be completed by you also. In that way only, I am taking the explanation, I am solving all varieties of questions. But except through 2 3 people, everyone is performing well only, no problem. So that's why after my subject, suppose next subject X is started. I said, no, you are going through X1, you are going to this subject, but you'll be missing this subject. No, what you have to do after starting the second subject, in this time only, at least 1 hour daily, you need to keep it for that. Again, third subject, again two. Like that, you need to have the continuous revision. Otherwise, in this month of June, measurements will be studied before the up to February. People are not at all opening this measurement at all. Over. No use because 6 months of time, 6 months time means definitely there is a chance of forgetting the things. So that's why continuous revision must be required. Continuous revision must be required definitely. Otherwise, very difficult. Right. That's what. Yeah, Pramod, this is a third subject. Very good. Obediently told that it is a third subject. Two subjects are completed by the faculty or by you is the matter. I'm not asking question. You think you question yourself. Everyone. That's what I'm saying. That's why not only you are every time same thing. Every time same thing. Right? The moment I say this, immediately, sir, how to prepare and everything, people are asking. If I say that, not at all preparing, by wasting time, etc., etc. Right. So major problem when we revise, it feels like new. When we revise, it feels like you new means you didn't. I'm openly saying not only my subject, not only my subject, any subject. While you are revising, if you are feeling like new, I'm 100% sure even you feel bad, I don't mind because I'm not here to praise you. If I praise you unnecessarily, you will be diverted. That's why you should be in the same track means I should say the fact. That's why you did not attend the class carefully. 2 o'clock started means 2 o'clock started. Complete concentration on the topic only. Right? Going there, drinking water, etc. You drink the water, no problem. But listening only, going there, out, every 2 hours, I'm giving the break. No, yes, feel free and get refreshed and come back. That's what the point. You see, I'm openly saying here, if you don't understand now, 2 3 people are there. I can understand by their response and all. They may be feeling differently, like sorry is not at all saying the things properly with respect to this one. Doubts are asked, etc. I'm intentionally saying that if the people are asking the doubts, I'm answering all the doubts. But if the people are typing the questions while I was explaining, intentionally I'm pointing out you so that at least you can change. If you keep on definitely, if you keep on typing, something will be missing definitely. Definitely, the topic will be looking like new topic only. Definitely. So that is the reason why the moment you start the topic, the moment the faculty starts the topic, you should concentrate. So it is very difficult to see the mobile phone means the platform is like that. Not only to you, all over the world is like that. Do you have any alternative other than using the laptop or mobile phone? No. So that's why be clear, be clear. Right. Yes, sir. Doing made of notes of measurements up to 3 phase per calculation, 8 pages from start. Very nice, very nice. Right. Which subject should be completed first? That your wish. That your wish. Whichever you like the most, that subject should be completed first. Then you can get the positive thought. Okay, one subject completed. With that positive thought, you can go to the next topic and all. Okay. See, okay, Pramod, in the May month, throughout the day, classes have been done. Okay, even though you need to find the time. I'm openly saying you need to find the time. Definitely. See, if anything is there, I'm giving about 2 web series, for example, almost 8 hours. Can't you sit continuously for watching all 2 web series 8 hours continuously? Do you say that by 8 hours I cannot say? Definitely, we don't say. That's why whatever the number of hours are there in future, 8 hours class is there, for example, one subject or two, three subject. At any cost, after this, you need to find at least 2, 3 hours for revision compulsory. By by utilizing the other time for this one. Otherwise, no alternative at all. At any cost, you should get the gate rank. You should follow this compulsory. You should get the gate rank means you should get it. That's it. So it is very difficult. Yes, if it is very difficult now, yes, it is very difficult now. Then after the BTech, your life will be beautiful like anything. Right. And sir, what to follow after the notes? After the notes, don't go to previous question. If you follow my notes, material questions all will be solved. Other than that, self-practice booklet questions are any other questions are there, practice it. After the previous question, because when do you write the gate exam? After having the complete preparation or not having the before having the complete preparation means after completion only. That's why you need to be perfect in class notes, all the questions class solved in the class, homework questions, some extra questions, whatever the thing you are having. After that, go for the previous questions. Definitely. Very good. Yeah, that is what, because of final year project, etc. means, yes, problem is there, but I cannot say, okay, that is correct. Okay, that is correct only, but we cannot, we don't have any other things, right? And how many months are required? Let me take July to December. Perfectly 6 months. 6 months into 14 hours, I say. In this 14 hours of time, your coaching time, 6 to 8 hours will be there. No, rest of the time you need to prepare. If you prepare like that, 840 hours will be there. 10 subjects are there. 84 hours will be there. In that way, you need to plan accordingly. Right? 6 months of time is more than enough. More than enough. Yeah, because of final year project, yes, that is there. But somehow you need to manage. Any year after my class notes, whatever the material, whatever the questions you are having, you need to follow. But be clear, according to your syllabus only. By taking the AK Sahana textbook, I will solve all the questions one by one. No, in the AK Sahana textbook, only electrical and electronic measurements only your gate syllabus for electrical people. ESC people, transducer is there, but lengthy topics are there. That much is not there in your ESC. But IN people, I told you, transducer is there for you, it is there. So this is what the complete preparation strategy. And I'll be speaking like this. Continue, no need to worry. In SO exam, good questions are asked. Yes, gate question paper, ISO question, anything you are having, practice that. Right? Kindly follow this, because we lost so many things here when we are in the BTech or etc. We lost so many things. That's why we don't want to see in the same situation. That is the reason why I'm giving all this suggestion, not to pass the time, not to pass the time. If I spend this 10 to 15 minutes of time for my topic, I can complete my topic. But at least 10 to 15 minutes of time I'm spending means I don't want you to be in the same position in which you lost everything, nothing is there like that. No, that's why you need to be very careful from now onwards only. You may be second year, third year, fourth year, or BTech completed. I don't want anything. Make the time and prepare. Make the time and prepare only for this 6 months. January complete revision, February writing the gate exam, getting the double digit rank. Stay happy. Then you can enjoy like anything. Through the 24 hours, you can watch the you can watch the movies. No one will object you. But after getting the gate rank, right? Sir, why management is giving low priority to dropper batch? What do you mean by dropper batch? Ankur, what do you mean by dropper batch? See, only ISRO is generally, right now, ISRO is conducting their own exam. Apart from that, almost all the PSUs are recruiting through GATE exam only here. Only ISRO, all other state level examination like GENCO, TRANSCO, own state. Don't worry. I already told you, yes, I'll be just, I need to take the permission from them. Yes, I'll be taking the session separately. Almost 1.5 hour session. Generally, I'll take as the career opportunities and all. I'll be planning for you also, no need to worry. Passed out batch. How, just now passed out batch. Mean, okay. Yeah, okay. One more problem is also there. People don't get disappointed at all. Electrical measurement in the starting day, and I told you in this session, I'm taking electrical measurements. After this, instrumentation transformer, bridges will be there. After that, 2-3 miscellaneous topics are there. I will complete the electrical measurements, only electrical. After that, either that session may be continued or in the other session, I'll be taking electronic measurements for everyone. After that, right, ESC people, transducers will be separately taken because ESC separate subjects, ESC extra subjects we see in our AS Academy. Lot of time is there for ESC. No, that's why we will be focusing on GATE and ESC common subjects first, so that those who are taking ESC coaching, they can write GATE also. After that, we'll be taking the corresponding ESC extra subjects. No need to worry. Everything will be covered. That's why in this session, sir, 14th only completed. That is only electrical measurement. Only electrical measurement, right? After the instrumentation transformer, bridges, lengthy chapter is there. After that, I'll be taking measurement of power factor and frequency, miscellaneous topic, and I'm going to solve all the questions from chapter 1 to chapter last chapter. Few questions, general question, my own questions, few questions are previous papers. In that way, my explanation will be there. That's why topic to topic questions, at the end of the chapter, few questions, and at the end of the syllabus also, chapter 1 to last chapter, all varieties of questions, my own questions and previous questions, everything will be covered. That is why in my class itself is every day I'm revising, and chapter after the chapter every day I'm revising again. At the end of the syllabus also I will revise. So directly you can write the exam, no problem. But you need to have practice. That's it. Okay, now let me start the topic. Actually, Genco, Transco, they are saying that posts are there, but they are not getting the notification. We are not having any correct idea. Right. Now I'll be answering all your doubts later, some other time again, right? Test series regarding everything. I'll be taking it later. Let me take the topic. If I take this entire discussion for long time, it will be deviating. So no problem. To 15 feet like that, I'll be taking, no need to worry. And in the one student is asking one technical doubt. Sir, in the Crompton's potentiometer, if I take, you are missing small thing, kindly concentrate. That's why you think your question first. You think your question. Sir, like this is there, right? I kept here, I kept here, and here voltage source is there. Galvanometer is showing 0 means which resistance must be taken? Which resistance must be taken? Concentrate. This resistance must be taken or this resistance must be taken. Come on here. Where you are connecting means here supply. You go like this from supply this resistance to this resistance only you have to take. People are saying that clockwise. Where is the clockwise? I'm not understanding. That's why where you are connecting the points, where you are connecting the points that you have to take from here and here you have to take. That's why in the actual construction model also, how the thing will be there? No, this is 0 ohm, 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5, 6, like this, 10 ohm will be there. But in this is 0, 10, 20, 30, 40, like this, 100 will be there. In that way, between these 2 points only, you have to consider that only. I told you with the figure. Right. I'll tell you, Vinita, I'll tell you everything one by one. My subject is completed. Now, by that time, you will be coming to know everything. No need to worry. Right. First, coming back to the topic here. Right. Definitely, Mano, definitely. Because at this time, not only the subject, something else is also required to you. Yes, I'll give you, no need to worry. Right, let me start. Sir, instrument transformer. Sir, what is the instrument transformer meaning? Everyone keenly observe. Very simplest topic. Transformer used as an instrument. Sir, why we are using transformer as the instrument? One point. What is a transformer? Transformer is AC type or DC type, means AC type. So transformer is AC device. So therefore automatically instrument transformer also nothing but AC device only. AC device only. And okay, one more thing I wanted to say. Few people asked one doubt in yesterday's class. I think Mubin or some other person, I don't remember. Regarding energy meter. Regarding energy meter protection, one person asked. I don't remember. But I told that in the energy meter, what is it here? Over coil, over voltage, etc. is there? No, that is in the normal type instrument. But nowadays instrument, in the digital instruments, there is no protection scheme. Actually, I contacted some industry person and I came to know today morning only. Even I got the doubt actually. Energy meter. Normally, whatever the disk type energy meter we have taken, no, in the over voltage, over separate protection schemes are there. But nowadays in the practical world, digital meters are there. And they told that if the service wire voltage is 230 volt, for example, generally, right? The energy meter can bear up to 230 plus or minus 10 volt or 10% approximately. That tolerance based only energy meter is designed. Other than that, if the fault is, if the over voltage is increase more than 10%, instrument will be damaged. That only he told. My friends are in the department and I asked them. So therefore, there is no separate protection schemes nowadays in the digital meters directly. What is it? Digital meters, nothing but energy meters are designed such that up to 10% extra it can bear, but more than 10% damage will be there, he told. But what is the remedy means? There is no remedy right now. As of now, he told that. But in the disk type energy meter internally, what is it? By keeping the core specially, but only for that is he told that is only for study purpose. Practically, all those will not be there, he told. So that's why just I'm correcting my statement. Protection schemes are not specially inbuilt in the corresponding practical devices. That's why don't worry. Normal operation only you study. Clear? Okay, right. After saying that, even I got the doubt, is it correct or not? That's why I asked them. So that's why theoretical purpose we say so and so production scheme is there and all, but practically they are not. They are not. Yeah, Imtiaz. Yeah, Imtiaz. Right. Okay, right. AC device. And come to the top. Transformer. So why we are going for this means transformer means higher capacity device. Transformer itself indicates higher capacity device. So that's why to measure high voltages and currents. To measure high voltage and currents. Sir, why? Means concentrate. Sir, AC device means already we are having MI. Sir, even though we are having MI, why we are coming to this instrument transformers means MI instruments are laboratory instruments. Okay, in MI instrument, up to how much voltage you can measure? In MI instrument, up to how much here? Laboratory voltage 230 or 400 or 440, etc. Suppose if you want to extend that by using extension methods we have taken, no, we can extend up to 600 or 1000, etc. But in our transmission line, 11 kilovolt, 33 kilovolt, and 132 kilovolt, all those things are there. All those things are there. So that is the reason why. How do we measure? How do we measure those very higher voltage and current means with the help of instrument transformer? That's why measure MI instrument extension methods are having some limitation up to a laboratory voltage or up to 1000 volt or 100 amperes or 50, like that only. But if you want to go for kilos of volt, 20 to 33 kilovolt, 220 kilovolt, etc., how do we measure that? Very important. Second thing, sir, outside the substation, if you are going on the road and street, if any substation is there, outside the substation one board will be there, 132 kV by 33 kV. How do they measure that voltage as 132 kV? How do they measure that voltage as 33 kV? That we are going to study now. Okay, and in this instrument transformer, there are two types are there. One is for current measurement, that is current transformer. Voltage measurement, that is called as potential transformer. This is in short form, it is called as CT. It is called as PT, we can say CT and PT. Clear? Okay. Now, what is CT? What is PT? What is the purpose? Everything we are going to take. Now, concentrate. Very important topic for practical point of view, also for electrical people, but IM people in the gate examination point of view, you require concentrate here. Sir, suppose if I'm taking one line, very important, I'm going to spend lot of time on this. Concentrate. One line is there. Okay. One line is there, right? And this is the written path, for example. This is the written path. Okay, right. Here, supply is given. Supply is given. Okay. This is phase, neutral. Phase and neutral. After that, load. Some load is there. Some load. Okay. This voltage I need to measure. But this voltage is in terms of 33 kV, 132 kV, that much high range is there. And I want to measure this current I1. First of all, sir, this I1 is coming over here, right? And this V1 is coming over here, but we don't know. But be clear, load means don't think like our bulb, our fan, not like that. This load means complete one village, complete one street. In that way I'm taking, because our topic is not the laboratory type topic now. This is the complete topic related to, what is that here? Practical substation or practical transmission line, like that. Okay, right, sir. In this is the high voltage we know, but how much magnitude we don't know. That's why we need to measure this voltage. Sir, voltage measuring device is called as which device here? Voltage measuring is PT, potential transformer. Always voltage measuring device should be connected in parallel in the line or series in the line, means parallel in the line, because voltage measuring circuit parallel. Therefore, I'm taking here, this is connected like this. You may be asking, sir, why these many number of turns? Means this is not 100 volt, this is not 200 volt here. This is 11 kV, 33 kV, 66 kV, 132 kV, 220 kV or 400 kV, etc. Transmission or distribution, any voltage, very. That's why in order to handle this much of high voltage, the transformer winding should be having more number of turns. Why? More number of turns are there, more voltage will be there. Yes, handling. After that, sir, we are reducing this voltage. We are transformer means changing the voltage concept. Here I am using less number of turns. Okay, sir, this is V2. So my question is, sir, V2 is less or V2 is more than the V1 means obviously V2 will be less. So indirectly what we are doing here, we are stepping down the large voltage. Okay, what is this voltage? In that way only the CT and PT will be designed here. The secondary voltage will be our laboratory equivalent voltage of either 100 volt or 200 or 300 or 400, etc. That voltage can be measured by our MI instrument or not? Yes, that's why here MI voltmeter is connected. Finally, we are using MI, but MI is not directly connected to the large voltage. To say that, yeah, MI instrument is directly showing the pointer movement for 11 kV, 33 kV, no, not possible. That's what we are reducing the voltage. Sir, for reduction of voltage, what is it? N1 greater than N2 means number of turns N2 must be less than N1. Okay, sir, this is PG. Okay, is it step down or step up? Everyone, is it step down transformer or step up transformer? And why? Kindly respond. And why? Reason also I require. Step down or step up? Reason also I require. Right. Few people give the correct answer. Be clear. Yes, this is step down. This is step down, but be clear. This is the step down transformer because actual terminology I'm giving, because number of turns are getting reduced from primary to secondary. Number of turns got reduced from primary to secondary. That is called as step down. That is called as step down. Primary number of turns are more, secondary number of turns are less. Therefore, the large voltage is reduced to small voltage. That is called as step down transformer. So therefore, what is it here? Why it is called a step down means number of turns are more, number of turns are less in the secondary. So primary to secondary, number of turns got reduced. That is called as step down transformer. Okay, after that. Sir, in this concentrate gate, 3-4 questions, I answer. No need to worry. Sir, 1, 2, 3, and 4. Out of these 4 values, which values are given in the nameplate details of the transformer means N1, N2 will be given after that. Sir, out of these 2, which is shown by the MI voltmeter means V2 is shown. Finally, which is to be calculated here? V1. So simply number of turns N2 by N1 is equal to V2 by V1. So from this, sir, V1 is equal to N1 by N2 into V2. So in this also concentrate, the large voltage is not shown by the device by the pointer movement. No, small value of voltage is shown, substituted here. Number of turns anyway, we know from the data, we can calculate the large voltage. Nothing but it is also extension method only. Means MI voltmeter range is extended with the help of which are potential transformer. MI voltmeter range is extended with the help of potential transformer. Therefore, the instrument transformer concept itself is extension of range of MI inch, but not to small value, to the larger value. That is the reason why we are taking as a separate topic. We are taking this as a separate topic. That's it. Clear? Right now. Sir, CT, current transformer, should be connected in series or parallel. Series or parallel. Current transformer means what is that? Current measuring device always which is series. So therefore, here like this. Sir, Y means concentrate. What is the current here? I1. Here doubt is there. Sir, here I1 is there. Here I1 is there. How it is possible means be clear. as it is having many number of turns, right? It is having very less carrying current. That's why generally, practically, we neglect that. That's why don't indicate the primary current of P. What is the potential coil like that? And no need. Terminology purpose, you can take it, but mathematically, magnitude point of view, that is very small. You can neglect it blindly. You can neglect it blindly. Okay. Second thing, sir, I1 as it is, I1 is coming over here, coming, and large current is there. Therefore, how should be the cross section? How should be the cross section? Means the primary winding of a CT. The primary winding of a CT should have large thickness or small thickness. Means large thickness. Why? Cross section area is more. R equal to rho L by A. A is more. R will be less. R is less. Current will be very high. So that's why very less number of turns and more thickness. I will write that. No need to worry. And here I am using more number of turns like this. Here again same concept. We are using MI ammeter. This is MI ammeter. Through this I2 is there, I1 is coming over here. Now what is the logic here? Concentrate here. N1 less than N2. N1 less than N2. And here this is called as which one? CT. Okay, my question is either step up or step down, and why? Correct reason I require. Step up or step down, or why? For this question, if IN people are giving them wrong answer, no problem. But electrical people should not. It is step up or step down, and correct reason. See, kindly don't give that. Sir, current is increased, so that step down. So that, sorry, current is decreased, so that step up. How can you say that? Current is increased. What is the relation? Step up. This is the main problem here. Concentrate. Here, actual answer is, sir, as the number of, many people give that, as the number of turns are increased from primary to secondary, as the number of turns are increased from primary to secondary, this is called as step up transformer. Be clear, guys. This is step up. Kindly don't say that, sir, current is decreased, so step up. Current is decreased, step up. There is a relation. That's why actual answer is, as the number of turns are increased, it is called as step up transformer. Yes, many people give that step up, but step up because current is decreased, not exact statement actually. That may be valid finally, but people are saying that, sir, current is decreased, to say therefore step up. Why? Means number of turns. That is what finally we are depending on number of turns only. And few people give this formula also. So I1 by I2 equal to N2 by N1. Yeah, that is okay. That's why I told you. Even though you are saying that current is decreased, nothing but number of turns are increased. Again, we are coming to number of turns only. That is the reason why we need to give the same notation. See, Shiva Gopiraju, this is not the power transformer. This is the instrument transformer. In the power transformer, this is the main problem, main confusion with the students in this topic. In the power transformer, from primary to secondary, power will be transferred. That is power transformer. Power is constant, kVA constant, we say. But in this, are you transferring the power from here to here? No, you are transferring the power from here to here. This is the load. That's why in the what is it here? Supply line is there, load is there, power is being transferred from, what is it, primary to load or source to load. That is common. But how much power is there? How much voltage is there? How much current is there? For that purpose, we are using. That's why these two transformers are not for power transferring purposes. These two transformers are for which in here only current and voltage value measurement purpose. These are not transferring. If it's transferring means from here to here, here to here, is it the load? No, it is acting as load. But is it your house? Is it your village? Or is it your street? No, this is only measuring device. That's why be clear with the terminology in this topic especially. Clear? Okay. After that, sir, 1, 2, what is it? 3 and 4. Out of these four terminals, what will be the given value means N1, N2 already given. Okay. I2 measured by the ammeter. I1 can be calculated. So therefore, what is that? N2 by N1 is equal to I1 by I2. Equal to which one? I1 is I2 into N2 by N1. So in this way, we are going to calculate the larger value. But I'm asking the question again and again. This MI voltmeter shows the 13 kV, 33 kV, etc. No, this MI voltmeter shows small value. But with the help of number of turns, we are going to have what is it? Large voltage finding. Here also, same thing, large current, we are going to find out. That's what the actual point. Clear? Right. After that, very, very simple here. Here, this current coil generally, we can say practically either 1 ton or 2 tons, maximum 5 tons will be there. That too, less number of tons means more current carrying means thickness. Nothing but the core, the winding thickness will be, winding cross section area will be very, very less. Nothing but this is a thick wire. But this is thin wire. Here reverse, thick wire, and here thin, exactly reverse. Clear, guys? Now, sir, how CT primary is connected in transmission line means don't think like already line is there. How do we connect it? Come on here. The opening paths will be there, etc. The CT primary will be connected. Actually, CT, some ring type structure will be there. We keep the winding means suppose this is a transmission line, this is a transmission line, this is a CT. So simply we keep the CT primary like this. Simply we keep the CT primary like this. This is a CT. Right, the primary winding will be placed here like this. Some arrangement will be there, no need to worry. Right. Why step down transformer? Why step down? Which one? Sir, why step down transformer in CT, sir? Who told step down? CT, step up here. I told you step up. Kindly concentrate. Step up. See, simple logic here. Number of turns are increased, step up. Number of turns are decreased, step down. Yes, here number of turns are decreased, step down. Number of turns are increased, step up. That's what I tell you. Number of turns are increased, then that is called as stepping up. If the turns are increased, stepping up. Turns are decreased, stepping down. That's why step up or step down should be defined based on the number of turns only. After that, you can relate voltage or current. That is different. But first point is, what is it here? Based on the number of turns only. Here reduced, step down. Here increased, step up. CT is step up and PT is step down. Then how instrument transform step down? Who told, Shubham? Who told instrument transform is step down? Who told? No. Right. So is this connection practically possible? Sirisha, yes, practically possible. Otherwise, how can they measure practically possible? There's some openings, etc. will be there. They can insert the CT winding, that is different. Right. 1 or 2 tons of CT. See, kindly before asking the question, think of it first. Think of it. So CT 1 or 2 tons can it withstand high current? What I told you, very, very, very thick. Very means this much of thick wire, this much of diameter thick wire will be there. Why can't it carry the total current? It will carry. It will carry. Right. Sir, why CT primary is less number of tons? Kindly go back and see the recorded video. Okay, and after that, be clear guys. Sir, across this V1 is there. Across this V1 is there. Across which one? Here, across these two V1 is there. Sir, same V1 here is there. Same V1 here is there means what is the voltage drop in the primary of CT should be neglected. Why? It is having very negligible opposition. That's why I told you the thickness of the wire will be this much of size. Diameter or area of cross section is this much of size. R is equal to rho L by A. A is this much of size. So automatically resistance is very less. Therefore, voltage drop is neglected. That's why we have taken the power measurement question. One CT based question is there. In the CT primary, voltage drop is neglected. Through the PT primary, current flow is neglected. That is what the practicality. But small voltage drop will be there, small current will be there. That is negligible. The moment I say negligible, don't get the confusion like, sir, why it is not there? It is there, but very small value. Therefore, it can be neglected. Therefore, it can be neglected. Clear? Right. Finally, again, people are asking, sir, why MI is used? What is this question after explanation of this much? MI is used to measure the V2. V2 is substituted in the formula. V1 is calculated. Instrument transformer means don't think like transformer winding is moving and showing the 11 kilo, 33 kilo, not like that here. Transformer reduces the voltage. That reduced voltage is measured by the voltmeter, 150, 200, etc. That will be substituted here and multiplied with this entire formula, and large voltage can be calculated. Just now I told you. Same thing. CT reduces the large current to small current. That small current is measured by the ammeter. That small current is measured by the ammeter. Therefore, this ammeter I2 very small value. I2 very small value. Substituting here with the help of this entire formula, large value of I1 is being calculated. Clear? This is what the actual theory. Right. Now, people are having many doubts in this. I'm taking all those questions. What people are thinking, no, sir, in the PT secondary, large currents are there. In the PT secondary, large currents are there. So therefore, we need to use something. Come on here. In order to have the large current, at least here, normal current is to be given or not. But are you giving the normal current? No. You are bypassing. That's why current, just now I told you. Before completion of my statement, you are asking the same question. I1 is negligible. If I1 is 100, it will be 10K, 5K, which damages we can say. But what is I1? If this is 1K, this may be 0.1 or 0.01. This will be 1K. This current is negligible. If current is negligible, so current will be increased here. How can you say that here? No, that is the reason why. Be clear? The PT means only the concept of voltage. Current will be neglected. Why? More number of turns, more resistance. It will carry very negligible current. Suppose, sir, this is 1000 ampere. If it is 500, for example, then okay, 500 amperes is there, reducing. So the number of turns are reduced means this current will be increased to 5000 or 50,000 ampere, which may damage, we can say. But what I told you, from this 1000 towards this 0.01 also will not be there. Negligibly small means approximately here 1000 only, still 1000 only, still 1000 only. So that is the reason why kindly don't use your mission's topic. Mission topic, what is it here? That is the power transformer. All I told you, that is the power transformer. But our transformer is not for power transferring. Our transformer is only to reduce the voltage with negligible current. Negligible current. Reducing the current with negligible voltage. Why? Large cross-section area, very less voltage drop. Negligible. But don't say, sir, more number of turns are there. Directly more voltage will be there. More voltage means damage. Not like that. If the voltage is there, then we can say large voltage. But here, voltage itself is not there. Why? Across is 0.01, 001, 002. Like that will be there. Negligibly small completely. That's why only one point you have to remember here. CT always current concept, PT always potential concept. CT always current concept, PT always potential concept. Clear? And here again people are asking the same thing, you don't change, right? Okay, sir, primary of CT by the voltage drop, just now 3-4 times I told you, thick wire, cross section area is large. Cross section area is large means length is less, means resistance is very negligible. Drop is also negligible. Here more number of turns are there. As more number of turns are there, what is that? More number of turns mean length will be large, resistance will be large. That too, cross section area is so very less. Therefore, resistance is very high. Current flowing to this will be negligible. Right? Same thing. Just what we have taken in the corresponding topic. What is that? Here, suppose ammeter is connected. Ammeter is connected in series with this. Sir, 230 volt is here. Do you get exactly 230 here? No. Why? Drop will be there, but we take 230 only by neglecting the voltage drop across the ammeter. Next, suppose load is there. If I connect the voltmeter like this, suppose here some 10 amperes current is there. Here we can take 10 ampere current. Why? Voltmeter, through the voltmeter current can be negligible sometimes according to the given date. That's why voltmeter current drawing must be very less. Same thing, potential transformer current drawing will be very less. Same concept. And ammeter voltage drop will be very less, negligible. Sir, CT primary also voltage drop is very negligible, neglected. That's what the actual concept of CT and PT. Right? So this is the complete discussion is there in your GATE, ESC and all the competitive examinations. Clear, guys? What is it? Finally, I'm brushing up. PT reduces the large voltage into small voltage. Okay, this small voltage is measured by the MI voltmeter. With the help of this value, with this mathematical formula, large voltage can be measured. And CT, large current can be reduced into small current. Large current can be reduced into small current. So therefore, this small current is measured by MI voltmeter. With the help of formula, yes, we can calculate the large current I1. Clear, this is a complete discussion regarding CTPT construction in the circuit and operation point of view. That's why with the small current measurement by the MI, we are getting large current calculation. With the small voltage measurement, we are getting large voltage calculation. That's why I told you this is just like an extension. This is just like an extension. Clear? And one more thing, people are having very good doubt. Sir, where will it be there? Means concentrate here. Actually, in the diagram I have drawn this here only, but actually this entire CT or PT will be in the substation yard. Substation yard we say. So in that CT PT will be there. These wires will be brought to the operating room. Operating room we say, right? Panel board room. There MI voltmeter will be connected by sitting at the panel board room, operating room. Okay, voltage is 230. Substitute 230. Use this formula and V1 shows you calculation. That's what. But in the diagram point of view, I am showing voltmeter here only, but this will be in the operating room. Voltmeter, ammeter will not be in the substation yard. Those will be in operating room. Means substation yard to operating room connection will be there. By sitting at the operating room only, yes, voltage is this much, you can calculate V1. Current is this much, you can calculate this. In that way, we can get the value. Clear? Right. Now, continuation. Sir, here very important topic is that, but as the machine is not completed for electrical people, it's very difficult for me to inject the topic, because you know small things about the transformer. Okay, something you know, unnecessarily you will mix up all the things. That's why you got these many doubts. Actually, this is just 5 minutes topic, but only one thing is inject in your mind: transformer, power is constant. Which transformer? Power transformer. But what is our transformer? Current transformer, potential transformer. That's why where the power question here, why current is not coming, voltage is not dropped, so automatically power is not at all the matter. Only power will be here, and here only we have to talk between these two only, voltage and current measurement only. But you know that always transformer power is constant. That's why you're getting the doubt. Second thing, large voltage you are measuring means large voltage we are calculating with the help of small voltage. Large current is calculated with the help of small current measurement. That's what the actual point. After that, definitely in this more number of doubts generally possible. The topic is like that only. So kindly I'm requesting everyone to concentrate more. This is possible in the ESC paper objective question. Right. All these measurements of voltage and current by using MI is done in substitute. Yes, yes, definitely, definitely. Right. So that is the reason why I'm suggesting one more point to the BTech pursuing students. Completed students, anyway, we cannot do anything now. Here, those who are pursuing, kindly concentrate. If the time permits, otherwise, make the time to visit the substations as an electrical engineer. Very, 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 very important. How do you get the permission from your faculty? That is your headache. But try to visit so that we can understand something. What is there in the yard? What is in the panel board? How the connection will be there? How the things are there, etc. Where is the circuit breaker? Where is the isolator? Where is the CT? Where is the PT? How the operation, manual, automatic, everything will be coming together. So kindly try to get it. Right? Here, why? One question actually, I'm explaining as the concept. Why? Pawan Kumar, I worked in GS substation, so that there will not be any doubt to you. Very good, very good. If you have worked in the substation, at least you can get some idea. Okay. Other people, don't worry. If time permits, you can try. Right. See, why the secondary of CT? Why the secondary of CT never be opened? Why the secondary of CT never be opened? Never be opened while the primary is energized. This is what the question. I'm requesting everyone to concentrate on this topic very, very, very clearly, very much clearly, very, very, very much clearly, because in this complete concept based I'm taking. Very good, very good. Yeah, very good. Those who have visited, they can understand, they can revise it. Other people, no need to worry. You can understand now. After at any time, if you visit that, you can revise all these things. Okay, no problem. But kindly, for 10 minutes of time, at least 10 minutes of, don't type any question. Kindly, I'm requesting, concentrate here. Sir, first point. Why the secondary of CT never be opened means here, this is there, right? I'm opening like this. Actually, we don't open, but if I open like this, what will be the problem? So the moment if I open, what is I2? I2 will be 0. Okay, the first point happened is I2 will be 0. Okay, if I2 is 0, if I2 is 0, what will be there? N2, I2 will be 0. General logic. I2 will be 0. Then N2, I2 will also be 0. Clear? Right. So after that, what happens is very, 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 very important. What happened? Generally, what is the primary MMF? N1, I1. What is the secondary MMF? N2, I2. Now, everyone, don't answer anything. I'm giving entire thing here. See, Vishnu and Ashwani, I'm not asking any question, I'm explaining. Just now I told you, don't type anything. Still, you people are typing. Kindly let me explain. Otherwise, subject will be done from my side. Subject will not be completed from your side. That's what the main problem. Concentrate. So, in the normal condition, what is the corresponding primary MMF? N1, I1. Secondary, N2, I2. So, my question is, so these two are in the opposite or in the same direction In the normal transformer operation means always secondary opposes the primary. Transformer is a phase shifting device. Means what? Corresponding secondary always tries to oppose the primary, or we can say load always oppose the source. So therefore, this secondary MMF will be equal and opposite to the primary MMF. Secondary MMF almost equal and opposite to the primary MMF. So that's why resultant will be like this. Sir, what will be the resultant practically? Sir, here 100 ampere turns is there, for example, primary. What can be secondary? For every action, equal and opposite reaction means we say a statement, but is it exactly equal and opposite? No, approximately. So that's why let me take some 98 for example. Some 98 for example means 198. What is the healthy ampere turn during the running condition? 2 amperes. 2 amperes. Clear? So therefore, my question here is, this is the healthy condition. Okay, so under healthy condition, N1 I1 is there, N2 I2 also there. Both are almost equal and opposite. Therefore, 198 or 192 something approximately. So 2 ampere turns. So far, it is operated in the healthy mode. Is that no? Suppose, sir, if the secondary got opened when primary is energized, I2 0, N2 I2 will be 0. Then what we can say, I'm giving the complete node, no need to worry. Then the opposition offered by secondary MMF on primary MMF becomes zero. So what does it mean? Concentrate here. Sir, N1 I1 as it is there, but which one? Secondary MMF became 0. What is it? 0. Sir, what is this? This is 100 minus 0 equal to 100 ampere turns. Very, very important, sir. Under healthy condition, the MMF available in the transformer core, that is CT core. CT core is 2 ampere turns. But when the CT secondary got open while the primary is energized, means under operation, if the secondary got open, what happens here? N2 I2 will be 0, N2 I2 will be 0. Automatically, opposition offered by secondary MMF on primary MMF becomes 0. So secondary MMF opposition on the primary MMF will be 0. Okay, then N1 N2 minus 0. So N1 N2 is 100 already. 100 minus 0, 100 ampere turns. So automatically, what is happening here? One second. N1 I1, sorry, primary MMF. N1 I1 as it is there. N2 I2 0. Therefore automatically 100 minus 0, 100 will be there. Sir, under normal condition, 2 ampere turns is there. Under normal condition, 2 ampere turns is there. But under this, what is it? Opening condition, secondary circuit opening condition, this flux density, or we can say correspondingly magnetic MMF, what is it here? Increased by 50 times. Sir, if the MMF is increased by 1 ampere turn or 2 ampere turn, acceptable. But here, MMF is increased by 50 times. Is it acceptable here? No. What happens here? Due to this entire thing, as this opposition is 0, MMF in the core will be drastically increased. What is it? Therefore, MMF in the core is increased heavily. Sir, if MMF is suddenly, see how much time for opening here? With just like this it get opened. The moment it get opened under running condition, what happens, sir? I2 becomes 0, N2 I2 becomes 0. Opposition offered from the secondary to primary becomes 0. Immediately, what is it? Core gets, what is it? Very, very, very large amount of EMF. So due to this, what is happening? Here? MMF in the core is increased heavily. Therefore, what is it here? Due to this, what we can say, core gets deeply saturated. Core gets deeply saturated. What does it mean? Suppose cutoff limit is 2, for example. 2.5, okay. 2.3, okay. 3 also okay. 3 also okay. But instead of 2, it is increased by 50 times, means it is reaching to 100, means what is it here? More than the saturation, very, very larger value, means that is called as deeply saturated, sir. Once the core gets deeply saturated, the flux will be not at all changing. Therefore, AC nature will be fail. We can say core gets damaged. We can say core gets damaged. That's why CT secondary never be opened while the operation is going on. That's why while the primary is energized. Okay, one thing. Not only this, sir, once the core gets saturated, deeply saturated, and the two, what is it here? MMF is very, very, very high, I told you. So therefore, suddenly, what happens, sir? It got open in this secondary, in this entire core is there, no? In this entire core, largest possible, heaviest possible MMF is increased. In my example, 50 times I told you. 5 Weber to 50 means 250 Weber. In that way, heavy flux will be produced. Therefore, what's it here? Core gets saturated, I told you. And that heavy flux is cutting the corresponding heavy number of tons. What happened here? Due to that heavy flux in this abnormal condition, is no, cutting the large number of tons, automatically large amount of EMF will be induced, which will burn the entire secondary coil. But under healthy condition, do we have any inducing of large EMF? No. Why? Under healthy condition, after all, 2 ampere turns MMF is only there. So therefore, normal MMF we neglected already, told you. So therefore, here not much high voltage drop. Here also voltage drop neglected. But under abnormal condition, I'm repeating, I2 0, N2 I2 0. Then opposition offered by the N2 I2 on N1 I1 will be 0. Then automatically in the core, MMF will be increased heavily. Core gets deeply saturated, and also large amount of EMF will be induced in the secondary winding, which will damage the secondary winding. I'm writing now here, and right, what is it? Large amount of EMF is induced in the secondary due to heavy flux or large flux, due to large flux. Then secondary winding gets damaged. So what is that happening here? If this is happened automatically, what is it here? Here, core is damaged, secondary winding is also damaged. Finally, we can say CT got damaged. So that is the reason why while you are operating the CT, you should take care of that CT secondary never be opened. Okay. People are asking that, sir, what should be the precaution then? Means always one thing here. If you want to measure the things, connect the ammeter. If you don't want to measure the thing, simply short like this. Right? If you're shorting like this, right? Definitely path will be there. So I2 will not be 0, no problem. If you connect the ammeter, path will be there. I2 will not be 0, no problem. That's why, what is the precaution here? Therefore, always either ammeter one second. Either ammeter is connected in the secondary, or the secondary winding must be shorted. Means always the secondary path should be available. It should not get open. If it gets open, core gets damaged and winding also gets damaged. That is always this type of precaution. Always ammeter if you want to measure. Otherwise, few substation will be there. Ideal substation means only for study purpose. There is no input, there is no output. Only just showcase purpose, means to learn how the substation is there, etc. At the time, simply what is it here? Shorted there. No need to connect the ammeter over there. This is what the complete precaution and corresponding. This is the problem and corresponding precaution. But people are getting one doubt, sir. You are shorting the line. If you're shorting the line, why don't we get complete damage? Come on here. What is the ammeter resistance? Very, 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 very low. 0.01, 0.02 like that. Instead of 0.01, 0.02 ohm, we are keeping zero resistance. Nothing will happen. Nothing will happen. One thing. Second thing, sir, it is shorted. It should be damaged. No, yeah, it is shorted means when the supply is very, 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 very large, current is also very, very, very large. If you're shorting, then the damage will be there. But already 0.01 resistance is there. But simply we are shorting like this automatically, no problem at all. That's why either ammeter should be there or simply a short path must be available, but it should not be opened at any cost. This is a total discussion regarding CT. What is it? Problem and corresponding precaution. But PT precaution is very, very simple. PT problem also. What is it? Suppose if the secondary of PT got short circuited, what will happen? Directly you can answer. Sir, what was there so far? Voltmeter was there. Voltmeter resistance is 1K, 2K, 3K, 4K, 5K. All I told you, voltmeter resistance is considerably high. So instead of high resistance, means in the place of high resistance, what is it here? Short circuit path is there. In the place of high resistance, short circuit path is there. Automatically, what will happen here? Right? Definitely, this entire winding gets short circuited. But the moment I said this, right? People will ask me like, sir, you told that here short, nothing will happen. But here short happens, damage. How? Means you need to understand that this is the series connected structure. Here, ammeter was there, which is having 0.01 ohm, 0.2 ohm, etc. Instead of 0.01 or 0.2 ohm resistance, we can keep short circuit, no problem. But here, instead of 1 kilo, 2 kilo, 3 kilo, 4 kilo, etc., can we keep the short circuit path? No, direct answer is once the secondary of the PT gets short circuited, the entire winding of the secondary winding, thereby complete short circuit. We can say simply PT get damaged. PT gets damaged directly. PT gets damaged directly. Clear? One thing. Second thing. Sir, what will be the precaution now? What is precaution now? Either open, keep it open. If it is open, yes, voltage is there. 1K, 2K, 10K, 20K, etc. Infinity, no problem at all. That's why voltmeter, highest resistance is infinity ideally. Practically 1 mega, 2 mega, or 1K, 2K, 3K, anything. Either it should be open or it should be simply connected with the voltmeter. So that's why generally I'm showing with the voltmeter. Clear? But generally this is normal point, but in this conceptual point is there. That's why specifically one by one I gave you. Clear, guys? And now I'm asking the question again. CT, which should not be happen. Secondary never be opened. Secondary circuit should not be opened. PT, secondary circuit should not be shorted. PT, secondary circuit should not be shorted. Clear? Right. People are asking that, sir, does this voltmeter sustain with 1 kilo ampere? Where you are sending 1 kilo ampere, 1 kilo, 2 kilo, etc. Current is flowing through this. So no, in this, what is it here? Correspondingly, current itself is not there. Very, very, very negligible. In this, current need not to worry. Negligibly only will be there. Only old. That's why be clear. PT only voltage. Currents will not be there. Even though those are there, very, very negligible, neglected. Here also same thing. Voltage will not be there. Only that is the reason. We kindly see the name. It is not the power transformer. It is the current transformer. It is the potential transformer. That's why be clear with the terminology. Okay, right. Right, very good. Bhavani, very good. Sir, while connecting or disconnecting the ammeter, open circuit will be there? No, very good question. Actually, I'm going to say that only. Be clear. It is in the line. It is in the line. You want to remove this ammeter, for example. Be clear. Simply one short circuit path they will provide, some switch element like that. Then they will disconnect this one. No problem. After that, okay, some other device, suppose I want to replace some other device I am keeping here. After keeping that, simply removing that corresponding part. In that way, corresponding precautions will be there. No need to worry. This is what the complete discussion regarding CT and PT construction in the substation line or transmission line, and correspondingly problems and precautions correspond. Clear? Now we are going to take ratios, 1 mark questions. After that, complete derivation part, and 2 marks question we are going to take. Okay, then take the break and come back. Take the break for 15 minutes of time and come back. In our subject, what is their lifetime is not the matter. Don't worry. That will be given by manufacturer. No need to worry. Come back, everyone. Right. Now let us take ratios in instrument transformer. Ratios in instrument transformers. There are three ratios defined in the instrument transformer. One is actual ratio. Kindly concentrate. This is the terminology. Based on this terminology only, all the practical theories are built up. So concentrate. Actual ratio. Right. This is also called as, this is denoted with otherwise actual ratio, or we can say transformation ratio. Actual ratio or transformation ratio. It is denoted with R. Okay. Right. Second one. Nominal ratio. Nominal ratio. This is generally denoted with Kn. Kn. And third ratio is turns ratio. Third ratio is turns ratio, that is denoted with N. Right? These are the three ratios we define. In the examination, in the GATE model, generally 1 mark model, directly they are asking what is a, find out the so and so ratio. Otherwise, what is a ratio error, etc. They are finding. So they are asking. So therefore, let us concentrate on this first one. What is the ratio? Kindly wait for 1 minute. I'll show everything. There are three ratios like this. The first ratio, that is instrument transfer, first ratio, transformation ratio, actual ratio. Directly formula only, that's I'm giving this. So this is defined as primary winding current by secondary winding current. Means during the operation of the transformer, during the operation of the current transformer, potential transformer, whatever the current is there, that is called as primary winding in the current transformer, primary voltage in the voltage potential transformer, like that. Primary winding current during the operation, secondary winding current during the operation. If you take this ratio, that is called as CT. Second one, primary winding voltage by secondary winding voltage, that is PT. Primary winding, right? Secondary winding currents and voltages, if you take, that is called as CT and PT. Okay, now, so given the statement, it is a ratio of the magnitude of the primary phasor to the secondary phasor. So what do you mean by this? Means phasor diagram will be drawn with respect to the values which are available during the operation. So therefore, yes, these are during the operation only. That's why the direct statement is, it is a ratio of the magnitude of primary phasor to secondary, means current by current CT, voltage by voltage PT. This is called as which one? Actual ratio. Direct definitions only I'm giving as a note. Next, what is nominal ratio? The nominal ratio is here. That is whatever the rated values are given, Kn is rated primary winding current. Sir, there also primary, here also primary, but their winding values, but here rated values. Therefore, nominal ratio means itself indicates rated values only. So rated primary winding current by rated secondary winding. So current by current CT, voltage by voltage PT. So rated primary, rated secondary. Okay, same thing here. It is a ratio of rated primary winding current or voltage to the rated secondary winding current or voltage. Kindly don't say here primary phasor or secondary phasor. No, primary phasor or secondary phasor means the phasor is the word to be used only for values which are there during the operation. But these are rated values. Rated values may not be there in the operation. So that's why those values separately. But one simple hint I'm giving to remember this, simple point I'm giving to remember this, concentrate here. Here, primary by secondary. Here also, primary by secondary. Everywhere, primary by secondary only. In these two ratios, nominal ratio. Clear? Now, the third one is turns ratio. So what is turns ratio? Turns ratio means based on the number of turns. Clear? What is it? Turns ratio. Number of turns on the secondary winding by primary winding, that is CT. Number of turns on the primary winding by secondary winding, that is PT. So therefore, the simple point here, sir, primary turns by secondary. Everywhere concentrate. Actual ratio, primary by secondary. Yes. Nominal ratio, primary by secondary. PT turns ratio also primary by secondary only. That's why only one thing you have to follow. CT, what is it here? Secondary by primary. In that logic way, you need to remember all those. CT secondary turns by primary turns, that is N. PT primary turns by secondary, that is PT. In that way, we have to take. But here one more confusion here is, sir, among the given values, among the available values, which is taken as a true value and which is taken as other value, means concentrate, true, actual. So automatically in the transformer, in the current transformer, in the potential transformer, in the instrument transformers, which is defined as a true ratio, R is defined as a true ratio. I'm clarifying this doubt now itself. Kindly concentrate. Kindly, no one should get the same doubt. So rated values must be taken as a true value. No, they have taken this as a true value, and all the theories are built up based on the corresponding terminology only. That's why this terminology based only all the discussions will be there. That's why I'm repeating this point. R is the true value. So rated value is always true. That is common. But in the transformer, reverse concept, based on this only, all the corresponding theories are built up. So take it for granted. That's why this is not the true value. This is the true value. Clear? Right. Now, so this some rated value is there. Suppose 5 amperes current is there. Do you say that in the primary winding operation time also 5 amperes will be there? Maybe, may not be. That depends on the practical condition. So therefore, definitely the actual ratio R is not equal to, the actual ratio R will not be equal to, which one here? Nominal ratio Kn. Actual ratio R will not be equal to nominal ratio Kn. Therefore, ratio difference will be there. No, yes, this is a rated value, this is a rated, and this is the value during the operation will be different compulsory. That's why we need to measure ratio error also. We need to measure ratio error also. So what is ratio error? The ratio error here is this one. The ratio error here is, what is the ratio error here? Simply AM minus AT by AT model only. But here, which is true value? I told you R is the true value. R is the true value. That's why Kn. I'm not saying that Kn as the measured value. No, Kn as the rated related ratio only. Rated values related ratio only. But R is the true value. That's why some other ratio minus true ratio by true ratio, that is called as ratio error. That is called as ratio error. That's why don't get confused. Like generally people are asking, sir, R minus Kn by Kn, Am minus At by At means this is becoming true value. But is it the true value? No. Which is the true value? R only the true value. In the instrument transformer, the theory is based on, all the practical theories are based on R as the true value only. R as the true value only. Clear? Right? After that, so phase angle error is denoted with theta. But what is the formula? I'm going to derive completely. No need for that. Phase angle error is denoted with theta. Okay. So suppose ratio error is there, right? Definitely ratio correction factor must be defined or not? Yes. How do we define ratio correction factor? In the starting of error analysis, I told you correction factor means what I told you, AM into correction factor is equal to 80. I told you. In our case, what is the true value? R. What is the correction factor? Ratio correction factor. What is the other ratio? I'm not saying that measure, but what is other ratio? Kn. So therefore, RCF is equal to R by Kn. Kindly I'm instructing everyone to follow the transformer theory, right? Why this is there, etc. Once you start the transformer subject, it will be clear. That's why I'm saying that in the transformer theory, based on the transformer construction operation and all, which is taken as a true value, R is taken as the true value. That's why other ratio minus true ratio by true ratio. But generally this doubt is common. Sir, rated values will be common. Rated values should be taken as the true value. No. In this concept, why means that you will study in the corresponding transformer notation. But as for measurement concern, kindly follow all this. Based on this only, all the practical theories are given. IN people take it for granted. Nothing is missed. No need to worry. These are the corresponding theories given. So that's why in the instrument transformer, three ratios: actual ratio or transformation ratio, nominal ratio, that is rated values, turns ratio, and correspondingly ratio error and ratio correction factor. This is the simple introduction regarding ratio error notation. Right? Now on this, let us have some numerical questions. Simple topic. Let us have some numerical questions. Try this. Kindly make it fast. Right. Right. Very good. Many people give the correct answer. Now, what is the point here? Simply, here first, 200 by 1 is given now. Kn nominal ratio 200 by 1. So that is 200. And actual ratio R is equal to primary current by secondary current. Primary current by secondary current. What is the primary current? 100 amperes by secondary current 0.495 amperes. Therefore, you'll be getting 202.02, I think, approximately, right? Finally, ratio error equal to, what is the formula? Kn minus R by R into 100. Kn 200 minus 202.02 by 202.02 into 100. Clear? What is this value? Many people give that answer as D. Many people give that answer as D. Is it D or A? Is it D or A? Come on. Is it D or A? What is it? Minus 1%. It's a minus 0.9 something, etc. Minus 1. Be clear. Right? And people are asking that, sir, this is the transformation ratio in instrument transformer, not in your power transformer. In your machine subject, you study power transformer. That is different, and this is different. Both are transformers only, but application wise, construction wise, operation wise, everything is different only. That's why kindly see the name. Our topic is instrument transformer. It is connected in parallel or series to measure the larger voltage and currents. But in the power transformer, in your machine's subject transformer, you are not using the transformer for measurement purposes. That's what the point. Clear? Right, this is the simple question. Now, very, very, very important question here is, one second. We'll take this question later. But I'm giving one point directly. Note our question as you wish. The primary current in a CT depends on just for idea purpose, I'm giving only two options: load current secondary winding current or something else. Two options I gave you. Which is correct? Right, few people first option, few people second option. Very good. Concentrate. Yes, there is a chance to get confused with this question. No problem. What people are thinking, okay, primary current in the CT measured by secondary current. So secondary current. I am not asking measurement. What is it here? The primary current in a CT depends on. I am not saying that the primary current in a CT measured by. I'm not asking depends on. Let us go back to the main topic. Let us go back to the main diagram. Check it here. Kindly concentrate. This is the primary current flowing through the CT. Depends on which one here? Load only. Concentrate. I1 based on the load only. But how much I1 is there? That is measured by this. But don't think like here. So I2 depends on I2. No, yeah. I1 is measured with the help of I2. I1 is measured with the help of I2, but not I1 depends on I2. No, yeah. I1 measured with the help of I2. Are you getting? So therefore, my question is I1 depends on means the I1 is decided by, I1 is depends on load only. So therefore, what the answer here? The primary current in a CT depends on, otherwise I'm adding one more statement, depends on or decided by, which one here? Load current only. Based on the load requirement, some large current will be there. How much value is there? That we are measuring with the help of secondary current. But I'm asking this value depends on which value? This value depends on load current only, or load, we can say. Load or load current. And one student is asking that, sir, Kn rated primary by rated secondary means it is 1 by 200, sir. You're taken 200 by 1. Concentrate here. CT primary, large current, secondary, small current, large current primary, IP by small current secondary. I have taken 200 by 1, primary by secondary. He has given that only. Right. Okay. Right. Few people gave this answer. I hope after my explanation, if you listen carefully, it is clear. What is it? It is not the question related to measured by which one, measured by which one, yeah, secondary current, secondary winding. But I'm saying that in the circuit, I1 is there. How much I1 we don't know, but whatever the I1 is there, that I1 is depending on, decided by the load only. That's why try to understand the question. This is previous gate model question only. In this way, confusingly, many people answer that, okay, primary current is measured by secondary. Primary current, how much is there? That is measured by secondary current. But I'm asking that how much current will be there? How much current should be there? That depends on corresponding load. That's what very, 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 very important thing. Clear? Conceptual question. Right after that, sir, current transformer theory I'm taking. Current transformer theory. So what is a current transformer theory? Consider in our syllabus, GATE or ESC, only current transformer theory. What are the things we have taken so far? That is there. But what are I'm taking here? Current transformer theory. That only there. Don't worry. Potential transformer theory is not there in any competitive examination. No need to worry. Okay. First of all, sir, what is CT? What is CT? I am taking transformer symbolic representation. Primary number of turns are only 1 or 2. Okay. And secondary number of turns are very, very, very high number of turns or more number of turns. It's very simple. Sir, N1 less than N2. Here, I1 greater than I2. Which one? Step up transformer. Step up transformer. Already we have taken this. Okay. Now from this, I'm going to draw the equivalent circuit. Right, whatever the transformer equivalent circuit is there in the machines, I'm taking that only. After that, what is my topic, I'll take it. But IN people, it might be completely new to you. But electrical people, already in the transformer subject, you know that only I'm taking first. But after 5 minutes of time, my measurement subject will be done. We'll be starting. Yes, everything will explain clearly. Right? Only 1 or 2 turns. Only 1 or 2 turns. Primary. And here, secondary, more number of turns. Consider, guys, sir, this secondary impedance I am showing separately. Means this is the secondary winding. It has resistance and it has reactance also, that I'm showing separately for clarity purpose. But don't think like, sir, winding is series with this one. No, guys, everyone, those who are on the line, this doubt will be there. I'm clarifying now itself. Sir, secondary winding is in series with this one. No, secondary winding, resistance I'm showing separately, reactance I'm showing separately for clarity purpose. Okay, and here some load will be there. Some load will be there, but generally load means which one? Yeah, voltmeter only. We don't connect the normal load at all because we are having only measurement procedure, not the power transferring with it. That's why this is load symbol only, but I'm writing simply voltmeter notation. So simply V2 here. Voltmeter acts as load for PT ammeter acts as load for CT, but not the actual load at all. And here E2 will be there. This current is I2. This current is, right? I2 you can write, or IS you can, secondary we can write. This current is I2. Clear, guys? Right? Now the question is, sir, primary side also concentrate. Here generally doubt will be there for instrumentation people, especially concentrate. So this primary impedance, R and X I'm showing. This is R1, this is X1. R1, X1. Okay. After that, supply is given. Right. But be clear, sir, under no load condition, generally transformer will be operated. So that's why the no load branch will be taken like this. Electrical people, they are aware of this, but IN people, how this diagram is coming and all, that is based on the mission topic. Simply no load you take it, but for you also transformer subject is there. I will take that clearly. Only for equivalent circuit I'll be spending. For you people instrumentation, I'm spending almost 30 to 40 minutes of time. Don't worry. As of now, only to get the concept, I'm taking this. So no load branch, resistance and reactance both will be there like this. This is denoted as R0, X0, and this current is I0, no load branch current, very small current. We can neglect it if it is not given some places. We can neglect it normally. Okay, and this I0 has two parts. One is through X0, this is called as IM, and this is called as IC. Okay, sir, this current related current will be there in the primary. Why? This is from the corresponding this only, that will be taken as I2 shifted to the primary 180 degrees. So I'm writing as I2 dash. So I0 plus I2 dash combinedly called as I1. This is the general transformer equivalent circuit. Our transformer is CT. That's why I'm specially mentioning with number of turns like this. This is our CT. Okay. Here induced EMF E1 will be there, etc. No need to, just idea purpose and I'm showing. Clear? Now the question here is, definitely this doubt will be there. So why this winding here? Why this winding here? I'm clearly, openly saying that electrical people, you study in your missions. Is it no? Because this is not at all my topic. But from this, I'm going to take my measurement topic. That's why for clarity purpose, I'm taking this. But if I don't take here, you cannot understand what parameter I'm taking, where it is there, added, subtracted, etc. And IN people also, yes, in the transformer, it will be explained. But I'm not concentrating on transformer. I'm concentrating on which one? Current transformer concept. So that's why I'm taking this entire thing as a just what is a note purpose. Okay. Now you can write I1, that is primary, or you can write IP also. So therefore I1 or IP, no problem. I2 or IS, no problem. That is S means secondary, P means primary. So therefore NP less than NS. That's what the simple logic. Now I'm going to start the corresponding instrument transformer actual concept and all. Clear? First of all, be clear. Transformer is called as what is it? Constant flux device. So generally, so transformer, we are going to take flux vector as the reference. Concentrate, flux vector as a reference. Okay, sir. Here, this is the current related to which one here? IM means inductive. Inductive means magnetization element. So IM is called as magnetizing component of no load current. I will give all the terminology. What are the names of these? Everything I'll give you. But let me take the concept first. IM, magnetizing component of current. So magnetizing current and its magnetic flux both will be in phase. Already told in the energy meter. Flux and current correspondingly both will be in phase. So therefore I'm taking this as IM. After that, sir, if this is IM, where will be IC? Means very simple. This is the pure inductive part. This is the pure resistive part. Automatically, which will be lagging here? The inductive part will be lagging. So therefore, by how many degrees? Pure inductor, pure resistor, 90 degrees difference is there. So that's why if this is Im, automatically this will be IC. I'm coming again. Y means concentrate. Magnetizing component of current will be in phase with flux, because current and its own flux both will be in phase. And this is the pure inductive current, that is pure magnetizing current. Resistive current will be which one here? 90 degrees. See, Im lags the IC by 90. Why? This is inductive component of current. Okay. Now, sir, in this figure, IC and Im combined, which value? I naught. So therefore, I'm writing here I naught is equal to IC and Im. I naught equal to IC and Im. Okay. So therefore, simply I'm taking the vector combination here. Therefore, this vector will be I naught. Actually, for electrical people, this entire phasor diagram already done so many times in their mission subject, transformer. But I'm repeating again to bring my topic here. Okay, after that, sir, here, based on the flux only, EMF is induced. What is that? E2 I'm taking. So where will be E2? Based on this flux linking only, E2 will be there. All I told you in the energy meter topic that E2 will be lagging the voltage by 90 degrees. Sorry, lagging the flux by 90 degrees. Clear? This is which value? E2, 90 degrees here. Why 90? Induced EMF lags its own flux by 90 always. Okay, now the point here is, sir, from this E2, how do you get other things? How do you get other things? Be clear, guys. Sir, E2 is there. From this circuit, sir, E2 is the induced value. This is the drop in the winding. So therefore, what we can write? E2 minus this drop is equal to V2. This is simple circuit concept. E2 minus this drop is equal to V2. I hope everyone understand this. What is it? Current is flowing like this. This is the induced value. From that, this is the drop in the winding itself. Rest of the thing will be output. So therefore, what we can write now? E2 minus I2 Z2 is equal to V2. Otherwise, E2 is equal to V2 plus I2 Z2 vector combination. Sir, already V2 is there. Already V2 is there. Now, concentrate. Sir, here among V2 and E2, which will be lagging by which one? Which will be lagging by which one? Be clear. Very simple. Sir, E2, right? So minus drop equal to V2 means what is it? V2 plus inductive drop. V2 plus inductive drop should be equal to E2. Based on this, what we can say here, based on circuit concept, V2 lags the E2. So therefore, I'm taking this here. This is V2. This is V2. So why V2 always left side of E2? Why not right side? I'll prove it. Simply V2 comes here after that. Sir, V2 should be added to I2 Z2. Sir, what is Z2 again? V2 plus I2. Z2 is R2 plus JX2. R2 plus JX2 because R is there, X is there. So therefore, I2 R2. In order to get I2 R2, you need to have I2. That's why now tell me I2 and V2. What is the relation between these two? Means be clear. Load is generally lagging. Load is generally lagging. Or otherwise, sir, actually here MI voltmeter is there, sir. Yes. MI ammeter is there, sir. Yes. In the MI ammeter, what is the equivalent circuit I have taken here? RL. Coil will be there. RL will be there. RL means automatically lagging only. Don't say that MI voltmeter capacitance, but this is MI ammeter. Only RL circuit, lagging circuit. So I2 lags the V2 by some angle, we don't know. So therefore, here I'm taking this is I2. This is I2. Sir, I2 lags the V2 by how much angle here? 5. Simply some 5 degrees will be there. That depends on the corresponding voltmeter structure, etc. Clear? Right. Now, very important here. Sir, I2R2 is which drop? I2R2 is which drop? Resistive drop. Sir, resistive drop should be in phase with current or lagging with current or leading with current. Means I2R2 is a resistive drop. Resistive drop always in phase with the current. So therefore, concentrate. This is which value? I2. So therefore, we need to add I2R2 to the V2 vector. But be clear, this line and correspondingly this I2. Check it here. This line and this line both are parallel, both are in phase. This and this both are in phase only. But be clear, guys, what people are doing mistake, here only they're adding like this, but they're writing V2 like this, they are writing. So this is, what is it? I2, 1 second. They're writing like this, I2R2. Sir, I2 is the current vector. I2R2 is the voltage. Can we say 3 amperes plus 4 volts equal to 7 watts? 3 ampere plus 4 volt equal to 7 or something? No way. That's why current and voltage cannot be added. Current and voltage cannot be added. That's why you need to concentrate that. Which one? Here. V2 only to be added. But where? In phase with I2. Sir, why? This drop is I2R2. Nothing but in this entire thing, complete AC circuit analysis fundamentals means BTech electrical circuit fundamentals only. But I'm revising all this. Okay, I'm coming again. So V2 should be added to I2R2. I2R2 should be in phase with I2. I2 already there. So in phase means parallel to this line. After that, sir, I2X2 definitely 90 degrees with R2. Yes, like this. This will be 90. I2 X2. Sir, I2 or V2 plus I2R2 plus 90 means J. J I2 X2 is equal to E2 vector. So that only we have got it. Yes, this is done. Okay, secondary side we have done. Sir, I2 should be reverse I2 dash. So therefore, this is I2. This is I2 no. So therefore, I need to reverse this vector. Right? What is this? This vector is I2 dash. This vector is I2 dash. Because I2, 180 degrees shift, I2 dash will be there. Sir, after getting that, see that. Sir, I2 dash and I0 combinedly getting I1. So therefore, automatically, what's the value now? Here. I0, I2 dash joined here. What will be there? Here. This combined value will be which value? IP value. Nothing but I1 value. This just disconnection. Right. Kindly concentrate here. Sir, IC and IM both will be differed by 90 degrees. So combination will be equal to I0. Combination will be equal to I0. After that, induced EMF lags the flux by induced EMF E2 lags the flux by 90 degrees. All I told in the corresponding energy meter structure. After that, sir, V2 will be here. Then only I2R2 plus I2X2 will be equal to E2 vector. And the two I2 lags the V2 by some corresponding angle based on the moving and voltmeter. Finally, I2 is reversed I2 dash. Finally, I0 I2 dash combination is I1. I0 I2 dash combination is I1. So this is what the total thing. But in the examination point of question point of view, concentrate. Where I told here 1 means primary, 2 means secondary. That's why half of the data I'm following with 1, 2 numbers. Next half of the data I'll be following with P and S, primary and secondary notation. Okay, concentrate here. After getting this in your machine subject, you will get all these things up to this. But now with this, with the help of this, I'm bringing my measurement topics as it. Concentrate, guys. What I'm doing now, sir, I'm extending this line. I'm extending this line and like this, right? If I extend like this, in this entire thing, there are, this is O, right? This is O, and this is A, this is B, and this is C. So O, B, C, one triangle, concentrate. O, B, C, one triangle. In the same way, A, B, C also one more triangle. Our total measurement topic is here only. So kindly be clear. Right? Now I'm taking, concentrate guys. First, here the angle between these two. The angle between these two is delta. What is that? I2 and E2 angle between this delta. And angle between these two is alpha. Angle between these two is alpha. Okay. What is alpha? No load. I0 related angle. No load angle we can say. Delta, secondary circuit angle. Secondary circuit angle delta. First point. Sir, here, concentrate guys, concentrate. Sir, this is the current related. Everyone, very, very, very important points. I'm going to start now. Sir, IC. IC is which current? Current through the resistive notation. Means with this current, drop will be there. No. So that is the reason why this IC must be as small as possible or as high as possible. Means IC must be as small as possible because the drop power loss we can say should be less. So therefore, first one, IC must be less. Sir, if IC is less, automatically I0 will be less. Means no load current. Under no load condition, if the transformer is drawing the more and more current, we don't accept it. Only small current, no problem. So I0 is also less. Sir, if I0 is also less, alpha will be also less. Kindly concentrate. People are asking, sir, why these are less? Conceptually, these should be less. Thereby, the manufacturer also designed the things related to very, very, very low notation only. One thing. Second thing. So delta must be low or delta must be high. Delta must be low or delta must be high. Means, sir, delta, which one? I2 and E2. Is it no? I2 lags E2 means secondary circuit. If delta is more, secondary circuit is more lagging. If more lagging, already approved, more lagging, more losses. Less lagging, less losses. That's why what we say, delta is also very, 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 very less. Right? All these must be less and will be design the circuit also correspondingly less only. They will design the circuit like less only. No need to worry at all. This is what the point. Now concentrate here, sir. This is anyway 90 degrees. Anyway, 90 degrees. Okay, sir. O, A, B, C is there. No, O, A, B, C is there. Sir, what is AC magnitude? First point, AC magnitude is I0 or not? Sir, I0 only parallelly we have drawn for this vector combination. That's why the first point here is AC is I0. Okay, after that, sir, what is O and C? OC is I1. OC is I1. OC is I1, nothing but I primary I'm writing. I primary. Next, sir, concentrate, guys, concentrate. Sir, OC, okay. OA, oh, sorry, OC, okay, AC, okay. Now, what is OA? O to A, which one are I2 dash. So, therefore, OA is I2 dash. I'm writing as IS dash. 2 is secondary, S means secondary. Okay. After that, very, very, very important point. Sir, from this, sir, what is BC and what is AB? AC already known. AC is I naught, but what is AB and BC? That's why concentrate here. We need to calculate this angle. Sir, what is this angle? What is this angle? From the phasor diagram, I told you, no, if a phasor diagram is given with all the angles, this is 7th, 8th, 9th class topic only. Can you tell me what is this angle? This angle. All the mathematics I gave you in this, what is this angle? Tell me. I'm giving 2 minutes of time. What is this angle? Your mathematicians, before giving the answer, kindly think that, okay, I came from mathematics background. I'm doing BTech electrical. Come on, guys. Come on. Come on, make it fast. Ninety minus alpha. 90 minus, yeah. 2, 3 people give the correct answer. Ayush guy, pi by 4. From where you got pi by 4? In the phasor diagram, pi is there. Right, very simple. How to get it? Concentrate here. Very, very, very simple. See, okay, stop thinking, kindly concentrate. I'm making one vertical line like this. I'm making one vertical line, one horizontal line. Sir, what is this horizontal line? It is also horizontal line. This is I naught. This is also I naught. So therefore, what will be this angle here? This angle is alpha. Now, sir, this is vertical line. Yes, this is vertical line. Okay, and this is I2 or IS. This is I2 dash line. So therefore, this angle is which one here? Delta. So therefore, this is right angle 90 minus delta minus alpha. Therefore, few people, only 2, 3 people give that 90 minus delta plus alpha. 90 minus delta plus alpha. Right. Clear? 90 minus delta plus alpha. Now tell me, sir, what is AB? AB is the adjacent of this angle. So AC cos. So therefore, Mathematics only. AB is equal to AC cos 90 minus delta plus alpha. What is that? AC. AC means I naught. Cos 90 minus something. What is that? Sine delta plus alpha. After that, BC. What is BC? Check it here. BC also same thing. Angle opposite. Angle opposite. BC angle opposite. So therefore, what is it here? AC sine 90 minus delta plus alpha. Therefore, AC means I naught. Sine something means cos of delta plus alpha. Cos of delta plus alpha. Clear? So these are the things observed from the corresponding phasor diagram. But I'm repeatedly saying many people might be thinking that, so this is very tough. It is not at all tough for electrical people, and electrical people should not say this as tough, because complete thing, everything is transformer phasor diagram only. That too, I have not taken blindly. I have drawn, I explained again also by thinking that you might have forgotten. But only what modification I have done here? I have extended this line. Blue color is there, no? I have extended this. That only the new thing. But IN people, everything is new to you. Kindly step by step you follow. But especially I'm saying that after today's class, definitely everyone should practice this phasor diagram along with this circuit diagram. Sorry, what is it? Connection diagram compulsory. Right? After that, mathematics is there. Why I'm taking this mathematics means in the mathematics also small concept is there. Otherwise, take the formula, get it. But I'm giving the complete derivation for concept purpose. As I'm giving this entire derivation for concept purpose, don't get confused with this kindly. Okay. After all this, after taking all this, now I'm starting the mathematics. Sir, in the triangle, in the corresponding triangle, concentrate here. Sir, OCB, it is a right angle, sorry, OBC is a right angle triangle. OB one side, BC one side, and what is it here? OC is the hypotenuse. So therefore, Pythagoras theorem. What is that? OC square equal to OA square. One second, I'll be showing. OC square equal to OB square plus BC. Let me write clearly. OB square plus BC square. Sir, what is OB? OA plus AB square plus BC square. Clear? Sir, what is OC? OC is IP square. What is OA? IS dash plus AB I naught sine delta plus alpha. I naught sine delta plus alpha plus BC. What is BC? I naught cos delta plus alpha whole square. Right? That's why practice more and more related to this one. Actually, our topic is only this, but in order to get this, everything is required. That's why I've taken this entire brush. Other than that, only formally follow also, you can answer as far as my topic is concerned. But total concept is remember, right? Right. Now, sir, I'm expanding this. A square plus B square plus 2AB model. But, sir, in the place of IS dash, what I'm keeping, concentrate, turns ratio is there. What is the turns ratio of CT? Secondary current by primary current means IS by IP. IS by IP. Okay, but try to answer, try to understand, sir. This is the secondary current. Secondary current IS as it is. IS as it is. Kindly, 100% get the doubt on this. Concentrate, sir. If this secondary is equated to primary, if this secondary is equated to primary, what will be the current? IS becomes IS dash. So therefore, secondary when referred to primary, IP primary is which is there here, IS dash is there. But I am not saying that IP and IS both are same. No, and that's why I'm writing here simply. What is it here? Approximately. Why? IP is nothing but I naught and IS dash. I naught is very, very small. Look, I'm neglecting. That is one point. Second point here is, sir, I'm repeating this point. Definitely, even for electrical people also, genuine doubt. Sir, secondary current IS as it is. Secondary current IS as it is. Primary current means secondary current when we are referring to the primary. IS becomes IS dash. So therefore, IS dash. Therefore, what we can write simply, what is it? Here, IS is equal to, or IS, one second, I have to written the reversal. Here, what is that? N2 equal to, number of turns equal to, come on guys, total, I have written the reversal. So, number of turns is equal to, sir, number of turns, secondary turns by primary, I have reversed, wait, reversed, right? What is that? NS by NP. What is it? Number is a turns ratio. Turns ratio means secondary turns by primary turns. Sir, N2 by N1 means, what is it here? I1 by I2, reverse, right? What is I1? IP by IS. No, check it. Sir, secondary current is IS as it is. Same concept, same concept. But secondary current referred to primary. In the primary side, in the place of IS, which is there, IS dash is there. So therefore, IS dash. You can write approximately, no problem. Therefore, IS dash is equal to N into IS. IS dash we can write equal to N into IS. I'm coming again. Sir, turns ratio is secondary number of turns by primary number of turns. Secondary number of turns means NS, primary means NP. So N2 by N1 means I1 by I2. We know relation between current and turns. So primary by secondary. Secondary current as it is, IS is there. As it is, IS is there. But IS is referred to the primary. It becomes IS dash. So IS dash. IS dash is equal to N into IS. Clear? So this is the terminology. Clear? Now, in the place of IS dash, I'm keeping N into IS. So therefore, what is that? IP square equal to N into IS plus I naught sine delta plus alpha whole square plus I naught cos delta plus alpha whole square. Now let us expand this. Sir, A square plus 2AB or B square as usual. I'm writing 2AB, 2 into A into B plus B square I naught square, otherwise simply leave it. Okay, I naught square sine square delta plus alpha plus, this is there no, what is that? I naught square cos square delta plus alpha. Sir, sine square and cos square both will be equal. Right, both will be equal. See, I told you this I naught is not neglected. Approximately, I'm talking about I2 to I2 dash relation only. That's why don't say I naught is completely neglected. No, it implies that only. But simply secondary current IS as it is. Secondary current IS as it is. And then primary said secondary related primary current is IS dash. That only I've taken. But no need to write specially I naught is neglected. This implies. Okay, right. Now, here, sir, N IS whole square plus 2 NIS I naught sine delta plus alpha plus sine square cos square 1. So automatically I naught square into 1. I naught square into 1. Clear? Okay. Now the question here is, for this point, actually the main reason of taking this is one of the main reason of taking this entire derivation is, sir, here I naught is very, very small. I told you no load current. All I told you here, I naught very small. Let me take 0.2, 0.3. I naught square, 0.2 square, 0.04, further less. Clear? So therefore my point is I naught and I naught square very, very less. So therefore, can we write like this? I naught square as I naught square is very, very, very less. Right? Therefore, can we write like this? I naught square is approximately, not exactly, approximately equal to, what is it here? I naught square sine square delta plus alpha. This is very, 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 very important point in my entire derivation. This is a conceptual point. Concentrate. I naught is very small. I naught square is also very, very small, undoubtedly. Okay. Sir, I naught square small. Sir, delta small. Alpha small. Sine delta plus alpha small. Sine square delta plus alpha also small only. These two are approximately same. That's why we can replace I naught square with the I naught square sine square plus sine square delta plus alpha. Very, 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 very important point. Otherwise, if I take the formula directly, people are getting stuck up here. So after this, how did you get the sign, etc.? That's why I'm coming again. I naught square is very less. Delta is very less. Alpha is very less. Therefore, sine square delta plus alpha is also very less. So therefore, these not exactly equal. But all I told you, while you are deriving something, small values are there. If you want to neglect, you can neglect it. That's what the point. Small value is there to be add it like that. We need to take it. So therefore, what we can write now? IP square is equal to n into is square plus 2 nis I naught sine delta plus alpha plus, in the place of I naught square, I'm writing like this. What is that? I naught square. What is it here? I naught square in the place of I naught square, this one. I naught square sine square delta plus alpha. But everyone, those on the line, keenly observe the screen. In few textbooks, these two are not given. In few textbooks, these two are not given. Directly, this statement is given. Sir, what is it looking like? NIS whole square, correct? 2AB term, correct? I naught sine square delta plus alpha, correct? Sir, I naught cos square delta plus alpha. Neglected. Is it neglected? No. Delta very small. Alpha very small. Cos small value, large. Large value can neglect it here. No, that's why we have not neglected this. For showing purpose only. Sine square, cos square, I have taken. Cos square is being taken 1. After that, this I naught square is taken as I naught square sine square delta plus alpha. That is what the point. But I'm repeating, these two steps are not there in many textbooks. Don't get confused that this is neglected. No, actual theory is this. Right? This is a procedure. Why can't we neglect? Means whenever the small value is there, we can add it, we can remove it. But if you're adding to simplify this, and people are asking, kindly wake up, don't sleep. Why delta small? Already told you. Why delta small? Already told you. Right? Now, come back here. After this, so a square plus 2ab plus b square. For this purpose, concentrate here. Shivateja, right? Why we are adding this term means, suppose I'm removing this one. A square plus 2ab, no simplification. That's why a square plus 2ab plus b. That is what the very, very, very important point in the, what is that? Derivation point of view of any subject. Wherever small value is there, you want to neglect it. Wherever small value you want to add, you can add. That is what the that is what the main point in the derivation point, right? So a square plus 2ab plus b square. So I'm writing now. Therefore, ip square equal to a plus b square. A plus b whole square. So a square plus 2ab plus b square. This only there. So therefore, in order to simplify like this, we have added the terminology. I have added the terminology. Okay. So therefore, IP is equal to, what is that? Square we cancel, n into is plus I naught sine delta plus alpha. This is the entire procedure to determine the primary current in the CT. After that, now first point in this, actual ratio. Actual ratio. What is the actual ratio formula? R. What is the formula of actual ratio? Primary winding current by secondary winding current. IP by IS. IP by IS. Sir, what is IP? This one. NIS plus I naught sine delta plus alpha by IS. Now we can say IS cancel. So therefore, N plus I naught by IS sine delta plus alpha. This is the formula of actual ratio. In your GATE paper or ESC paper, 2 marks question, the GATE, ESC anyway, 1 question. They will be giving like no load current they will give, secondary current they will give, directly or indirectly. Delta alpha both may be given or any one may be given, I'll tell you. And turns ratio indirectly, find out the actual ratio, means you can use this formula. Say, without this entire thing, if I give this formula directly, and remember this, my point is very simple, but you'll be having the doubt like how this formula, etc. That's why to have the overall idea, I have taken the corresponding mathematical discussion. And this is one formula, but I'm modifying still, right? N plus I naught by IS sine A plus B sine A cos B plus cos A sine B. This is a modifying because based on the data, sir, N plus I naught N plus here simply IS I'm writing. Sir, if you go to the phasor diagram, concentrate, kindly focus on this triangle. Focus on this triangle. Sir, what is cos alpha? What is cos alpha? Cos alpha is equal to adjacent IM by hypotenuse I naught. So what is sine alpha? What is sine alpha? Sine alpha is opposite. Opposite means IC. IC by I naught. Clear? No, sir. I naught cos alpha can be written as IM. I naught sine alpha can be written as IC. So therefore, I naught cos alpha IM. Okay, here I'm writing. What is that? I naught cos alpha IM into sine delta plus I naught sine alpha IC. I naught sine alpha is IC into cos delta. Clear? You can use this formula also when only delta is given. Here delta plus alpha both are there, you can use. If only delta is there, you can use this. This is formula. Suppose all I told you, so delta is very low, so therefore what we can write now as delta is very low and delta is equal to 0 approximately. I'm taking approximately. What we can write now? R N plus, sir, sine 0 0 cos 0 1. What will be there here? IC by IS. Based on this formula, earlier paper question is also there, and he asked that find out the approximate actual ratio. Find out the approximate actual ratio, that is N plus IC base. IC given directly, IS given, N is also turns ratio given. Simply R equal to N plus IC by IS. This is also correct, but this is not the exact formula. This is approximate formula, but these two are exact formula. Right? Actually, this slide is very important, final value. But so far we have taken complete concept step by step to get the theory. Clear? After getting this, right? What is that? Ratio error. Ratio error. Sir, what is ratio error? All I told you now, KN. KN means nameplate details, rated values they will give. R we have determined. R we determined by R into 100. In this way, you can measure the ratio error. This is one calculation. But ratio error Kn will be given in the question, but R may be given directly or may not be given directly. In the earlier topic, we have taken few questions, 1 mark question we have taken. In this R, we can calculate directly without any internal construction parameters. But if you're going in depth, what is it? Based on the internal correction parameters. Yes, any data may be given in the question. Those are 2 marks models in the examination. That's why current transformer, potential transformer concept is simple, but mathematics is very, very lengthy, because transformer concept and this concept will be same overall way, but mathematics only lengthy. At everyone, at any cost, this, and this, these 3 formulae to be remembered at any cost, to be remembered at any cost. Clear? Right. Now, sir, ratio error is over. Ratio error. Sir, I told you, phase angle error also will be there. What is that phase angle error? Phase angle error. Now, kindly concentrate. In this also, by giving the concept only, I'll go to the mathematics. I'll go to the mathematics. Ankur, can we convert R to Kn by putting I naught equal to 0? How? Right. Next. Sir, phase angle error. Sir, what is this phase angle error? Very, very important. Concentrate. I'm going back to this. Kindly concentrate on this figure. Sir, I2 is here. I2 is here. I2 dash, nothing but IS dash. Anything you can take, no problem. Both are same. Sir, generally in the transformer, no load current must be as small as possible. No load current, that is simply no load current must be as small as possible. No load current, I'm repeating, as small as possible. Why? Under no load condition, do you want to lose much energy in that? No, under no load means load is not connected. But in the machine, loss will be more. We don't expect. So therefore, under no load condition, losses must be low. Therefore, I naught must be low. But ideally, I naught must be 0. When? Ideally, I'm talking here, ideally, not practically. Ideally, I naught should be 0. So therefore, if I naught is 0, concentrate guys, concentrate. If I naught is 0, automatically, sir, I1, that is IP and IS dash, both will be same or different. I'm coming again. I naught is 0, automatically IP and IS dash both will be same. Yes or no? Therefore, ideally, what we expect, I know IP and IS dash should be same, but no load will be there. No load will be there. That's why these two are different. That's why, be clear here. IS dash and IP, angle between these two is theta. This is called as, but just 2 minutes, concentrate. This is called as phase angle or phase angle error. Both are same here. What is that? Phase angle error or phase angle, both are same. Sir, phase angle error or phase angle, how both are same? Very, 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 very important point. Concentrate. Sir, ideally, what you're expecting, I naught is 0. If ideally I naught is 0, automatically IS dash itself equal to IP. What is the theta value? If IS dash is equal to IP, concentrate, IS dash is equal to IP, automatically theta value will be 0. So therefore, first I'm writing now. Sir, ideally, I naught is 0. It implies IS dash is equal to IP. It implies theta is equal to 0. So ideal case means theta will be, ideal case means the whatever the value you're getting, that is true value or measured value. Ideal case, so simply true value. What is the theta value? True value. What is that? 0 value. Okay. Practically means measured value. I naught is not 0. Therefore, IS dash plus I naught is equal to IP. Therefore, theta is not equal to 0. This which value? Measured value. Sir, what is the error formula? Error is equal to measured value minus true value. What is the measured value? Theta. What is the true value? 0. So therefore, error equal to theta. Which error? Phase angle error. So that's why either phase angle or phase angle error, both are same. How much phase angle is there? theta. How much phase angle error is there? Theta. Why? True value is 0. In order to have this entire idea, still I'm spending time. Simple logic here. In my experiment, true value I'm expecting 0, but measured value I'm getting 5 volt. How much voltage is there in the circuit? 5. How much error is there in the circuit? 5 minus 0, 5 only. That's why available voltage is 5 and error is also 5 when true value is 0. That is what our topic. Yes, true value. That's why in the examination, find out the phase angle or find out the phase angle error. Anything may be given. Both will be same only. Both will be same. With this entire introduction, now entering into again CT topic. Now concentrate, sir, in this. Here, concentrate here. This theta is there. No, I'm writing tan theta. What is tan theta? Tan theta equal to opposite by adjacent. What is opposite? BC. Adjacent OB. So simply, what is it? Here, tan theta is equal to BC by OB. What is BC? As it is, OB means OA plus AB. OA plus AB. Sir, what is BC? Concentrate again. BC we have written already. I naught cos delta plus alpha. I naught cos delta plus alpha. What is OA and AB? What is OA? OA is IS dash. OA is IS dash means N into IS. So therefore this. And AB is I naught sine. So therefore N into IS plus I naught sine delta plus alpha. Sir, I naught is very small, delta is very small, alpha is also very small, and n number of turns ratio secondary turns by primary turns. Yes or no? So therefore, in that way, compared to this entire thing, this is a no load branch, very small. So therefore, what we can write as I naught sine delta plus alpha is far less than NIS. What we can write? Tan theta is equal to I naught cos delta plus alpha by N into IS. Okay, after that, one more thing. Sir, this theta or this error theta, we expect large magnitude, we expect small magnitude. Concentrate. I naught is to be very low means the corresponding angle theta should be very low. How? Kindly check it in the figure. Concentrate. In the figure, kindly check it. If I naught is very small, I naught is this one only, or I naught is this one only, automatically this theta value will be very less or not. Why? I2 dash plus I naught equal to IP angle theta. That's why as I naught is expected very less, theta also expected very less only. Otherwise, sir, phase angle error expected is low or high means obviously low only. So that's why be clear. What we can write now? As theta is to be very low, actually as theta is very low, we can say theta is to be very low or theta is very low, we can say mathematics only. As theta is very low, tan theta approximately written as theta. So therefore theta is equal to, what is the formula here? I naught cos delta plus alpha, I naught cos delta plus alpha by N into IS. This is one formula of phase angle theta, phase angle error theta. Otherwise, same expansion. I naught cos A plus B, cos A, cos B minus sin A, sin B by N into IS. This is also one more formula. When cos delta, cos alpha, both are 100, no problem. Again, same thing. Sir, in the phasor diagram, I naught cos alpha is IM, I naught sin alpha is IC. So I naught cos alpha, IM. Here in this, I naught cos alpha Im. So Im cos delta. Theta is equal to Im cos delta. I naught sin alpha Ic. So therefore Ic sin delta by n into Is. It is also one formula. When delta alone is given, this is one formula. Clear? Right? After that, here, sir, as delta is very low, what we can write now? Approximately delta equal to 0, approximately. Therefore, what we can say here? Theta is equal to delta 0 sin 0 0 over cos 0 1. So therefore Im by n into Is. This is the approximate theta formula, but radians only. If you want to have degrees, theta is equal to 180 by pi Im by n into Is. This is what the phase angle error theta. In the phase angle error calculation, percentage they will not ask. Phase angle itself is in terms of degrees they will ask. That's why phase angle error theta simply, what is it here? Here I told you phase angle error or phase angle error theta only in terms of radians only. And and people are asking, sir, why theta low? Phase angle error must be low or error must be high? Error must be low. That's why as we are expecting error must be low. Yes, based on that only, as the theta is to be very low, proceeded. Finally, this was the formula. Like this, total mathematics I have taken from this. All these formulae you need to follow in the gate paper. 2 marks questions are possible. The two instrumentation paper also, in the instrument transformers, in the instrument transfer topic, questions are there. 1 mark questions are there. 2 marks questions are also there. It is, I'm openly saying, this is purely mathematics. Looking like very lengthy, I know, very lengthy, but after going home, you need to practice once again. Is that no? Especially I'm worrying about IN people because they don't know transformer details and all. That's why. But other people, electrical people, they know equivalent circuit of transformer. But I explained in my class, but still I'm saying that already you know something, it is better. But IN people, this is the first time you're studying. That's why I have taken this entire thing in detail, phasor diagram step by step, from that one by one value calculated. And people are asking that, so do we need to remember all the formulae? Here, generally, there is a two-way problem. If I give the formulae directly in the short-term batch, in the crash course batch, we don't take all these mathematicals, right? Formulae. The people ask that, sir, we want the derivation. In the long-term batch, if you take the derivation, so do we need to remember this formula? What is this? So that's why if you want to see, if you want to get the gate rank, whatever the faculty is giving in the class, you should follow compulsory. After that, how do you remember in the shortcut? That is your wish, but it must be followed compulsory. That too, I have not skipped any step. I have taken step-by-step procedure, but definitely I can give the guarantee. This is looking very difficult, but step by step I explain. You may be feeling like, yeah, it is clear, but not enough, not sufficient. After going home, first 5, then IM, then IC, combination I naught, after that E2, V2, like that step by step you go. Then you can go for the mathematics is very simple. What is the Pythagoras theorem? A plus B whole square, C square equal to A square plus B square. After that, A plus B whole square formula only. That's why here, once you start this entire thing, you cannot stop. You need not to stop completely. You can go. But starting problem, that's why I spent a lot of time in the phasor diagram. Kindly concentrate, kindly practice even after the class. Right. In the previous question papers, the questions not appeared since 2006. Electrical people are saying in the 2022 question may be there. See, you are very smart, not you people generally. If you leave any topic by saying that previous 5-6 years the topic was not there, then people ask that, no sir, next year the question may be there. Explain it. Okay, we don't skip it, but if you skip it, And if I take the topic, people say that, sir, since 2006, there was no question. So what should I do? Should I leave the topic? In the 2022, question may be there. And the two, instrumentation people, in the recent 2-3 years back also, question is there on this. Question is there on this. That's why whatever the topics are there, you should study. You are not writing your university examination. You're writing competitive examination according to the syllabus terminology. Everything must be followed. Which topic, maybe which topic will be there in the question paper, we don't know. That's what the point. That's why without skipping anything, any small concept also, I have not skipped completely. I have taken. Only the thing is, your duty is to practice this again. Your duty is to practice this again. And Dinesh, so that is is dash equal to n into is. 1 by n is transformation ratio, like a power transformer. Kind of don't comment anything about power transformer. If any doubt is there, go back to this ratios. If you are perfect in these ratios, then my entire derivation will be clear. That's why before coming to this lengthy topic, I have taken one simple numerical question also. Kindly practice more and more. Until you practice more and more, this topic is not that much easy. This topic is not that much easy. Right. Very good. Very nice. Sanjay Kalaskari, you are preparing for 2022. So let us. Right. Sirisha. And every people. Yes, yes. I am here to explain you all. Phasor diagram little bit confusing, sir. Explain again. Yes, one student asked that, but many people might have the same doubt. So that before going to the questions, I would like to revise the entire topic. Yes, those who understood very much clearly already, yes, revise. Other people kindly concentrate, right? But after this, no one should ask about the phasor diagram. Concentrate here. First, I'm drawing everything again. Flux phi. First thing, flux phi. After that, magnetizing current IM in phase with each other. And the two, if anyone, one second, if anyone is saying that, this phasor diagram is confusing, that student is IM student acceptable. Electrical student never, should not be acceptable. But still, I'm explaining this again and again. For your better understanding purpose, I'm explaining. But if IN people are saying that it is not clear, okay, no, small doubts are there, okay, but electrical people should not say. I'm openly saying, but still, no problem, I'll explain. Sir, magnetizing component of current in phase with phi. After that, resistive component of current 90 degrees. Why? Inductive current lags the resistive current by 90. So therefore, combination. Which one? I not. Okay. Sir, EMF will be induced. EMF will be induced. That is secondary voltage ES lags this voltage by 90. So lag this flux by 90. After that, here this is VS. They have taken 2. I'm taking S. And as the MI instrument is lagging, so therefore lagging, this angle is delta. After that, in the secondary AC circuit, no, resistance will be there, reactance also will be there. So resistive drop must be added to the VS in phase with this one. In phase with this one. Okay, this is which one? IS RS. Because that is secondary I to R to ISRS. Here this will be IS XS. Clear? After that, sir, IS must be reversed. Why? In the secondary circuit, the current should come from primary circuit only. What is this? IS dash. What is this IS dash? N into IS. After that, this will be IP. Nothing more than this. Whatever you do in the transformer, same thing. But after that, this is extra. Just I have extended like this. This is O, A, B, C. After that, simple mathematically, Pythagoras theorem. I have revised the entire thing. Kindly, after session, see here, kindly concentrate. Take this diagram. and looking at the diagram, simply look at the phasor diagram, try to draw again and again for practice purpose. But those who are asking, no, sir, this question was not there so far, I don't study, I can't say anything, that's your wish. But I need to take the questions in the class compulsory because 2021 question may be there, may not be there also, but may be there. So that's why prepare every topic, prepare every topic. At least now, I hope it is clear. Kindly respond. Is it clear or not? As it is purely derivation, you need to practice again. But the way of taking the parameters, clear or not? Respond kindly. Right. No. This is genuine doubt. Right. Sir, when I naught is 0, or I sir, I naught is very low, theta will be low. How can you say that? Can you explain again? No problem. Sir, like this now, right? This is theta. This is theta. Okay. Now, same thing I'm taking here. This is flux phi, right? Here, this is I naught. Okay. And this is is dash. Now, this is IP. Now, tell me, between these two, automatically gap will be reduced or not? Reduced or not? Definitely. Otherwise, if it is not clear, I'll explain one more way also. See, here only I'm using some white color. See, concentrate. This is I naught. Suppose very less current I'm taking. So this I naught will be added over here like this. Right, sir? This is the phasor diagram. Now this will be IP. Now this will be theta. Obviously, theta more here, theta less here. So therefore, the theta will be reduced. Vaishnavi, clear? Yes, very good, very good. Sir, how delta is very small? Concentrate. Mi instrument is the load. Mi instrument is the load. What is it here? Here, delta. See, don't get confused. How the delta is small? No, delta should be small. In that way, the manufacturer designed the devices. Why delta should be small? Because this is the secondary circuit. Secondary circuit which is there? Mi. Mi is there. RL combination. Sir, Mi is acting as a load. Load must be high lagging or low lagging, means load must be always low lagging only. Delta must be low. Delta is low, and I'm not saying delta must be low. In that way, he will design the corresponding CT winding and all. Right. Yes. Very good. Very good. Yeah, definitely. Will the see delta value will be given or not? If it is given, use the formula of which one? Use the formula of this one. If delta is not given, use this formula. That's why I told you. If delta is not mentioned, no comment anything about this. Simply use this formula. That's it. That's why I have given various types of things. Right. So turns ratio is primary current by secondary current, and you said that secondary by primary. Where did I say? Here, turns ratio, primary current by secondary current only I told. Srikanta Gowda. Here, turns ratio, primary current by secondary current only I told you. I did not say secondary by primary. Okay, sir, after revision, it is more clear, sir. Okay, right. Thank you. Right. Clear? This is the total discussion regarding entire instrument transformer topic. Clear, guys? Now let us have some questions on this topic. How the questions will be there? How the questions will be there? Kindly let us see. Can you wait for 1 minute? Don't worry, I'll explain each and every step, how to calculate and all. Those who want to have the break, they can leave the class, no problem. They can take the break. All I told you, for every 2 hours, I give the break, I told you. Suppose if you want, you can stop the class, you can go. You're having a chance of recorded video, no, you can go. So no problem for me. But don't ask me to give the break. 2 hours of time, definitely I'll give the break, no need to worry. Even I need to get relaxed. Definitely everyone should get relaxed. No, I will give you. I will give you. Right now, very, very important. No one should try. No one should try. I will explain. Clearly, I will explain. If I naught is 0, how the magnetization? Mathematically, I naught is 0. Ideally, I naught is 0. Practically, I naught is not 0. That's why I gave the word clearly. Ideally, see this, ideally, I naught is 0. Practically, I naught will not be 0. I naught will be there. Magnetization will also definitely be there. Okay, right now, sir, 50 hits, bar primary. Concentrate. Bar primary means, everyone concentrate, the number of turns in the primary is 1. Bar primary means BAR, bar means only 1 turn. That implies only 1 turn primary. Has a secondary turns. NS is equal to 500. NS equal to 500. Secondary supplies a current of 5 amperes. Into a purely resistive burden means in the secondary side, he is taking only resistive. But actually what I have taken the phasor diagram, inductive structure, because MI instrument, RL circuit, so lagging I have taken. But in this question, he is giving the data, secondary circuit, pure resistive is there. Load nothing but burden we can say. And magnetizing ampere turns is 200. Magnetizing ampere turns is 200. Very, very important, right? The phase angle between the primary and secondary current, very important, right? To confuse you, these two angles are given. To confuse you, these two angles are given. See, if you are adding these two, are you getting 180 or not? Yes, you are getting 180. But be clear, sir, the phase angle between primary and secondary means, concentrate here, IP and IS dash only, not IS. Not IS. The meaning of the terminology itself is IS dash only. What people are thinking, no, sir, the angle between primary and secondary is like this they are taking. Sir, this is secondary current, this is secondary current, and this is primary current like this. So that 180 minus theta, no here, simply, even though he is mentioning as a secondary current in the question, that means IS dash only, don't worry. IS dash only, I'm repeating, IS dash only. Secondary current itself indicates IS to IS dash. So always they'll be asking IS dash, because IS dash on the primary, IP also on the primary, that angle only generally asked. So that's why here IP and IS dash only. So immediately what he is asking here? Theta he is asking. But after getting this, secondary means 180 minus theta. No, theta only they are asking. I am giving the terminology. Kindly concentrate. Kindly concentrate. Clear? Right. Sir, what is a formula? What is a formula? Concentrate. So theta is equal to Im by n into is, because no delta, nothing is given. Nothing is given. Okay. Sir, by using this, what is n? What is n? N is secondary turns by this. So simply 500. Okay. Sir, here n means 500. Current, secondary current is 5. Oh, direct answer. So what is IM? Where he has given IM means concentrate. What is IM? I told you, magnetizing component of no load current. Magnetizing component of no load current. Sir, here this IM is on which side? This IM is on primary side or secondary side here? Always primary, because this is the no load equivalent branch. That's why no load is there. Equivalent effect will be on the primary, because no load is there, not drawing anything, but this will be drawing the corresponding power or not. That is the reason why no load branch will be always on the primary. That is the reason why concentrate. Magnetizing ampere turns means turns, primary turns NP. Primary turns NP. And ampere, simply which current here? IM we can take. IM we can take. Or sometimes we can take I naught also, because in this IM IC is not given. No, you can take both, no problem. So from this, sir, what is IM? IM is equal to 200 by number of turns in the primary is 1. So IM is 200. So therefore automatically IM is 200. Now tell me this value. But he has given in degrees. So simply into 180 by pi, so many degrees. In this way, the questions will be given. Right. In this way, the questions will be given. Kindly concentrate. Tell me the answer, everyone. Come on. Aishwarya, 0.08. How? Right. So 4.56 or 59 degrees, approximately 4.6 degrees. In this way, the questions will be given. We are going to solve 2-3 more questions also at the revision point of view. No need to worry. But for idea purpose, I'm taking questions like this. Okay, in this way, the questions will be asked. Clear? Any confusion, kindly let me know. Only you may be getting confusion here. That's why I told already. I'm repeating. Sir, magnetizing means no load. No load means on the primary side. So primary number of turns and IM or I not. So simply we can get the IM value. Right. That's what. Yeah, Dinesh. After reading the question, people are, yeah, that's why I told you, sir, angle between primary and secondary means people are thinking like this, sir, this is secondary. I'm using some other color. This is secondary. This is primary. Yes or no? And here to here, this is 180. 180 minus theta. If you're taking 180 minus theta, option is there. That's why I already told you, simply they will be asking phase angle error or phase angle theta, right? Phase angle error or phase angle theta, both are same, plus primary and secondary current also we should say IP and IS dash only, that is 4.6 only, not this one. Don't subtract one from 180 degrees. Right. Bar primary CT means, Dhaneshwar, I told you bar primary means, what is it here? Number of turns in the primary is 1. Number of turns in the primary is 1. That is what? Bar primary. Bar primary. Bar primary means one primary winding. One turn will be there in the primary. Clear? And people are asking, sir, why 180 by pi? Come on here. This is in radians. If you are taking this one, degrees, you will get 180 by pi. Radians to degrees, 180 by pi. I told you this also in the derivation point also. Here, check it. This is in radians. This is in degrees, 180 by pi. I hope everyone knows radians to degrees calculation. Right. For everywhere, Bhavani, everywhere you have to take IP and IS dash only. IP and IS dash only. That is what phase angle theta, phase angle error theta, and angle between primary and secondary current also. Meaning is same. Same meaning, no need to worry. Same meaning. Clear? Let me take one more question. Just a minute. Kindly wait. I'll be taking few more questions. Wait for 1 minute. Here, one question I'm waiting here. A 500 by 5 ampere 50 hertz current transformer has a bar primary. Has a bar primary. Means number of turns in the primary is 1. The secondary burden is a pure resistance. Secondary burden is a pure resistance of 1 ohm and draws a current of 5 amperes. If the magnetic core requires 250 ampere turns, magnetization the percentage ratio error is he is asking. What is it? Ratio error means Kn minus R by R into 100. That you have to give. Means Kn is already there. Based on the corresponding rated, we can take. You need to find out the R. R formula is there, no? Yes, bring it and try. I'm giving 2 minutes of time. Just try this. Try this. And if you want, I give the options also. 10.56 minus 10.56, 11.80 minus 11.80. Come on. Right. See, I'm doing step by step. Concentrate here. Sir, first point, what he has given? 500 by 5. So let me calculate first. Nominal ratio. Nominal ratio, that is Kn is equal to, how much he has given? 500 by 5. That is 100. Nominal ratio is 100. Okay. Magnetizing ampere turns, how much? 250. 250. This is equal to Np I naught. If data is not given, approximately Np Im, we can write it. All I told you in the earlier question, I have written like this. No load current magnitude I naught. In that, what is Im value? Clear? After that, secondary current Is. Is is given as second current. What is it? Is how much? 5 amperes. Sorry. Is is given as 5 amperes. Okay. Right. Few people are giving answer as 10 minus 10.4. So very good, very good. 2 people gave the correct answer. Is is 5 amperes. But what you require? Kn is there. But what we require? R. What is R formula? Right. I'm going back. I'm showing, people are showing, asking that. So go back and go back, etc. R. What is R value here? N plus I naught by Is sine delta plus alpha. Otherwise, N plus Ic by Is. Any formula according to the given data. Okay. I'm writing first. N plus I naught by Is sine delta plus alpha. N plus I naught by Is sine delta plus alpha. Otherwise, N plus Is is there here. Here, Im sine delta plus Ic cos delta. Im sine delta plus Ic cos delta. Otherwise, one more formula I told you, N plus Ic by Is. So people are asking me to turn the page, everything. So simply I have written all the formula here. At least now try. One student give the correct answer. Yes. 2 people give the correct answer. Can you make it fast? Come on. Only 2 people you have given. Okay. 3, 4 people. Very good. Very good. So we can write one more point here. Concentrate. Sir, N is not, no. N is equal to, what the formula? N number of turns ratio is, which one here? Secondary number of turns by primary number of turns. Nothing but IP by IS. What is IP and IS rated values he has given? in the question. What is it here? 500 by 5. So automatically, what we can write? N value. Kindly concentrate. What will be the N value? 500 by 5. So therefore, 100. Nothing but in the given data, if the number of tons and in the current values are separately not given, simply take this. N equal to Kn, you can take approximately 100. No problem. Right? Okay. Sir, N is there. IS is there. Is or no? And IM and IC not there. How to proceed and all? Kindly get it. Come on, other people. Be clear, guys. In this, here, magnetizing ampere turns. What is that? He has given. What is the value? 1 second. 250 they have given. So therefore, 250 is equal to current I naught, primary number of turns NP. I naught, NP model we have taken. I naught we can take IM, but based on the terminology I naught generally. So from this, what is I naught? 250 by NP. What is the number of tons? What is the number of tons? Bar primary. Bar primary. So secondary tons are not given. Primary tons are given. So therefore, what is the value here? So simply 250 by 1. So answer is 250. I naught is 250. Okay, after that. Sir, IS dash is equal to N into IS. What is N? 100 into IS is how much? Secondary current 5. So therefore, simply this is 5. So what is this value? 500. Therefore, IP is equal to root of y. I told you already. IP vector is nothing but I naught vector plus IS dash vector. So simply root of I naught square 250 square plus IS dash square 500 square. 500 square. Clear? What is this value? You'll be getting which value? 559.0607. This is IP value. Okay. Finally, what's the value now? R is equal to IP by IS. Yes or no? You can use any one of the formula. Our basic formula is IP by IS notation. Basic formula. This is nothing but IP by IS. All the formula to recreate it, which is suitable, you go for it. Simply, 1 second. Right here. IP. What is IP? 559.069 by 5. So what is value? 11.8 approximately. After that, finally, ratio error is equal to what is the formula? Kn minus R by R into 100. What was the Kn value? 100. So therefore, 100 minus 111.8 by 111.8 into 100. Definitely get minus sign. What is the value? That only. Nothing new at all. Everything is same, but only thing is you must be able to recollect the formula. That is 10.56. Option? Yes, B option. In this way, the questions may be possible. In this way, the questions may be possible. Clear? Right. So this is the total discussion regarding entire CT and PT, including all the derivations and all mathematical concepts. Right? Now let us have break. After the break, I'm going to start the Yeah, Sai Charan Reddy, it is not very hard. It is not very tough at all. That you are electrical student, I think. It is not at all very hard. Only thing is it is very lengthy. Difference is there. Lengthy and hard. It is only lengthy. The point is, if you follow the phasor diagram again, the things will be easy. The topic is like that actually. Math concept is very less. Mathematically, very, very lengthy. That's what you are feeling like very hard, but not hard here, only lengthy. So I'm requesting everyone, practice that. And sir, PT problem, I told you already, PT concepts are not there, PT theory is not there, CT theory only, I told you, no, in the syllabus PT theory is not there. Don't worry. Clear? Right. Take the break and come back. Right. Come back. See, according to the given data only you want to proceed. Kindly don't get any question like if this is not given, that is not given. In that way, kindly don't think anything. If you see the question, you can understand, oh, this is not given, then how can you get the angle? If it is not given, without the angle, how do we solve? Everything will be given. So that's why, without having the particular question, if that is not given, how can we do? If this is not given, how can you do? Take that question anywhere you find it, you try it, you will get the answer. Kindly don't expect the questions, right? So this is not given, that is not given, randomly controversial, they will not give the things, so no need to worry. Right. Now next topic, very important. Of course all topic is important only, but this is very lengthy chapter, bridges. Right. Now see, in these bridges, there are two types of bridges. There are two types of bridges. But after that, what is bridge, what is and all, everything I'm going to take now. What is bridge and all? Bridges, DC bridges. The bridges are classified into two types. One is DC bridge. And other one is AC bridges. DC as well as AC. Very simple. Whatever the supply we are having, that is what? DC, etc. Based on that only, we are going to have the corresponding thing. Alpha is no load angle. No load branch we are taken, no. Alpha no load angle. Okay, right. Come on. In this DC bridge, and in this AC bridge, what we are going to measure? What we are going to measure? You know, in this we are going to measure resistance of the corresponding parameter. Resistance of the corresponding parameter. In the AC bridge, we are going to measure inductance. In the AC bridge, we are going to measure inductance, thereby quality factor, capacitance, thereby dissipation factor. Means inductor, nothing but coil. If coil is there, automatically we are going to measure quality factor of the coil. And capacitance is there. That is, capacitor means dissipation losses will be there. Dielectric losses will be there. Then we are going to measure what is the dissipation factor. And frequency. And this mutual inductance is not there, but I'll give you safe side point. I will give you. These are totally available in this entire bridges. Clear? In these bridges, very lengthy topic. We are going to measure all these values. So what are all those? Now let us see one by one. First of all, what do you mean by bridge? What do you mean by bridge? After that, what is DC bridge and what is AC bridge? That you have to concentrate here. First of all, in the DC bridges, what will be there, right? In the DC bridges means definitely supply should be there. Isn't it? Supply should be there. In the bridge concept means balancing condition. Based on the balancing condition only, we need to proceed. So that's why I'm giving the things separately. In DC bridge, what do we measure? What do we have? Everything I'm going to show one by one. A simple introduction only. Kindly concentrate. In the DC bridge, what will be there? Everything I'm going to give now. After this introduction, we are going to take the complete discussion of each and every bridge clearly. This is the DC bridge requirement. In the DC bridge, generally, source will be there. Generally, source will be there. Which type of source we use means battery we use. Source means battery, right? Only DC supply we go, that is DC bridge simply. In order to have the detection of so and so things, detector, DC galvanometer, that is 0 hertz. DC means 0 hertz only. Galvanometer is used to have the detection. So where we detect and what we detect, everything we are going to take. And what is application? I told you, no, resistance measurement. We are going to measure the resistance. Now, how the bridge will be looking like? How the bridge looks like? Concentrate here. Concentrate here. What is bridge I'm giving? The bridge is the combination of 4 branches like this, right? Here, one resistance. Here, one resistance. Like this, 4 elements will be connected. Okay, that is a DC notation. No, yes, resistance I'm taking. Sir, between these two corners, we give supply. Nothing but between any 2 corners, either between these 2 or between these 2, as wish. Right after that, between other 2 corners, we are going to connect galvanometer. Between other 2 corners, we are going to connect, what is it? Galvanometer. Clear? Right? Now, so this is R1, this is R3, R2, R4, right? Assume that this resistance is unknown, means unknown resistance is connected between these 2. Unknown resistance is connected between these 2. Okay, if unknown resistance is connected between these 2, what is it meaning? Okay, this resistance value is to be measured. But how? But how means, kindly concentrate. How do we measure this value? Now, out of these 3 variables, any resistor, maybe any resistor is taken as a variable. Means we design the circuit like that. We vary this. By varying this, we observe the 0 current in the galvanometer. We observe the 0 current in the galvanometer. Once it is showing the 0 current, then we start the numericals to find out the corresponding value of R1. To find out the corresponding value of R1, this was the procedure. Only hint I gave you, only small discussion. After that, once I start the, what is it, bridge topic, yes, I'll be taking the continuation discussion. This is simply structure. Okay, in the DC bridges, automatically only resistors will be there. Only resistors will be there. Okay, now, so don't worry, sir, what is this? What is, everything will be taken, but only what I gave you, 1 or 2 elements will be variable, 1 will be unknown. By varying the available variable elements, galvanometer current is to be observed as 0. Once it is showing 0, then we proceed for the all calculations. We proceed for all calculations. Clear? Right. Now, concentrate here. Sir, what is AC bridge? What is AC bridge? In the AC bridge, what will be there? Concentrate. In the AC bridges, the source will be AC source, or we can say oscillators. AC source are oscillators. Oscillator also, frequency of oscillations will be given. No, yes. In the AC bridges, either AC source may be used, or what is it? AC source, oscillator, anything may be used. Detecting purposes, vibration galvanometer. This vibration galvanometer operating frequency is this. Starting days only I told you, galvanometers are so many types. Vibration galvanometer, D'Arson galvanometer, and ballistic galvanometer. Each and every galvanometer is working with respect to different frequencies. Okay, here whatever the galvanometer we are using, this is simply D'Arson galvanometer working with respect to 0 hertz, as DC means 0 only. Yes, that's what the point. But if you are coming for AC, vibration galvanometer we can use, or telephone detectors in headphones we can use, or tuned amplifiers, anything you can use. Anything you can use, but generally we use vibration galvanometers, or simply detector we can say. Right? Why I'm giving all these means, simply detector is sufficient, but which type of detector you need to understand. You need to understand. That's why I gave you so and so detector is used. Clear? Right? Now, sir, after that, in this entire AC bridges, which we are going to measure, that is L, inductance, quality factor, C, dissipation factor, F, And finally, this is mutual inductance. One second. This is M. Mutual inductance can be measured. Clear? So this is a total introduction of the DC and AC bridges. Okay. Sir, in the AC bridge, how the figure? Same figure. Bridge shape will be same, right? Between these two, AC supply V, comma F. Okay. And between these two, which one? Galvanometer you can write, or detect also you can write. Which step means this one. Anything okay, no problem, but our purpose is only to observe, yes, whether the value is 0 or not. That's it. After that, sir, in all four branches, here, this is one element. Like this, right? See, why am I showing with boxes? In this AC means impedances means RL combination, RC combination, or RC series, RC parallel, RL series, different combination. That's why I'm writing here Z1, Z3, Z2, Z4, Z1, Z3, Z2, Z4. Suppose Z1 is unknown, no problem, right? Simply any one of these, they assume that this is variable. By varying this one, we need to observe the detector or galvanometer, anything, right? Value as 0. Then we need to proceed for the corresponding mathematics. But what is that mathematics? I will tell you clearly one by one. This is a simple introduction regarding DC and AC bridges. Okay. Now, in the DC bridges, what I told you, resistance measurement will be there. Here also I told you application resistance measurement only. So therefore, sir, in order to measure the resistance, concentrate here. In order to measure the resistance, how many types of resistance are there? What is the classification of resistance is there? We should be able to understand. We should be able to know that. So that's why concentrate here. First, I'm taking resistance measurement. So, in order to measure the resistance, we should know classification of resistance. First of all, the resistance is classified into three types: low resistance, medium resistance, high resistance. Low resistance, medium resistance, and high resistance. Three categories are there. The first point here is, sir, which is coming under low resistance category? Less than 1 ohm. All these are the values you need to remember. Less than 1 ohm, that is low resistance. 1 ohm to 100 kilo ohm, that is medium resistance. High resistance, 100 kilo ohm. High resistance is greater than 100 kilo. This is the classification. Less than 1 ohm to 100k, and greater than 100 kilo ohm resistance. Right? Based on this also, ESC or any PSC or Genco Transco, all the examination directly match the following will be there. But for gate point of view, numerical question, we are going to see. And sir, what are the examples of this? What are the examples of this? Low resistance examples here. DC machines, armature winding resistance. Armature winding resistance in DC machine. Armature. Don't worry, one machine will be there. In that DC machine, one winding is having 0.01, 0.02, 0.03 ohms. That is called as less than 1 ohm. And series field winding resistance of DC machine, it is also 0.05, 0.06, or 0.1, so less than 1 only. Anyway, ammeter resistance is completely coming, no problem. And here medium resistance means shunt field winding resistance. Shunt field resistance in DC machine. All these are the electrical examples where we have low resistance means armature winding and series field winding. Where we have medium resistance means shunt field winding. Okay. After that, here, sir, in the electronics point of view, which will be there, resistance of a diode under forward bias. Generally, diode is forward bias. What we take? Short circuit we take. Resistance, sorry, diode is forward bias. We take short circuit. But is it exactly short circuited? No. Small resistance will be there. We neglect it. That small resistance comes under forward bias diode resistance. Okay. Next, medium resistance. One example, in the high resistance, resistance under reverse bias. Resistance under reverse bias means under reverse bias condition, you make the diode open. Generally, you open the diode. If you open the diode, that will be acting as infinite. Infinite means very, very high only. That's why practically while you're taking the questions, you open it. But strictly speaking, reverse leakage current IC not very, very, very small current will be there. Therefore, very high resistance under reverse bias condition. After that, insulation resistance. Everyone knows that insulation resistance is very, 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 very high. So coming under which one? High resistance category. Vishnu Ajit, if you have the patience, listen the class. If you have the patience, let me take the topic first. His question is, for resistance measurement, we can use multimeter to measure, no sir. Then why bridges? Means if multimeter is there, why did you study PMMC? Why did you study MI, EMMC, electrostatic and all? Multimeter is there, no need of all these things, right? So no need to study the measurement subject at all, right? Concentrate here. Right, sir. Here, what is the symbolic representation of? What is a symbolic representation of low resistance, medium resistance, and high resistance? That is, concentrate. Here, this is the resistance symbol. Everyone knows this. This is R. Okay. And here, right? Like this. R. Okay. Very, very important is, sir, low resistance, right? This is some less than 0.1 or something, for example. How do we represent that? How do we represent that? Means, concentrate here. Sir, low resistance should have 2 terminals or any extra number of terminals are required. Only 2 or any extra number of terminals are required. That you have to consider. One thing. Second thing, medium resistance also only 2 or more than 2, like that. High resistance also only 2 or more than 2. A very, very important point is, sir, here, while you are taking the low resistance, how to define the corresponding number of terminals, concentrate. Sir, I have taken one resistance like this. For example, assume that this is 0.1 ohm, for example. If you're connecting this in the circuit, right, sir, contact lead also having some resistance. So therefore, what is the point here? If you are, while you are taking the low resistance into picture, contact resistance can be neglected, cannot be neglected. Guys, come on. Contact resistance can be neglected or cannot be neglected? Let me know kindly. Respond. Right. Very good, very good. Cannot be neglected because this is 0.1. For example, this is 0.05. This is 0.05. Okay, right? Sir, 0.05, 0.05 neglected. Resistance in the circuit is 0.1 ohm. Can you write like that? Yeah. No. Why? If you're neglecting 0.05 here means 50% of 0.1 you're neglecting. Is it possible? No. If you're neglecting this 0.05, 50% of this you are neglecting. Is it possible here? Never. That's why the contact lead resistances cannot be neglected, should be considered. So that's why how to represent, here I'm taking terminals like this. I'm taking terminals like this. Right? These terminals are called as voltage terminals. These are called as voltage terminals. And these are called as current terminals. Sir, why? Why? I'll tell you. Concentrate here. Sir, in this entire circuit, suppose this is the resistance given. Suppose if I indicate voltage across only this, right? This is 0.1 ohm, this is 0.05 ohm, this is 0.05 ohm, and current is flowing like this. Sir, in the second diagram, V by I gives us which value? V by I gives us which value? 0.1 or something else? V by I. See, I is flowing here, I is flowing here, I is flowing here, I is flowing. Therefore, V by I gives 0.1 perfectly. But in this circuit, if I take this as I, if I take V by I, how much will be there here? This is V, this is I. From here to here, you are applying the voltage. No, what is the total resistance here? V by I is 0.2 ohm. Okay, but how much resistance is there? 0.1. How much is given? 0.2. Is it acceptable? No. How much is there? 0.1. How much is obtained? 0.1. Yes, this representation is working properly. That's why you need to separate here. Across these two, you need to indicate the voltage, and through these two, you need to indicate the current. That's why, see, across these two voltage, and through these two, yes, current will be flowing. Then we can say that, okay, successfully we are getting the proper value of resistance. That's what the point. Clear? Right. To get more clarity, I'm taking everything. Sir, in this medium resistance, how many terminals should be there? Suppose, sir, this is suppose 1000 ohms is there, right? Can we neglect this contact resistance or not? Come on here. Can we neglect this 0.05 ohms or not? Yes, we can neglect. Why? This is 1000, but this after all 0.05, 0.05. So therefore, no problem. What is it? If I represent like this, V by I will be equal to 1000.1 ohm. So 1000.1, almost same or not? That's why in the medium resistance approach, here between these two terminals voltage, and here only current also. So that's why, what is it here? These two are voltage and current terminals. Voltage and current terminals. Clear? Here across this one means we are especially concentrating on this contact leads. Why? This value is low, other values cannot be neglected. But medium 1000, 500, 600, 20, 40, etc. will be there. No. Yes, contact lead resistance can be neglected. Okay. Coming to the third one. Sir, in this entire thing, now I'm taking the high resistance. What is high resistance range? Greater than 100K. Suppose I'm taking that here 1 mega ohm, for example. Sir, what will be the resultant value now? What will be the resultant value? 1 mega plus 0.1. So therefore, 1 mega plus 0.1. So compared to 1 mega plus 0.1, blindly neglected. So therefore, between these two only voltage, between these two only current. So here also, what is it? Voltage and current terminals. But sir, medium and high both are looking like same. So that in order to differentiate further, what we have to do, sir, through these two resistances, right? See, if you are taking these two resistance into consideration, through which resistance we can neglect the current? Can you answer? Medium and high. Through which resistance we can neglect the current? Respond. Through which resistance we can neglect the current? right? Come on here. Very good. High resistance. Yes or no? Yes, high resistance. So therefore, in order to represent that symbolically, we do like this. Symbolically, here, like this we show, and this is ground terminal or God terminal. What do you mean by this? Actually, we don't ground it practically, but sir, very small current is there. That current I am bypassing, that current I am bypassing to the ground. Means okay, if the ground bypassing terminal is there, we can understand that okay, very small current is there. Therefore, we can bypass it. So very small current means high resistance. In that way, symbolically we can observe. That's why low resistance 4. Why? By seeing the 4 terminals, we can understand that okay, contact resistance also consider means okay, value of resistance is low. 2 terminals only means contact resistance is no need to worry means it is medium. And 3 terminals, okay, what is it? Bypassing to the ground terminal is shown. So therefore automatically very small current. Very small current means very high resistance. So therefore high resistance. This is the symbolic representation of all. Clear, guys? This is the total discussion regarding resistance measurement. That is introduction only. Only introduction is this. Now, if any doubt is there, kindly talk to me now. After that, measurement, I'm going to start resistance measurement and all. Come on, guys. Is this introduction clear? Right. Okay. Now I'm taking resistance measurement. Right. In that first one, low resistance measurement. Right. So what is that low resistance measurement? Right. Here, the low resistance can be measured by 2 methods. One is potentiometer method, and second one is Kelvin's double bridge method. Right? Potentiometer method and Kelvin's double bridge method. There are 2 methods. See, this is the bridge. This is the method given by Kelvin. So whatever the bridge he proposed, that only we have to consider here. Right? Okay, now the first one, potentiometer method, let us take now. Potentiometer method, very simplest method. Concentrate. What is that? First, let us take unknown resistance R. This is R, unknown resistance. But be clear, people are asking that, sir, you are taking only 2 this I told you symbolically, but application point of view, any resistance we take 2 terminals only, but symbolically, if low resistance is to be indicated, medium resistance is to be indicated, and high resistance is to be indicated, then we have to go for which one? Correspondingly, symbolic represent 4, 2, 3 terminals. But usage point of view, in your laboratory, in your EDC laboratory, anywhere, any resistance you can take, simply only 2 terminals will be there. So no, that's why this is only symbolical notation. So that's why I'll be taking only normal resistance. And for this, I'm using one more resistance, that is standard resistance. That is standard resistance. Okay. After that, these two are connected in series across some voltage source. Some voltage, some no problem, some voltage source. Okay. First point is Current through these two will be same or different. Obviously, both are in series means both will be carrying the same current. Okay. Now, what is our duty? Concentrate here. Across this, VR will be there. Across this, VS will be there. VR and VS. Now the question here is, sir, this VR is determined by which device? Potentiometer. In the potentiometer, unknown value measurement is there. Remember or not? Yes, you need to connect this to potentiometer. This also to potentiometer. Why? The method itself is by using the potentiometer. So where and how? Concentrate. Example purpose I'm taking like this. This is the corresponding structure. Right? Slide wire is there. I told you here unknown EMF is to be connected. I told you. Where? Here no? Yes. Here between these two terminals unknown EMF. Which is our unknown EMF? Which is our unknown EMF? This one. So simply like this we connect. What you have to do after connecting these two terminals? Vary this entire slide wire. Vary this entire galvanometer point on the slide wire. Suppose across 170 centimeter, it shows 0. Everyone kindly concentrate. Same my standard values only. Across 170 centimeter, if the galvanometer shows 0, if the galvanometer shows 0, then what is unknown EMF? Everyone should answer this. Kindly tell me. Across 170 centimeter, if the galvanometer shows 0, what is this value? According to our values only. According to the given values I have taken the class. Very good. Everyone should respond so that I can understand that yesterday's class you have prepared or not. Come on. Yes. 1.7. Many people gave the correct answer. 1.7. Why? 170 centimeter means 170 ohm. 170 ohm into 10 milliampere. So 1.7 volt. In that way, this will be given to the potentiometer and measured. After that, by disconnecting this, what we do? Simply we connect here. Again, same thing we do. Suppose it is showing at 70 centimeter, for example, 70 ohm into 10 milliampere, 0.7 volt. Like that, the voltage across these two R and S are measured by potentiometer. That's what the concept. That's why if you understand the potentiometer topic, yes, this topic is very, very simple, exactly similar. That's why the VR and VS are determined by correspondingly potentiometer structure. Right now, after using this entire potentiometer, what we can say now, sir, I is equal to VR by R is equal to VS by S. Definitely, VR by R, this is the current I. VS by S, this is the current I. So from this, what we can write? Therefore, VR by R is equal to VS by S. From this, R is equal to VR by VS into S. Right now, very, very important. Last point here is, sir, 1, 2, 3, 4. Out of 4 parameters, which parameter is given in the question? Which parameter is given in the question? Come on. Which parameter is given in the question? That is, S is given. In the circuit already, S is given. Sir, which parameters we determine from the potentiometer method means VR and VS. Finally, calculated like this. But in the question, kindly consider in the gate question and all, definitely they will give all the 3 values. But experimental, I'm asking first which is there already. Yes. Okay. After that, which we have determined from the potentiometer means VR and VS. So finally, what we require R. What we have done? Calculated. R value is being calculated. Clear? Right. So in this way, this is one way. But now people are asking that, sir, why to take potentiometer? Why not PMMC voltmeter? I'm asking the same question. Why not PMMC voltmeter? Can you tell me? Everyone, why only potentiometer here? Why not PMMC? Respond. Very nice, very nice. Yes, very good, very good. Yes, correct. Sir, our topic is which topic? Low resistance. Sir, if you are talking about low resistance, or if you're finding the low resistance value or lower values, we need to have good resolution, or we need to have poor resolution. Means always we need to have good resolution only, because highly accurate only we require. Sir, why? Means concentrate here. Low values measurement definitely requires very highly accurate measurement. Suppose high value of measurement is there, 10 ohms I want to neglect it. 5 ohms I want to neglect it. But low resistance measurement, low values measurement, 0.1 also we cannot neglect. 0.05 also we cannot neglect sometimes. That's why the low resistance measurement requires very high resistance, very high accuracy. That is the reason why good resolution, high accuracy, high sensitivity. Therefore, what we can say, potentiometer is better than the PMMC. That's why PMMC is not preferred generally. That's what the actual topic. Clear? People are asking generally, sir, why not voltmeter and ammeter? I mean, that only gave you. Sir, if voltmeter is used, which one? PMMC only. PMMC means it is having less resolution than the potentiometer. So that is the reason why we need to go for which one? Potentiometer method only. Clear? Right. After that, it is also more of mathematical topic only, bridges. Right. Second one, Kelvin's double bridge method. Kelvin's double bridge method. What he proposed, no, concentrate. This is the bridge given by Kelvin. Right. Here, one resistance. One resistance. Right. And here one resistance, and here one resistance he proposed. This is capital P, capital Q, capital R, capital S he proposed. Okay. And here galvanometer. Okay. Actually, this all I told you, what I told you, variability must be required. One of the elements must be variable. I told you, no. But in this, simply he has connected like this. And with respect to this, here, one resistance, and one resistance. And he proposed the bridge like this. But by seeing the bridge, can you say, is it accurate bridge or not? Is it accurate method or not? Come on. Is it accurate or not? Respond. Right. See, this is the better accurate bridge. Not only accurate here, better accurate bridge. Because, be clear. See, galvanometer is connected here. Means galvanometer, one resistance, other resistance. At this combination, contact drop will be there. No, that's why he has not neglected the contact drops. He has given all these contact drops into picture by taking small p, small q, and small r like this. So therefore, as he has taken internal drops into consideration, nothing but contact drops into consideration, automatically this bridge is highly accurate. Very, very simple. Yeah? From now onwards, take only one point. Sir, here lead resistance are considered, contact resistance are considered, not neglected. Considered means like this. What are the method I have taken? No, here low resistance method. Contact resistance are considered. Is that no? But not exactly. This in the bridge point of view he has shown. That's why as the contact resistance are considered, not neglected. Suppose if I draw like this directly, contact resistance are not shown. Not shown means neglected. Neglected means not low resistance measurement. So therefore here, as it is a low resistance measurement, this is R unknown. Low resistance measurement, contact drops are considered. So automatically the Kelvin's double bridge method is highly accurate. One thing. Second point, already, sir, low resistance measurement itself indicates highly accurate methods must be followed. Highly accurate methods must be followed. Yes, that only. This is potentiometer method. By considering the internal drops also he proposed. Clear? Right. R is unknown. Yes, R is unknown here. Okay. Right. Now in this, he proposed that these two and these two are variable. Now I'm giving the complete information regarding bridge balancing condition. Kindly consider until we complete this entire chapter, we will be taking bridge balancing technique only. Right? Bridge balancing technique only. These three are the contact drops. These three are the contact drops. I'm repeating. These three are the contact drops. This is the standard resistance. Yes. Right? Okay. Now, sir, what is the procedure? You know, everyone concentrate. Sir, vary the variable elements until the galvanometer shows 0. Means until the galvanometer shows 0. Once the galvanometer shows 0, what we can say? This potential C, this potential D, I'm taking. What is it here? VC is equal to VD. Why? Current is not flowing from C to D or D to C. It is showing 0. Automatically, VC equal to VD. Then that is called as bridge balancing condition. Bridge balancing condition. Clear? Right? First point. After that, after this bridge balancing condition, mathematics is there. From that mathematics only, you are getting the value of R. That's why I told you, bridge itself is so much of mathematical concept will be there. Kindly concentrate. Sir, after bridge balancing condition, we need to find out the corresponding value. Sir, VC is equal to VD means across this entire thing, voltage drop is not there. Voltage drop is not there, right? Okay, now, sir, this R is unknown. No, I'm taking current to through this one is some current, right? Randomly I'm taking. This current is I1. See, this I1 is coming over here. And do you have any current flow through this? No. So therefore, same I1 will be coming over here. Okay. And this I is coming here at this point, divided into two parts. This is IR. This is I2, for example, some current I2. Sir, this I2 is coming over here at this point. Constant here, galvanometer is not showing or not having any current flow. So therefore, same I2 coming over here. Same I2 come over here. Now, again, IR and I2 combination means I is coming over here. I plus I1. What is it? I plus I1. Here also, I plus I1. Clear? Right? This is a simple terminology. Now I'm taking, sir, I'm treating this as mesh 1. I'm treating this as mesh 2, like that. Mesh 1 and mesh 2 I'm taking. But be clear, guys. Simple KCL, KVL concept only. Nothing more than that in this topic. Nothing more than that in this topic. Clear? Right. See, people are having many confusions here, sir. Concentrate here. This is R. This is S. This is galvanometer. At this point, how many resistors are connected here? 3. So that's why one resistance here, one resistance here, one resistance here. He has taken like this. This is R. This is S. This is galvanometer. Where is the fourth one? Where is the fourth one here? Only these 3 elements are there. But you may be asking, sir, why only here? Why not here? Means he has proposed only here. That's why I told you. Why did he propose like that? Don't question. After his proposal, as it is, we need to take the complete conceptual point. That is what the actual point. Clear? Right. Now, I'm taking the corresponding mathematical discussion. Concentrate here. You need to give the answer after this mathematics. Sir, this I is flowing here. So this will be plus minus, because current always flows from higher potential to lower potential. Okay. And current is coming over here. This is plus, this is minus, and here it is flowing like this, plus and minus. Okay. And here this is plus, this is minus. As the current is flowing like this, plus minus, here also plus minus. Based on the current direction only I have taken, nothing new. Higher to lower, plus to minus. Higher to lower, plus to minus. Based on the current directions, what we have taken so far, I have taken the, what is it? Polarities, plus minus, etc. Right? Okay. Now, sir, I'm starting from here. I want to write the KVL equation here. KVL equation here also, 2 equations. Concentrate. Sir, plus to minus I1 into P. Plus to minus means reaching terminal I'm taking. After that, sir, what is the voltage drop between these two? 0. So plus or minus 0. After that, here to here, minus to plus. What is it? I2P plus I2 small p. I'm differentiating here. Capital P like this, small p like this. After that, sir, minus to plus I into R. I hope everyone knows about the KVL basic equation. But even though I'm writing every step, kindly concentrate. I'm coming again. I'm starting from here. Plus to minus I1 into P. Across this drop is 0. Minus to plus I2 into P. Minus to plus I into R equal to 0. This is equation 1. Okay. After that, what is equation 2? What is equation 2 here? I'm starting from this part. For example, minus to plus I2 small q. Here to here, 0 drop, plus or minus 0. And here to here, plus to minus I1q. So minus I1q. After that, minus to plus I into S. I into S. Clear? After that, what is the available thing here? Constant. I'm coming again. I2 means minus to plus is plus I2q. Plus or minus 0. My plus to minus means minus I1q. Minus to plus means yes, plus I into S is equal to 0. Equation 2. Kindly let me know these two KVL equations, basic electrical equations, clear or not? KVL equations. If these are clear, other things will be very, very simple. Kindly let me know. Yes. Respond, guys. Right. After that, third equation is very, very important. I'm taking this triangular shape is like that I'm taking. What is the current I? Here, these two will be in series. Why? No current is flowing. Same current means series. Therefore, one resistance and one resistance. This is small p. This is small q. What is this current? I2. Okay. After the downside, R like this. What is this current? I. This current also I only. See, whatever the triangular shape is there, no, that only I modified. That's it. That only I modified. Okay. Now tell me, sir, I is there, I2, PQ, R is there. Sir, what is I2? Current division law. I2 is equal to total current into opposite resistance R by sum of all the resistances. Small p, small q, small r. This is equation 3. This is equation 3. Now, what you have to do, not now, but generally, 1, 2, 3 from equations. From equations 1, 2, and 3. What is that? Sir, I2 is there. Substitute this I2 here, I2 here, and equate, etc. Bring that entire thing. Finally, you need to simplify. You need to simplify what is the R value. Purely mathematics. Technical thing is over. Simple math. Technical things are here, these two equations and corresponding current division law. After that, normal mathematics. I'm giving 2 minutes of time. Kindly take these three equations. Give me the value of R. Make it fast, mathematicians. Make it fast. Come on, try. Take 2 minutes of time and try this. Come on. See, you'll be getting this P by Q into S plus small rq by small p plus small q plus small r into capital P by Q minus small p by Q. This is what the value you will be getting. So this is the value of R by using Kelvin's double bridge method. Those are trying okay, but otherwise I give the formula. This is what the formula, right? Got it? Right. After this small modification, see capital P, small p, I'm not understanding. Already differentiated. Capital P like this, small p, I have given some extra line like this. Here, extra line like this, I told you. Right? Here, capital P like this, small p is like this. Some extra line I gave you. Right? Okay, one student gave the answer. Yes, yes. Very good. Don't worry, you can practice here. Capital P like this here. Small p like this. In that way, I maintained. So to have the differentiation. Right. After that, one more continuation point here is, sir, if ratio arms are equal, if ratio arms are equal means that is what do you mean by ratio arms? Capital P by Q is equal to small p by Q. These two are called as ratio arms, means whatever the branches you are varying, those are called as arms ratio, we can say. That's why if ratio arms are equal means arms ratio is equal. When do we say arms ratio equal? Capital P by Q is equal to small p by Q, then that is called as arms ratio is equal. So therefore, if arms ratio capital P by Q equals small p by Q, what is the value? Check it. This value will be 0. So therefore, this entire value will be 0. What's R value? Therefore, R is equal to P by Q into S. This is what the complete thing regarding Kelvin double bridge method. Clear? Right? Let's have one question on this. One second. This direct formula, and in the formula you have to substitute the values. That's it. Where have you written small q? Okay, okay, one second. Small q. Right. All values are given, kindly substitute. All values are given, kindly substitute. Make it. And even option C, option B, again two different answers. All values are given to everyone, same values only I have given, not different values. Sir, R is equal to capital P by QS plus RQ by into capital P by Q minus small p by Q. Substitute all values. Capital P. See, outer arms ratio, inner arms ratio means outer side. What is it here? P by Q. So therefore, 100.24 by 200. Standard resistance value is, how much is given standard resistance value? Here, 700 micro into 700 into 10 power minus 6 plus small r. Here, 1 second, it is not standard, 1 second. Concentrate here. Standard resistance is 100.03, yes, here. 100.03 micro plus. So very small r, very important point here. Here, the resistance of the link connecting the standard and the unknown resistance means this one. Check it here. The resistance of the link connecting the standard resistance and unknown resistance is which one here? Small r. That is what given as this value, 700 micro. 700 micro into what is Q? Small p by small q into 200 by all the values. What is that? Small p, small q, small, like that. All you substitute and give me the value. All values are given, just substitution only. Different answers, kindly give me one answer. B A. R value is this, because the resistance of link connecting the standard and unknown resistance, and this is capital P, capital Q, small p, small q, and this is yes. Very good. You'll be getting 49.97 micro ohm, first option. See, calculate the unknown resistance to the nearest 0.01 micro means here decimal point 001, like that 0.01 micro. In that we have to take, means after the decimal like this, and the two error should not be here 50 micro, and this is very close value. No, in that way he is asking. Got it, or any doubt in this question? Are contact resistance usually that high, sir? No, in the question he has given, but generally low only in the question he has given. Right? Our topic is DC bridges here, Ankur. Our topic is DC bridges, where the AC came into picture suddenly. The AC started, now I'll tell you. So generally P less than, no, yeah, no, these are the values given in this question. So kindly follow that. We cannot say P less, Q more, or small p, small q, this much large, not like that. Simply the given value, substitute that. Normally all values will be in the low category only. There's a relation like P should be low, Q should be, not like that, not like that. Right, 49.97. See, near to the 50 you are getting, people, few people gave that B. Check it here. 50 micro to 50.97 micro. How much value is there? 50.00 means 0.97 micro, but he has given that nearest to 0.01 micro, 0.01, 0.97, lot of difference is there. So even you're getting near to 50, you cannot choose B option. Suppose if you take 50.00, what is the value? 0.03 is 0.01, 0.03. Compared to all, first option is nearest one. So thing is done. Clear? Right? Right. Now let us go for medium resistance measurement. Medium resistance measurement. Right. So concentrate here. What is the range of medium resistance? What is it? 1 ohm to 100 kilo ohm is the range. Okay. In the same way, I'll write here also. In the low resistance, what is the value? Less than 1 ohm. Low is less than 1, and in this 1 to 100 kilo ohm. But in this medium resistance, there are 4 methods again. That's why the chapter is lengthy chapter, we can say. Medium resistance measurement, 1 ohm to 100 kilo ohm. Okay, and in the 4 methods are there. One is voltmeter, ammeter method. Voltmeter, ammeter method, first method. Second one is substitution method. Substitution method. And the third one is Wheatstone bridge method. And the fourth one is ohm meter. These are the 4 methods where we find medium resistance. Right. Shreya Sasi, right? Without solving also, yes, very good. But that is a blind answer. I should not say, but okay. Sir, without solving this also, we can answer no, sir. 50, nearest one is this only because 0.917, here 10.97, 20. So blindly we can write. That is okay, but procedure I wanted to give, no, that's what I gave you. Imtiaz, even you are getting 50, near to 50, which must be chosen. He has given that calculate the unknown resistance to the nearest 0.01 micro. He has given that for approximately this one is there. Compared to this, 0.01 difference only should be there. In that way, this is correct. Right? Okay. Now, let us take one by one. See, already this topic is being taken in the earlier class, that is voltmeter ammeter method, where we have taken voltmeter ammeter method, that is power measurement, VA method and AV method, and MC short, LC short. 2 methods we have taken, almost similar concept. Now I'm taking for third time. Now I'm taking the topic for third time. So kindly concentrate more and more. Clear? So what is it? First method is here, voltmeter ammeter method. In that, VA method and AV method. VA and AV method. Sir, this is just like a revision topic, but in the earlier classes, we measured the power measure. We have taken the power measurement, but now we are taking the resistance. Only that is a change. Other than that, everything is same. Everything. What is that? Concentrate. VA method, AV method. Be clear, guys. Sir, resistance is being taken, right? This is R because unknown resistance R. Here, Voltmeter first, ammeter later. Okay, here ammeter first, voltmeter later. Okay, sir, VA method, AV, everything is same. Only there we have taken P equal to V into I notation. Here we are taking R equal to V by I form. That's it. Other than that, everything is same. Now let us see now. Very, very important to concentrate. Those who miss the class of power measurement, right? This is the topic. Other people, those who attended it, just like revision. This is IL. This is IL because whatever the element we are measuring, always load element only we say. So VL, IL. Okay, first point. Same thing, R true. What is R true? VL by IL. There we have taken power true. Power true is VL by IL. Here R true, sorry, power true means VL into IL. R true means VL by IL. Here also R true, VL by IL. Okay, right, sir. How you are measuring the R? R measured is voltmeter reading by ammeter reading. Right? Here also RM, voltmeter reading by ammeter reading. Voltmeter reading by ammeter reading. Sir, okay. Here, what is voltmeter reading? What is voltmeter reading here? Between these 2 points, voltage. Between these 2 points, voltage should be there, right? Okay, what is this? Here, sir, this voltmeter reads VL plus VA. Everything is same here. Voltage across, this is VA. So therefore, VL plus VA by. Sir, ammeter reads, ammeter IA equal to IL. So ammeter reads the current of IL. Right? There what we have taken? VL plus VA into IL we have taken. But here, what is the division? Their multiplication, here division, because power equal to V into I, resistance equal to V by I. Everything is same other than that. Now here, what is voltmeter reading? Voltmeter reading is directly VL by. Ammeter reading is, sir, IA is equal to IL plus IV. IL plus IV. So therefore here IL plus IV. Clear? Right. Now after that, very, very simple here. Sir, RT is VL by IL. RM is VL plus VA by IL. Which is more? RM is more or RT is more? Definitely RM by VL plus something by IL. Here only VL by L. So RM is more. Here also. VL, numerator same. IL plus IV. Denominator is more. So it will be less. So therefore, only this is the difference. Only this is the difference from two topics. 1 second. So the only this is a change here in our power measurement, right? What you have got over there in the power measurement, in both the cases, power measured power was more only. Right now, here, sir, REM is greater than R2. REM is less than R2. Error is positive. Error is negative. Only this is a change. Other than that, every step is same. Every step is same. Error is positive here. Error is negative here. Okay. Now I'm writing REM is equal to VL plus something by IL. REM is equal to VL by IL plus something. Sir, what is this VA? Sir, what is VA formula? Current through the ammeter into resistance of ammeter. IL into RA. IL into RA. Okay, next. Here, IV. What is IV? IV is voltage across the voltmeter VL by resistance of that RV. So therefore, what is it? IV is equal to VL by RV. IV equal to VL by RV. Okay. Now, what is the error content? This is the error content. This is the error content. Sir, why? If this is 0, VL by IL, R true also VL by L. So therefore, what is that? Error is 0. That's what. This is the error content. Sir, what is that error content? This and this. Right? IL RA. RA is ammeter resistance. So therefore, error is due to ammeter resistance. IL is the current through ammeter. Same concept. IL is current through ammeter. RA is resistance of ammeter. Therefore, error is due to ammeter. Kindly try to recollect the same conclusion we got in the power measurement also. Error is due to ammeter and VA. Here also same thing in this. Error is due to, sir, RV, resistance of the voltmeter, VL, voltage across the load, but voltage across the load and voltage across the voltmeter also. So therefore, both are with respect to voltmeter. Now finally, very important conclusion. Definitely conclusion will be there. Kindly concentrate, sir. Error is due to ammeter. Error is due to voltmeter. Okay, sir. This error value must be 0 ideally, but practically speaking, must be low. Sir, this portion must be low. In order to have that portion low, RA must be low. RA must be low. Sir, already ammeter, low resistance only. No need to worry. Sir, next one. IL must be low. Isn't it? When do we have IL low? Means concentrate here. Low current. Nothing but simply IL must be low means resistance must be high. IL must be low means resistance must be high. So therefore, what we can say, suitable for high resistances. Okay. Now here, sir, this entire quantity must be low. So in order to have that quantity low, RV denominator must be high. Denominator must be high. Then only this entire ratio will be low. Denominator must be high. Okay. Yes. And numerator must be low. Okay. Denominator must be high. RV must be high means voltmeter should be designed with high resistance. Already designed with the manufacturer. No need to worry. VL must be as low as possible. VL must be as low as possible. What does it mean? VL means voltage across load. So voltage across load must be low means the corresponding R must be very low value. So therefore, what is that? Suitable for low resistances. But the moment I conclude this, so what is our heading? Medium resistance. In the medium resistance, first method is this. But sir, conclusion what I gave? Suitable for high resistances, suitable for low. But our topic is medium. How do you justify this? How do you conclude this? Tell me, everyone. Topic is medium. We are taking in the medium. But conclusion is, sir, one is high resistance and one is low resistance. How to conclude this? How to conclude this? Come on, guys, everyone. Here, this was the main problem, main point in this topic. Come on. Very nice, very nice. 1 second, who is this? Very good. Right, Shivanath Ganesh, right, correct. Equal error case if we got the formula. What I asked? Equal error case if we got the formula. Lower and higher, and very nice, very nice. Right. Be clear, guys. What is the meaning of this? You know, very nice. People will answer. Suitable for high resistances in medium range. In medium range. Suitable for low resistances in medium range. So what do you mean by this? Very, very simple. Sir, 1 ohm to 100 kilo ohm is there. No? Suppose, everyone concentrate. Suppose if I'm giving 75k to 80k range, 75k to 80k range. Now tell me which method we follow. 75k to 80k range. Which method means higher resistances in this medium range. Medium means 1 ohm to 100k only, but in the medium higher side, that is what VA method. Suppose if my application is 500 to 1000 ohm is there, for example, lower side in the medium range only. That is what the task. Don't think like low means less than 1, high means greater than 100k. Not like that here. In this 1 to 100 kilo only, few things will be higher side, few things will be lower side. Therefore, higher side VA method, lower side AV method. Now people are asking one question like exactly, sir, if the resistance is exactly 50k, then if the resistance is exactly 50k, you can take any one of the method because equally good. So that's why around 50k, suppose around 50k is the question, VA and AV both are equally good, we say. Why? Around 50k means more than 50k, less than 50k, very close, no problem, almost same distance here. So therefore equally good. So this is the total discussion regarding VA and AV method of resistance measurement. Clear? Right? Okay, next methods will be taken in tomorrow's class. That is normal timing only 5 to 9. Now I'm stopping the session. If any doubts are there, kindly let us have the doubt session. In this majorly instrument transformer, mathematics only done, major portion. Okay. V and AV method, I got this experiment as my final exam. Okay, very good. Right. I'm repeating the last point. See, this is suitable for which one? High resistance. Already you got it. This RA must be below, IL must be below means high resistance. RV must be high, VL must be below means low resistance. But what is our topic? What's the topic here? High resistance in the medium range, low resistance in the medium range means concentrate here. What is the meaning of this? You know, 1 ohm to 100 kilo ohm is the medium range. Suppose my unknown value is close to this, higher resistance in the medium range means close to this, VA method. Suppose my resistance is close to this, lower side means low resistance in the medium, low means not below, high means not above this, simply between these two only, higher side 75k, 80k, etc. higher side, 50 ohm, 100 ohm, 1000 ohm, lower side. People are asking that, sir, if exactly 50k is there, equally good. So both methods are no problem at all. Small change, no problem. That's what the point, last point I told you. Yeah.
Good evening, sir.
Yeah, good evening.
Sir, my doubt is from from day 9, sir.
From
The last question we did on day 9th.
day 9th question. Can you tell me the question?
Yes, sir. The question that where there were connections, one to neutral, one to R. First, it was connected to neutral. The 3 watt meters were there, and then it connected to
Yeah,
R.
lengthy question. Yeah. Tell
Yes,
me.
sir. There's
What's the doubt in
only one thing, sir. Sir, here you,
there? Tell me.
sir, here you calculated phi, sir.
This one, right?
Yes, sir. Yes, sir.
Yeah, tell me.
Sir, here it is saying the load is balanced and inductive, drawing 3464 volt ampere. This of what?
Yeah.
So Sir, how did you take this? It has apparent power. I didn't.
Come on. Yes, what is the formula? S is equal to root 3 VLL formula I gave you. What is the
That-
unit? Volt ampere. Volt ampere apparent power. And reactive power root 3 VL IL sine phi. Volt ampere. Sine means reactive. VAR. Power root 3 VL IL cos phi. General, simply we can say what? As it is given, I have taken. Volt ampere means that is the main drawing. I told you one more point also. See, always electricity board people will supply apparent power only. We consume
Sir.
active power, that will be wasted reactive power. That's the
Okay, sir. Now that's good. Yes, sir.
right.
That's what I was missing. Thank
Good
you.
evening. Good evening, sir.
Yeah.
Sir, CT and PT.
Yeah.
Sir, you told that PT will damage if we short circuit it, but CT will not damage. Sir, can you explain it once again?
Complete explanation is not possible. Which is your doubt? You tell me that.
Sir, how CT will damage, but PT will not damage, sir, if we short circuit
PT
it?
construction, PT construction is different, right?
Yes, sir.
Then
But sir, we short the both, but like in PT
ask
will
the doubt
damage.
clearly. Ask the particular doubt clearly. I will explain. No problem.
Sir, when we short circuit the PT, how it will damage, but not CT
I
damage?
told you already, clear. Voltmeter resistance is 1 kilo, 10 kilo, etc. is there. Instead of kilos ohms of resistance, instead of kilo ohms of resistance, simply you are keeping zero resistance. Instead of kilo ohms of resistance, zero resistance you are keeping means, what is it here? This voltage V2 by 1 kilo, 10 kilo, 20 kilo during normal. But what is happening? It is short, it is zero. V2 by 0, what's it here? Very, very, very large current will be flowing. That's why it will be damaging. Is it no? You asked
Yes,
one
sir.
question. Yeah, one second. Sir, in the PT, current is not there. In the normal operation, I'm not asking. Once it is short circuited, resistance is becoming zero. Therefore, corresponding voltage is same. Only resistance is zero. Automatically, correspondingly, current will be increased. This will damage the entire winding. 1 second. If you have this doubt, suppose I told one more point here. Sir, if it is getting opened, I told you, what is it? Due to the large amount of flux induced, what is it here? This winding gets large amount of EMF will be damaged. Same question you can ask. Sir, CT, no EMF, no. How the large EMF is coming means large EMF is not in the normal operation. Large EMF is under the mal operation. If it is open, large EMF will be into picture. If it is shorted, large current will be into picture. Why? V2 is same. Resistance was 1 kilo, 2 kilo, 3 kilo, 4 kilo, etc. Suddenly, resistance becomes zero. Same voltage, but resistance becomes zero. Current will be drastically increased or not? Yes, that's why it will be damaged.
Sir, in VA and AV method,
Who is this? Other doubt?
yes, sir, other doubt, sir.
Yeah,
Sir,
tell me.
VA and AV method.
Yeah. Now tell me.
Yes, sir, in AV method, sir. So we have in the denominator IL current, sir. So
Huh?
because sir, voltmeters have high resistance, sir. So can we neglect the IV current, sir?
See, we can neglect. That's what I told you. Yeah. This entire method is for which purpose I told you? For high resistance. It gives the less error. So you can neglect it. That only I'm saying. I'm not saying that you should count this, etc. If I say that, yeah, okay, error is not there. V by I. My topic is just half a minute. Just half a minute. But I need to explain the concept like where the error is there, which must be neglected. Here it is neglected. It is neglected. So that simply voltmeter reading by ammeter, take it. Correct answer. But can I say it is a correct answer? No. What is that? Error will be there. But that error will be very, very small when high resistance is in VA, low resistance is in AV. That only I have taken.
Okay, sir, good. Thank you.
Sir, same. Sir.
Yeah.
అదే సార్ మనకి అంటే అన్నోన్ రెసిస్టెన్స్ మెజర్ చేయడానికి కదా సార్ ఈ బ్రిడ్జెస్ ఇప్పుడు బిఏ మెథడ్ ఏవి మెథడ్ తీసుకుంటాం.
Yeah.
అప్పుడు మనం అంటే ఫస్ట్ అది నియర్లీ 100K ఉందా లేకపోతే నియర్లీ 1K ఉందా అని అలా తెలుస్తుంది సార్ అప్పుడు
See, 1 second. Who is this Sagar? Yeah, here. Sir, if I give you 5, 6, 7, 8, you'll be saying that 7 plus 8 series parallel with 6, series with 5. Sir, how do you know that this is 6 ohm? Sagar,
sir
how do you know that this is 6 ohm?
given
Huh?
they
Come
given
again. Come again.
they have given no sir.
Yeah, same thing. Question they will give you. That's what I told you every time. If it is low value, he will mention. Yeah, I told you, no, our unknown. I told you clearly 3 times. Explained 75K to 80K range is given. Then which method you prefer? If this is not given, don't measure. Sit happily. Don't worry. This is given. This is given. So therefore, this question means you are asking that. So if the question is not given, how do we know that? Are you getting my point or not?
Okay sir.
That's all.
Thank you sir.
Thanks.
Sir?
Yeah.
Sir, bridges mundu problem, sir.
Bridges lo?
Bridges mundu problem. Bridges topic start అయ్యే ముందు problem.
Yeah.
Sir, ఈ problem లో IP క్యాలిక్యులేట్ చేసేటప్పుడు I0 కి IS prime కి యాంగిల్ 90 degrees sir?
No, why 90? Where have taken 90 degrees?
Sir, root over I0 square plus IS prime square తీసుకున్నాం కదా sir, plus 2AB cos theta కూడా ఉంటుంది sir.
No, here simply this and this normal parallelogram law. What we can take here? It is AC not angle. Angle we are not only magnitude we are taking. Only magnitude. See, V is equal to V1 bar plus V2 bar, for example. Otherwise, I'll give you a simple question. Here, VR plus VL bar. How do you write the formula?
Root of VR square plus VL square plus 2VR VL.
No. At an angle of, right, tan inverse VL by VR. Are you clear?
Okay, sir.
Right? Here, we don't know the angle. No, that's why we are separating the angle. This is only magnitude. You are correct only. I told you in the VL equal to root 3 V phase formula. There, V1, V2, V1 square plus V2 square plus 2 V1, V2. Cause of some angle. In this angle is not known. No. So directly, only magnitude, that angle part, separately we are going to take. That's what the point. Simple, yeah? Suppose if I give you VR equal to 3, VL equal to 4. What is supply voltage V?
Sir, 1 second, sir.
VR equal to 3 volt.
Okay.
VL equal to 4 volt. What is supply voltage V?
Root over 3 square plus 4 square.
That only we take. We don't take 2 into 3 into 4 cos, because that is not here also same thing. Right?
Okay. Sir, ఇంకొక డౌట్ సార్, 0.001 ohms అనేసి ఉంది చూడండి సార్. 49.97 మైక్రో ohms వచ్చింది చూడండి సార్ ఆన్సర్.
I'm not getting the resistance question.
Yes sir.
Yeah, tell me.
Sir, nearest 0.01 మైక్రో ohm అంటే ఏంటి సార్? నాకు అది క్లారిటీగా అర్థం కాలేదు.
Means here given value is how much more? 50 micro ohm. This is approximately he has given. Okay, we need to find the value nearest to 0.01 micro, means here 50 plus 0.01, otherwise 50 minus 0.01. In this range you need to find out. Means here, what is that? 49.9 or 50.1. near to this range we need to represent, which is there among this 49.97. That's what the point.
Okay,
Or
without
49.99 like that.
say that's no sir
Zero
answer.
value. Got it?
Yes sir, without calculating we can directly say
Actually we can, but I wanted to explain the procedure. That's why I gave you. In this question, that is okay. Suppose if one more question is given like very near value, then controversy. That's why follow the procedure. But in this question, directly we can answer because only one is there near to that.
okay. Thank you sir.
Right. Next.
Good evening, sir.
Yeah.
Sir, this is Imtiaz.
Yeah, tell me.
Sir, ఒకసారి ఫేజర్ డయాగ్రామ్ చూపిస్తారా సార్?
Which one?
That city. Yes, sir, city.
Yeah.
సార్ దీంట్లో ఏమన్నారంటే I0 0 ఉన్నప్పుడు theta వాల్యూ డిక్రీజ్ అవుతుంది అన్నారు కదా సార్.
I0 0, no. I0 is low, theta value low. I told you. I0 not 0.
ఓకే సార్.
If I0 is 0, theta will be 0.
ఓకే సార్, మేము అంటే ఇప్పుడు I0 ప్లస్ I2 ఫేజర్ నుంచి I1 వచ్చింది కదా సార్.
Yes.
అంటే ఒకవేళ I0 డిక్రీజ్ అయితే అది IM దగ్గర వస్తాయి కదా సార్.
I0 decrease. If I0 get decreased,
if I0 will be decreases, it means it's go towards the IM no sir.
It goes towards
IM, magnetization current.
How?
Sir, the values are decreasing no sir, IM and IC.
IC or yeah, IC decrease means okay, right? Yes.
Means I0 will be goes towards the IM.
Yeah.
At that time, I1 will comes towards the I0 no sir. Decreasing I1, it's changed from present position to down position. At that time, theta value will be increases no sir.
Okay, I will draw that. Let you tell me. I will draw that. We can analyze that. See, this is what is it? 5. This is IM. Okay, right? This is IC. Right, like this, sir. This is I0. Okay, what you are saying? No, IC decreases. You are saying IC decreases.
Then
Right?
I0 will decrease.
I0 will decrease.
Will
Yeah.
decrease. It
Yeah,
goes
but
towards the IM.
One second. This is IC. This is I0. Okay.
Yes sir.
Right. Finally, if IC is 0, I0 will be here, right? Okay.
Yes sir.
IC is 0, IM is I0. Okay.
Yes sir.
But what is my point? You know, not only IC, I0 magnitude directly. That's why be clear. Your point is correct, but you're missing something. This is I0. One case. Second case, I0 decreasing. Third case, I0 decrease. This is what also to be considered. Are you getting?
Oh yes sir, I got it. I'm thinking that it's go towards the IM.
No. It is coming towards this one.
Same
I0
same
magnitude.
position.
You are only shifting the I0 only. You are shifting, but here I0 magnitude we need to. That's why no load current magnitude should be less. Got it?
Okay. Yes sir. Sir, one more problem in yesterday problem. There
Yesterday's
is
problem?
true value. Yes sir. There is a true value and measure value no sir. E
One
of
second.
t and E of min. It's go 0.0444.
This one, right? Yeah.
Sir, I try in 3 type. First, I got measure value of ET is equal to 0.0444 no sir.
Measured value, yeah.
In next measure in true value sir, 0.0448 no sir.
Yeah, got it. Yeah.
I get only after decimal I get 3 values only sir. 0.0444.
The error will be 0, right? That's what your doubt.
And now first one is 0. Next I increase one value. At the time I am getting the answer is 0.71 sir.
Yeah.
And one more I increase 0.81. After that I get 0.81 sir.
Yeah.
In exam we confuse no sir. After
Yeah,
we are habituated to
one second. I got your doubt. In the exam, if these type of questions are given automatically, suppose if you are, see, what is that? You got 0.44, 0.44. Have you got only these two?
No, sir. 0.044 0
Yeah,
14.
zero, yeah, 0. But if
After
you
4 14.
yeah, here 44 and here 08 is there. Okay. How many value you should take? No, see, if whenever 3 digits are same after the simple mathematics only, after the decimal point 3 digits are same, then we need to stand with respect to at least 2 digits. Why? You know, suppose 5 is same, okay, 5.1, 5.2. We cannot differentiate these two properly. That's why at least like this means, suppose 5.1 is there, we cannot say again 1 digit. No, that's why we need to take at least 2 digits. Simple mathematics. 3 digits are same. As the 3 digits are exactly same, after that at least 2 digits give the better result. But that's why you take at least 2. But your thought is correct only, sir. If I take only up to this, I think you
At
are
that
getting
time,
this, right?
0.9. 0.9, sir. Also.
0.9 you are getting. That's
Is
what
there in
here,
option?
yeah, it is there. But always after mathematics only, after 3 digits similar, definitely at least 2 digits, because we should not depend only on 1 digit to get the better result. Simple mathematics.
Okay, sir. This one, sir.
But
Sir, yesterday dynamo problem. You are not
sorry?
sure, sir. Dynamo meter problem. I said in WhatsApp, sir. Question.
Dynamo-meter problem. What's your number? You tell me once.
70137 40.
Enough. 701. Yeah. Energy meter problem you sent it. Same question you sent it.
No, sir. One more. On
Before that. Yeah. Okay. Okay. I have not seen this. I told you to send, right? You said that 0 degrees and all.
Yes, sir. Perfect.
I'll tell you. I have not seen actually. I'll tell you today itself. No problem. Right? Don't worry. Those who have already asked the doubts, can you down your hand so that I can understand who is there? Yeah. Sai Charan?
Hello, sir.
Yeah.
Sir, in today's problem, in one case for magnetizing ampere turns.
Okay. CT/PT question. Yeah. PT
Yes,
question.
sir.
Yes. 1 second. This one. Yes.
Yes, sir.
Yeah.
This one.
Tell
Magnetizing ampere turns. Sir, in this question for magnetizing ampere turns, we took Im into NP, na, sir.
IM. No, I told you I not actually. Even though you can write IM if IC is neglected or not given, etc. No problem. Actually, you can take it, but actually I not you should take. Here I have taken IM. In the next question I have taken I not. That's why I told you I not is the first value. You can take I not. If any problem is there, no problem. You can take here I not also.
So according to question, we can neglect. Na, sir.
That's
according to
that's
question.
definitely, because delta may be given, may not be given, neglected like that. According to the question only, we need to neglect, we need to proceed. That's it. Even if I write I not here, IC is not given, therefore IM is approximately equal to I not. Again, finally, I need to substitute IM only. That's it.
I was confused because in next problem you came up to R
No.
is equals to S into
Yeah.
IC
But
by
here
IC.
I told you one
That's
thing.
why I confused, sir.
Yeah, that's what I told you here, right? I not or IM, you can take anything. But if IC is separately given, then you have to consider it is not given in this, no problem. That's the problem.
Yes, sir.
Got it?
I thought that in another way we can find IC. I thought, sir.
No.
Okay, sir. Thank you, sir.
Any more?
Hello, sir.
Yeah. Hello?
Hello, sir.
Yeah, tell me.
Good evening, sir.
Yeah, good evening, good evening.
Sir, transformer phasor diagram, sir.
Transformer phasor diagram. Yeah. What's your doubt?
Sir, actually, IMU is a magnetizing component, sir. IC is
IMU
working
or IM?
component,
Yeah.
sir. IC
IMU?
working component means
IW, IC.
IW.
Yeah.
ఆ వర్కింగ్ కాంపోనెంట్ అంటే ఐరన్ లాసెస్ ని ఇప్పుడు ఒక
Represent
ట్రాన్స్ఫార్మర్ లో ఐరన్
చేస్తుంది.
లాసెస్ ని
Represent
ఐరన్
చేస్తుంది.
లాసెస్ ని రిప్రజెంట్ చేసింది కదా సార్.
Yeah.
అంటే ఐరన్ లాసెస్ ని రిప్రజెంట్ చేసింది అంటే పవర్ లాస్ కదా సార్.
అవును.
పవర్ లాస్ ఇన్ టర్మ్స్ ఆఫ్ మనం రిప్రజెంట్ చేసేటప్పుడు VI cos phi తో రిప్రజెంట్ చేస్తాం కదా సార్.
VI cos phi ఎప్పుడు
VI cos
AVI చేస్తున్నారు, AI చేస్తున్నారు. అది కూడా ఇంపార్టెంట్ ఇక్కడ. VI cos phi
అప్లై చేసిన
I square R తో కూడా చేయొచ్చు.
సార్ నేను VI cos phi తో చేద్దామని డిసైడ్ అయ్యాను సార్.
ఓకే.
VI cos phi. ఇప్పుడు మనకి IC దగ్గర వాల్యూ మనకేం వచ్చింది సార్ ఇక్కడ I0 into sin alpha వచ్చింది.
IC కూడా I0 into sin alpha.
అంటే ఇప్పుడు నాకు V into I VI వేస్తే I0 V into I0 into sin cos alpha రావాలి కదా సార్. sin alpha ఎలా వస్తుంది సార్ ఇక్కడ? యాక్చువల్లీ ఇక్కడ ఆల్ఫా అనేది మీరు ఇక్కడ నో లోడ్ పవర్ ఫ్యాక్టర్ యాంగిల్ అన్నారు కదా సార్.
నో లోడ్ పవర్ ఫ్యాక్టర్ యాంగిల్ అనలేదండి నేను. నో లోడ్ యాంగిల్ అన్నాను. పవర్ ఫ్యాక్టర్ యాంగిల్ ఇక్కడ వస్తుంది. ఇది మిస్ అయ్యేది ఇది. ఇక్కడ వస్తుంది. ఇది ఇక్కడ VP వస్తుంది, V1 వస్తుంది. ఇది
ఇప్పుడు మనకి ఆల్ఫా ఎలా ఇప్పుడు క్వశ్చన్ అడిగితే మనకి ఆల్ఫా ఏమని రిప్రజెంట్ చేస్తారు సార్ అక్కడ?
నో లోడ్ యాంగిల్ అంటారు అంతే.
నో లోడ్ యాంగిల్ అంటారా సార్?
అంతే. నో లోడ్ ఇంపెడెన్స్ యాంగిల్, నో లోడ్ కరెంట్ యాంగిల్ అంటారు. గుడ్ క్వశ్చన్. ఇది 5 అండి, ఇది 5. బట్ మనకి ఇక్కడ అవసరం లేదు 5 ఇండికేట్ చేయలేదు అంతే.
ఓకే సార్.
Got it? Yes, very nice question.
Sir, another doubt, sir.
Who is this? Same. Tell me.
Same person.
Hello.
In the dial box resistance.
Huh?
Dial box resistance, DC Crompton matter.
Yeah. Tell me.
If dial box resistance, ఒకసారి ఓపెన్ చేయండి సార్ అది.
Yeah. ఇదా?
ఫర్ సప్ ఇంకో ఇది కాదు సార్, మామూలుగా డయాగ్రామ్ ఇచ్చి ఒక క్వశ్చన్ సార్. ఫర్ సపోజ్ ఇది డయాగ్రామ్ ఇవ్వలేదు సార్.
డయాగ్రామ్ ఇవ్వలేదు దీనికి. దీని డయాగ్రామ్ ఇవ్వలేదు.
దీనికి కాదు సార్, తర్వాత క్వశ్చన్. నెక్స్ట్ క్వశ్చన్ సార్.
దీనికి డయాగ్రామ్ ఇవ్వలేదు
సార్. ఒక డయాగ్రామ్ ఇచ్చారు చూడండి సార్, రెసిస్టెన్సెస్ 15 పెట్టి 11th పొజిషన్ దగ్గర సార్. దీనికి ఫర్ సపోజ్ డయాగ్రామ్ ఇవ్వలేదు సార్. డయాగ్రామ్ ఇవ్వకపోతే ఇప్పుడు నేను ఫర్ సపోజ్ 0 పొజిషన్ లెఫ్ట్ సైడ్ ఉంది అనుకోని 15th పొజిషన్ రైట్ సైడ్ ఉంది అనుకుంటే
0 పొజిషన్ అలా అనుకోదని నేను చెప్పింది. అలా అనుకోదని నేను చెప్పింది. ఓకే, మీరు 0 పొజిషన్ ఇక్కడ ఉంది అనుకుని నాకు అర్థమైపోయింది. చూడండి 15 పొజిషన్ ఇక్కడ తీసుకున్నా సరే మీరు ఎక్కడ కనెక్ట్ చేస్తున్నారు చూడండి. 0 1 2 3 4 5 6 ఇలా తీసుకున్నాను అనుకోండి.
11th పొజిషన్ ఇక్కడ వస్తుంది సార్.
అయితే నేను ఏమని చెప్పాను అక్కడ, మనకి ఈ రెండింటి మధ్యలో కావాలి కాబట్టి నేను క్లాస్ చెప్పేటప్పుడు చెప్పాను ఇక్కడ రివర్స్ లో తీసుకుంటాము, ఇక్కడ ఇలా తీసుకోవాలి. దాన్ని మనం
అదే సార్ పర్టికులర్ నాకు అర్థమైంది సార్ మీరు చెప్పింది. ఇప్పుడు ఫర్ సపోజ్ నేను ఇలా తీసుకుంటే అప్పుడు రెసిస్టెన్స్ వాల్యూ వేరీ అయిపోతుంది కదా.
నేను ఏమంటున్నాను, ప్రొసీజర్ ఏమని చెప్పాను, అలా తీసుకోమన్నా ఇలాగని తీసుకొచ్చాను.
రివర్స్ లో తీసుకోమన్నారు. ఎక్కడ ఇలా తీసుకుంటే ఇక్కడ 0 నుంచి 15 దాకా పెట్టమన్నారు.
నేను ఏమన్నాను ఒక్కసారి జాగ్రత్తగా. ఇలా తీసుకుంటే డెఫినెట్ గా రివర్స్ అయిపోతుంది. కాకపోతే అదే చెప్తున్నాను, ఈ క్రాంప్టన్ ఏదైతే ఉందో డయల్ బాక్స్ ఏదైతే ఉందో అది ఎలా తీసుకోమన్నాను, లెఫ్ట్ టు రైట్ తీసుకోమన్నా, రైట్ టు లెఫ్ట్ తీసుకోమన్నా. నేను ప్రొసీజర్ లో ఎలా తీసుకోమని చెప్పాను. క్వశ్చన్ చెప్పలేదు నేను నిన్న, అంటే నేను కాన్సెప్ట్
చెప్పేటప్పుడు సార్
ఏమని చెప్పాను.
కాన్సెప్ట్ చెప్పేటప్పుడు రివర్స్ ఆర్డర్ రెసిస్టెన్స్ కి స్లైడ్ వైర్ కి రివర్స్ లో కనెక్ట్ చేసుకోమన్నారు సార్.
రివర్స్ తీసుకోమని అదే రివర్స్ తీసుకోండి. మరి మళ్ళీ దాన్ని మళ్ళీ రివర్స్ ఎందుకు చేస్తున్నారు
అంటే డౌట్ వచ్చింది సార్. ఒకవేళ బై మిస్టేక్ మర్చిపోయి ఇప్పుడు ఫర్ సపోజ్ అలా కనెక్ట్ చేస్తే వాల్యూ
అదే చెప్తున్నానండి, మర్చిపోతే రాంగ్ వస్తాయి కదా ఎట్లయినా
సార్.
అర్థమైంది కదా, అందుకని అది ఆ డౌట్ వస్తేనే నేను స్పెషల్ గా మెన్షన్ చేసి దీన్ని రివర్స్ గా తీసుకోవాలి. లేకపోతే డెఫినెట్ ఇప్పుడు 150 ఉందండి, 9th క్వశ్చన్ తీసుకుంటే ఇలా తీసుకుంటే 60, ఇలా తీసుకుంటే 90 వస్తుంది కదా, అందుకనే ఈ రైట్స్ నుంచి తీసుకోవాలి. అందుకని పాయింట్ క్లియర్ గా మెన్షన్, ఎందుకంటే ఇది జనరల్ గా వచ్చే డౌట్ అందరికి, సార్ లెఫ్ట్ తీసుకోకూడదు, అదే పాయింట్ అక్కడ.
అదే స్పెసిఫిక్ రీజన్ ఏమైనా ఉందా సార్ అలా తీసుకోకూడదు అనుకోవడానికి?
అదే అంటున్నాను
అంటే
ఇప్పుడు
మెన్షన్ చేస్తుంటారు కదా సార్ ఏదో ఒకటి థియరీ పరంగా, ఇలా తీసుకుంటే.
అది థియరీని అదే చెప్తున్నాను, బ్లైండ్ గా చెప్పలేదు నేను. మనకి రిఫరెన్స్ ఏది కావాలి, ఈ మధ్యలో ఉన్న రెసిస్టెన్స్ కావాలి, ఈ మధ్యలో ఉన్న రెసిస్టెన్స్ కావాలి అనుకున్నప్పుడు ఇదేమో ఇక్కడ తీసుకున్నాము, ఇలా తీసుకుంటే 0 1 2 3 ఇలా కౌంట్ చేయొచ్చు. కానీ ఇలా తీసుకున్నాం అనుకోండి 15 14 13 12 11 అట్లా కౌంట్ చేసేవానికి వాల్యూ పర్ఫెక్ట్ గా రాదు కదా. అందుకని మన రిఫరెన్స్ ఏది, ఈ మధ్యలో పాయింట్ ఎక్కడైతే జాయిన్ చేసినామో జాయిన్ చేసి ఇటు సైడ్ 1 2 3 వెళ్ళాలి, ఇటు సైడ్ కూడా 1 2 3 లాగా వెళ్ళాలి, అది పాయింట్, అదే కాన్సెప్ట్.
ఓకే సార్, అనదర్ డౌట్ సార్. నామినల్ రేషియో అండ్ టర్న్స్ రేషియో, ట్రాన్స్ఫర్మేషన్ రేషియో. మామూలుగా ట్రాన్స్ఫార్మర్స్ లో టర్న్స్ రేషియో అంటే N1/N2 తీసుకుంటాం, ప్రైమరీ టర్న్స్ బై సెకండరీ టర్న్స్ తీసుకుంటాం కదా సార్.
అవునా?
సార్
నో,
ట్రాన్స్ఫర్మేషన్ రేషియో అంటే N2 సెకండరీ టర్న్స్ బై ప్రైమరీ టర్న్స్, ప్రైమరీ కరెంట్ బై సెకండరీ కరెంట్.
మీరు అలా డిఫైన్ చేస్తే ఓకే ఓకే, K = N2/N1,
సార్
N = N1/N2 తీసుకుంటాం. అయితే
ఓకే సార్, ఇక్కడ ఇప్పుడు K = N2/N1.
అది ఇదేం ట్రాన్స్ఫార్మర్?
పవర్ ట్రాన్స్ఫార్మర్ సార్.
మన ఏ ట్రాన్స్ఫార్మర్
సార్? అదే సార్, కంపేర్ చేస్తుంటే డిఫరెంట్ మారిపోతుంది సార్ అనాలిసిస్.
డిఫరెంట్ గా మారుతుంది కదా, దాని అప్లికేషన్ ఏంటి, పవర్ ట్రాన్స్ఫర్ అప్లికేషన్ ఏంటి?
సేమ్ పవర్ ని
పవర్ ట్రాన్స్ఫర్ సింపుల్, మీరు ఎక్కడ మిస్ అవుతున్నారో చెప్తాను. అంటే ఎప్పుడు గుర్తుపెట్టుకోండి, ఇది జనరల్ గా వచ్చే డౌట్స్ అందరికి, బట్ ఏంటంటే జాగ్రత్త చూడండి. ఇప్పుడు ట్రాన్స్ఫార్మర్ ఎలా కనెక్ట్ చేస్తారని లైన్ ఇలా వచ్చింది, లైన్ ఇలా వచ్చింది, లైన్ ఇలా ఉంది. మన పవర్ ట్రాన్స్ఫార్మర్ ని ఇలా కనెక్ట్ చేస్తుంది, అవునా? ఇలా కనెక్ట్ చేస్తాం. కానీ మనం సిటిపిటి ఎలా కనెక్ట్ చేస్తాము? సిటిపిటి ఎలా కనెక్ట్ చేస్తామండి? ఇలా ప్యారలల్ లో ఇలా తీసుకుని ఇక్కడ ఇలా తీసుకున్నాం. అంటే డెఫినెట్ గా అప్లికేషన్ డిఫరెన్స్ అయింది, కన్స్ట్రక్షన్ కనెక్షన్ డిఫరెంట్ ఉంది, మెయిన్ ఆపరేషన్ డిఫరెంట్ ఉన్నప్పుడు రెండింటి సేమ్ ఎలా ఉండాలనుకుంటాం. అర్థమైందా?
అంటే అక్కడ థియరీ పరంగా ఈక్వేషన్స్ కూడా టాలీ అవుతుంది సార్. పవర్ సేమ్ ట్రాన్స్ఫర్ అవ్వాలి కాబట్టి.
ఎక్కడ పవర్ సేమ్ ట్రాన్స్ఫర్ అవ్వాలి? పవర్ ట్రాన్స్ఫార్మర్ లో
V1 I1 = V2 I2.
అవును,
దట్ ఈస్ నథింగ్ బట్ V2/V1 = I1/I2.
yes definitely yes.
అది థియరీ పరంగా చూసుకున్నా కానీ అది సాటిస్ఫై అవుతుంది సార్.
అవుతుంది, అవును.
కానీ ఇక్కడ థియరీ
అదే ఇక్కడ సాటిస్ఫై, అదే ఒక్క నిమిషం, అది ఇక్కడ సాటిస్ఫై అవుతుంది. ఎందుకంటే మీరు ఏం తీసుకున్నారు, కాన్స్టెంట్ పవర్ ఇక్కడ ఎందుకు అప్లై చేస్తున్నారు మీరు? ఇక్కడ సిటీలో పీఈటీలో కాన్స్టెంట్ పవర్ ఎట్లా అప్లై చేస్తారు మీరు? అర్థమైందా? అక్కడ మీరు మిస్ అవుతున్నారు. ఇప్పుడు సిటీలో పీఈటీలో పవర్ ట్రాన్స్ఫరింగ్ లేదు, కాన్స్టెంట్ పవర్ కాన్సెప్ట్ లేదు కదా.
కాన్స్టెంట్ పవర్ కాన్సెప్ట్ లేదు సార్. కానీ అంటే ఇప్పుడు ప్రైమరీ యాక్చువల్ రేషియో ఆర్ ట్రాన్స్ఫర్మేషన్ రేషియో = ప్రైమరీ కరెంట్ బై సెకండరీ కరెంట్,
అవును,
లేదా ప్రైమరీ వోల్టేజ్ బై సెకండరీ వోల్టేజ్. అది ఏదో ఒక థియరీని బేస్ చేసుకుని ఇచ్చి ఉంటారు కదా సార్. బ్లైండ్ గా
చెప్పిన థియరీని బట్టి చెప్పాను నేను. ఎలా అంటే ప్రైమరీ కరెంట్ నుంచి సెకండరీ కరెంట్ కి ఎంత కరెంట్ చేంజ్ అవుతుంది, ఎంత వోల్టేజ్ చేంజ్ అవుతుంది, దాన్ని ట్రాన్స్ఫర్మేషన్ రేషియో అంటారని చెప్పాను. బ్లైండ్ ఇవ్వలేదు కదా. ప్రైమరీలో ఐపీ ఉంది, ఆ కరెంట్ సెకండరీ కి ఎంత తగ్గిపోతుంది, ప్రైమరీలో లార్జ్ వోల్టేజ్ ఉంది, సెకండరీ కి ఎలా తగ్గిపోతుంది, టర్న్స్ ని బట్టి. అదేం చెప్పాను కదా, అదే పాయింట్. అందుకని క్లారిటీగా చెప్పాను నేను. ఏంటంటే సిటీ స్టెప్ అప్ అన్నారు అందరూ. ఎందుకు స్టెప్ అప్ అంటే అందరూ మాక్సిమం కొందరు ఏమి ఇచ్చారంటే, సార్ కరెంట్ తగ్గిపోయింది కాబట్టి స్టెప్ అప్ కాదు, కరెంట్ తగ్గిపోయింది కాబట్టి స్టెప్ అప్ కాదు, ఇక్కడ టర్న్స్ ఇంక్రీజ్ అయినాయి కాబట్టి. అది మీరు మీ మిషన్స్ లో అనుకోండి, వోల్టేజ్ పైన చెప్పొచ్చు, కరెంట్ పైన చెప్పొచ్చు, టర్న్స్ పైన చెప్పండి. ఇక్కడ మాత్రం టర్న్స్ పైన చెప్పాలి, ఎందుకంటే అది పాయింట్.
సిటీపీటీ డిఫరెన్స్ వచ్చేసరికి ఓన్లీ టర్న్స్ బేస్ మీద చెప్పాలి సార్.
డెఫినెట్ గా, ఎందుకంటే మనకి సింపుల్ లాజిక్ అండి, పవర్ లేదు కదా మనకు. అది రైట్, ఓకే, అది
అర్థం, అది క్లారిటీ సార్ నాకు. అది నేను అదే డౌట్ వచ్చింది అంటే. సార్
మీరు ఏ ఇయర్ అండి?
ఫస్ట్ డౌట్ సార్.
ఓకే, ఎక్కడ కాలేజ్? జస్ట్ ఊరికి అడుగుతున్నాను, డోంట్ మైండ్.
ఏపీ సార్.
ఏపీ, ఓకే. కాలేజ్ నేమ్?
VVIT. వాసిరెడ్డి వెంకటాద్రి ఇన్స్టిట్యూట్.
ఓకే ఓకే ఇలాగే ప్రిపేర్ అవ్వండి. మీరు మంచి క్వశ్చన్స్ అడిగారు. ఇలాగే ఉండాలి థాట్ ఎప్పుడు కూడా.
ఓకే సార్.
రైట్.
ఓకే
అందుకే అడుగుతున్నాను.
థ్యాంక్ యూ సార్.
హలో సార్.
సాయి చరణ్ చెప్పండి.
Sir, in page number 11, sir. I forgot to ask that down, sir. Sir, in this, if the dial box resistance and the slide wire resistance are kept to maximum, then both should be in series with additive, and resultant resistance should be addition of both resistance, no, sir?
Repeat that.
In this, we should analyze. We should visualize like if both the resistance are kept to its maximum level.
One second. So you are saying like this. Yeah. Tell me.
Sir, instead of analyzing like left to right or right to left, we should analyze like if both are kept to its maximum, then both should be additive, and the resultant resistance should be addition of both the slide wire and the dial box resistance, no, sir?
That only I told you, no? Total resistance kept in the dial box and total resistance of the slide wire will be added from A to B. In my expression, this is AB. From A to B, total resistance should be always additive, definitely. Okay then.
So if you want to memorize like standard procedure, the dial box resistance should be from right to left, and the slide resistance should be left to right, no, sir?
That's what.
Standard.
Right.
Okay, sir. Thank you, sir.
Any more? Okay then. Tomorrow we'll meet. Thank you.